So the first type of application that we're going to look at is, I think, the most straightforward one and the easiest to understand, which is just called, I'd call it content generation. And I kind of divided this into two things. I like to call one transactional and the other one is conversational. A transactional content generation, I think, is the simplest way to get started with anything related to large language models is when you have a prompt, a question, a sentence, a statement, you send it to the LLM responds, and that's it. And you save that response, display that response, store it, it doesn't really matter. Okay, so there's not going to be an actual sort of back and forth conversation that you would do with a chatbot, for example. It's just literally, here's my prompt, I send it to you, give me a response, and then you're done, okay? A conversational content generation, on the other hand, is when you have an actual conversation with the large language model, right? So a typical, chatbot example where you say, hello, language model, and it responds, hello, what can I do for you? And then you ask a question, it responds, and you send a follow-up question, when you have a back and forth conversation. Okay, so these are the two examples that we're going to take a look at first. And from the code perspective, both a transactional content generation and this conversational content generation has two options. You can either stream the response back from the LLM, or you can get the non-streamed version. So the non-streamed version is when you send you send your prompt to the LLM, and your application or your UI is not going to do anything until the entire response is received from the large language model, and then you just print it. From a usability perspective, that's not the best. So that's why, the Gemini SDK offers you a streaming version as well, which basically going to stream the response back as it comes back from the large language model. So it's exactly the same experience that you get when you actually go and talk to, you go to gemini.google.com and then you talk to it and then you get the response and you kind of see the response being streamed back to you. Okay, but these are supported from the SDK as well. Then there's something that we need to talk about as well, which is the history. History management becomes relevant in some other use cases as well, but you need to make sure that you maintain a history, especially if it's a conversational content generation type of thing. So you're building a chatbot, you need to make sure that you manage the history of that conversation. Okay, so the history means, so without the history, you say something to the model, it sends you a response, then you send a follow-up question. Without history, it doesn't know what you talked about so far. Okay, whereas if you maintain the history, it will know exactly what you talked about before. I'll show you the code later on, but basically, so what I'm showing here as well, just to clarify, is a very simple history management, which is, it's just through an array called history. If you're building a real production system, you would probably have to store this history in a database, because what if that user comes back, you want to pull that information up again about the previous conversation, et cetera, et cetera, et cetera. Okay, so this is the simplest way of doing that. It's also very important to know that when you add items to that history array, and when you're talking to the Gemini models, there are two roles that Gemini supports. It's either user or model. So any message that the user sends must be categorized as user. Any response that you want to store in the history of that conversation should be categorized as model. Okay, these are only the two type of things that you can use in Gemini. Also, if you try to use anything else and you happen to use TypeScript, the Gemini SDK is going to yell at you saying, no, the role can only be user or model. So anything that the user inputs is the user role, anything that the model responds with, including function calls, whatever else, which we'll take a look at, must be labeled as model, okay? This is how it looks like. I'm not a fan of this, but it is what it is. So this is an object that you need to send or need to append to that history array. So you say role, user or model, parts, text, and then user input, okay? Don't ask me why it's like that, but that's how the schema looks like. Okay, so we have 1, 2, 3, 4, 5 examples to start with. So we're going to start with the very, very first one, npm run prompt. I'm going to show you the code for that. It's literally 12 lines of code. So the package, and this is also a little bit confusing, especially if you've been following what Gemini is doing. This is the add Google / GenAI SDK is the latest one. And that's the one that you're supposed to use. Before, I think it was add Google / Generative -AI. Some of you may use that before. That is deprecated, and it will not be, basically, they're not updating it anymore. Okay, so the one is add Google / Gemini. So what we do is install that package, import Google GenAI, then we create a new Google GenAI instance. We pass the API key, so that's the API key that you need from Gemini. Then we create a prompt, which is what is Star Wars, and then all you need to do is await GenAI models, and notice the method here that we use, generate content. Generate content must have at least these two parameters added to it, or options added to it, model, which is the model that you want to talk to. In this case, we're going to talk to Gemini 2.0 Flash, but this could be Gemini 2.0 Pro or whatever other model you want. And then contents is the actual prompt. Okay, so you need to provide it with a content, and the content in our case is just going to be the prompt. So what we're saying here is, hey, Gemini 2.0 Flash, can you answer the question, what is Star Wars? And then all we need to do is grab response.txt. And we're just going to console log that out. Okay, so npm, oh no, this is the wrong folder. npm run prompt. Okay, so we send the question, and notice we're not streaming, right? And that's the problem with streaming, is that now we have to wait for this entire content to come back, and here's the response. Okay? And you can now change that prompt to say whatever else you want it to do, and you can test it. Does this make sense? This is, so far, hopefully fine. Easiest example. Any questions? Okay. Now, exactly the same, but with streaming. So the only difference, well, there are two differences, really. First one is, instead of using generate content, we now use generate content stream, indicating that we want to have the streaming method. And because we're streaming, we can't just do console log. We have to basically iterate through the chunks that come back as part of the response. And then we're just going to print out the text from those chunks as they come in, using this for await loop. Okay, that's the only difference. But you will see that from the prompt stream, you will see that the experience is going to be different, right? Because now, as the model generates the content, it comes back sort of, in these chunks, right? So we don't have to sit there and wait for stuff to come back. We see stuff as it's being generated by the LLM. Okay, so that's really the two differences. Okay, what's the next one? Okay, npm run chat. Let's look at the code as well real quick. So that's chat. Okay, so this one, setup is the same, except now, instead of saying, GenAI.models.generate content or generate content stream, we say GenAI.chats.create. So the first thing that we do is we create a chat variable, and we say, here's the history, here's the model that we want to use, and then, let's just focus on this, we use this line to then send a message to that chat. And what the message is going to be the user input that we read from the command line in this case. Okay, it doesn't really matter what that is. And then again, to print out the response from the LLM, we say console.log response.txt. Okay, so again, very, very simple. npm run chat. Okay, so here's a message, we say hi, and then the model is going to say, hi there, how can I help you today? My name is Tamas. Okay, and we know that it auto-manages the history for us. This is, by the way, if you ever want to know, whether the chatbot has a history, what you do is you send a message and you say something like, hi, my name is X. And it says, it responds with something, and then as a follow-up, you say, what's my name? If it does this, then you know it remembers the history. If it says something like, oh, I don't have access to your personal information, then you know that the history is not maintained. Okay, and then you need to, well, if it's something that you build, then you have to look into why that is, et cetera, et cetera, et cetera. Okay, and this is now, going to go on as long as, like, this conversation will go on as long as I have this session open. Okay? Does this make sense? All right. Chat stream, same setup. The difference again here is that we have send the message stream, and then instead of console log, we now print out the chunks. That's just how we've done it before. Okay, so exactly the same stuff, but with streamed messages when chatting to the model. So chat stream, write a long paragraph. Okay, and now you will see that it streams out the response, whatever the response may be. Okay? That's it. Now, in this case, actually, let me... Hi, my name is... I can't remember if this... Out of the box... Okay, so before, for whatever reason, when you use this in the old SDK, when you use the chat stream method, it didn't remember the history of the conversation. With the new SDK, it does. Okay, so that means that my code here, called chat with history, is kind of irrelevant anymore because it now remembers the history out of the box. But still, we can take a look at this. So what I'm doing here is I'm actually creating a history array where I pretend that there was an input from the user. My name is Tamas and I love Star Wars, in particular The Empire Strikes Back, whatever. The model, I also have to generate a model's response, which is just, hey, thank you, or nice to meet you, whatever it is. And then I pass, hello? And I pass this history array to the create method. So when I create the chat itself, oops, here. And what that means, actually we can try that. What that means is that when I start the chat, npm run chat with history. So if I the first thing I ask, who am I, it's going to know who I am because it's in that history, right? It's been hard-coded in its history, so it should say, you're Tamas, and you like, it basically says everything that I said in the very first message, right? Whereas if you try this with anything else, who am I? In any of the other examples, it should say like, how do you want me to, like, how should it know? Like, it has no idea, right? So it will say, oh, I don't know who you are. I obviously don't know anything about you personally. Imagine it would say something like, oh, you're Tamas, you're in Indonesia now, like, what? Okay, so does this make sense? These are, really simple examples. This one is the most complex one with the chat history purely because there's this, I don't know, extra 10 lines of code here, but everything else here is the same. Now, what I'm also showing here are very, very simplified examples because I want to focus on these methods and the SDK, not the overall like UI and implementation of all of this. And I'm just using, process.standardout.write to print out the response. But basically how this would work in a real scenario is that you create, I don't know, a server of some sort with some API endpoints that can handle these chat messages, and then you send these back to the UI, right? You would have to set that up. Okay, but these are just the bare minimum examples that I'm showing you today. If there's more time, I can show you a few samples of like an actual, I don't know, Next.js UI or an Angular UI talking to these backends. But this is content generation. I think this is, this is very, very easy. One thing, let me show this to you as well. So let's go with the chat stream, because I think it's not in my slides, but I think it's worth talking about for a moment. So when, I think it's, wait, is it, yes. Okay, so every time when you tell Gemini, or using Gemini SDK, you say, this is the model I want to use, whether it's content generation or this chat, you can pass a configuration object. And we're going to take a look at a lot of options for this, but the one that I think I mistakenly not mentioned in my slides is system instruction. System instruction is basically you telling the model how it should behave. Okay, so you can give the model a personality. You can give the model a sense of how it should behave. Okay, so for example, a system instruction, often you would see this to say, come on. Often you would see this to say something like, oh, you're a helpful assistant, or that's like the most classic example. Like, you're a helpful assistant and you're going to help me with my booking of my flights or whatever it is. But you can really give it some fun personality. So just, you are Yoda. I didn't ask, but Star Wars fans? Yes. No? Star Trek? Star Trek fans, the door's that way? No, I'm kidding. Okay, but we all know, or at least hopefully 90% of you know who Yoda is, right? So, the green little, okay. So I'm telling the model that you're Yoda. And now, was that the stream one, right? So npm run chat stream. Let's run this again. Hi, how are you? And now he's going to respond in the style of Yoda, right? So if you know how Yoda speaks, like, the field of food, like that's how Yoda speaks. Like that's the way, it's like, it's like weird English, but that's how Yoda speaks. And now, no matter what, no matter what we ask the model to do, it's going to pretend that it's Yoda, okay? And it's going to give either Yoda references to the Force, to Star, whatever. Okay, but I gave the model a personality, okay, which is quite cool. But obviously the system instruction is fun to use this way, but more important, the system instructions are really how you want the model to behave, what you want the model to do. For example, in a system where, we won't look into it, but in a RAG system where you basically give the model your own knowledge base, the system instructions should be something along the lines of, you are, I don't know, you are a helpful assistant, and your entire knowledge base is these PDF documents that I'm going to give you. Only look for information within those PDF documents. If you can't find that information, just respond with, I don't know. And you're now restricting and limiting the model to, every time when you ask a question, it should use the 1 or 3 or 100 PDF documents or databases or whatever you gave access to it to answer your question. But it's important to set that up as part of the system instruction. Okay, does that make sense? Okay. So, next, model parameters. So let me just go to, what is it, AI Studio, the google.com. So if you ever on AI Studio here, you may have noticed things like token count, temperature, structured output, code execution, function calling, grounding, advanced settings, safety settings, TOP, all these settings. So what we're going to do next is go through these, because I want you to know what these are, what they do, okay, before you even open AI Studio. If you've opened AI Studio and you ever wondered what those are, then hopefully the next 20 minutes or so will help you understand that. So, models. So models take parameter values that basically control their behavior and how they work and what they do and how they generate content, okay? And there's no shortage of parameters. So first, let's start with this thing called token count. So in this example, Gemini 2.0 Flight 001 has 1 million input token limit and 8,192 output token limits. Every single model out there would have different values. So if you want to work with a model, and I'll explain to you what this token count is, but basically every time when you work with a model, have a look at how many input tokens it can have or it can take and how many output tokens it can generate. Now, what does this mean? It means that I can send 1 million-ish input tokens. So I can, whatever input I'm sending to the model, whether that's text or text extracted from PDFs or whatever it is, it can take, hello, this is back? Okay, it can take up to 1 million input tokens. Now, I'm probably wondering what is a token. We'll get there in just a second. And more importantly, the output token limit is how much, effectively how much text it can output. Okay, so 8,192 tokens is equal to maybe 6,000 words or so. I think, or is it more? Whatever. So it's equal to X amount of words, which means that if you go above that, it means that you won't get the full response back from the model. It's literally going to have a cutoff point at some points. It may be middle of the sentence, middle of a word, whatever it is. The other important thing to remember here is that if you're having a conversation, so you're building a chatbot, the input token limit is given. So let's simplify this, right? Let's say that your input token limit for the model that you use is 100 tokens, okay? You have a user that comes in and starts talking to your chatbot. They say something, it's going to be 30 tokens, okay? So we send 30 tokens, then the model is going to respond with, let's say, 40 tokens. That's 70 tokens in total, and your token limit is 100. So if the user now sends 40 tokens, the model will lose access to the first 10. Does that make sense? So the input token limit, especially when you manage and maintain history, is going to take every single word, every single token in the conversation history into consideration. Okay? Now, it doesn't matter. Wait, I have more on. Where did that go? Where's that slide? Hello, slide. Huh, okay, it's fine. So how do you circumvent that? That's the question. So what you do and what, Gemini, in the UI, what they do, because the most important thing to remember is that, and I don't know if you ever experienced this before, you have a very lengthy conversation with a model, and you send it lots of code or whatever, and then you ask questions, and you feel that it doesn't know what you talked about before. Like it kind of almost it forgot. That's because they maintain this token limit dynamically. So whatever was sent, I don't know, 10 minutes ago, and now it's outside this 1 million token limit, it just doesn't know, just doesn't remember. So what you need to do, and what most of these interfaces that you use online do, is when they are close to the token limit, I mean, it depends which one you use, right? So for example, another company that shall not be mentioned actually sends you a warning that says, hey, you're close to your maximum token limit. It would be worth it to start a new chat. Okay, and then they just offer you to start a brand new chat, which then resets the entire token limit, and then you can start a conversation. A more sophisticated system, what they do, and this is where I think is genuinely very interesting, is when they are close to the token limit, they take the entire conversation history, they pass it to a large language model and say, generate a summary of the conversation so far, and then they store that summary. So that every time when you need to re-instantiate the conversation, they load that summary into the history, minimizing the token count, because it's now just a summary of that entire conversation, but it still remembers what happened, and it can continue the conversation without going outside this token limit. Okay, so that's one idea. Another idea is, they would also store that summary in the database. There's another, I just have to say it at some point, so OpenAI, I said it. So they also have memory management, which is they build up a memory of all the conversations that you have. Okay, so even if you start a brand new conversation, you can ask things that you said in any of your conversations before, and it will know what you talked about. But this means that you have to do a lot of stuff in the back end, right? You have to create the summaries of those conversations, store them in a database, unify them, whatever. Every time when there's a new chat, if someone is logged in, you need to load that summary of that person into that chat. Probably they load it into a system instruction saying like, hey, this is the user, this is what has been discussed so far, this is his style, whatever. And when you start talking to the model, you don't need to like re-explain yourself, or you can just reference things like, oh, you remember this thing we did last week? And it will say, oh yeah, I do. Here's what we talked about, right? So but that's a lot of like manual labor that you as a developer would have to do, okay? But what's important is these token limits, right? So again, long story short, every time you work with a model, check the input token limit, check the output token limit, the number of tokens it can generate, and just be mindful of this thing where if you go outside that token limit, it will lose context, it will lose sort of like, it's like dementia for the model, if you will. So token. There are two URLs there, which basically, we can actually open this one, I think, because that will help. So this one is a sort of like a token visualizer kind of thing, where we can select the model, it doesn't matter, so let's go with Gemini. I don't know which Gemini that is. And then you put in your text, and then it's going to show you the tokens for the text. Okay, so hi, my name is Tamas. As far as the number of tokens are concerned, this equals to 5 tokens. Okay, and this is also important because sometimes LLMs charge you per token or token usage. So you say, oh, I'm going to be charged 3 cents per token. What does that mean? This would be 5 times 3 cents in that example. Okay, generally speaking, 100 tokens is about 60 to 80 English words, give or take. Simpler English words would be equal to 1 token. More complex English words would be equal to multiple tokens. So like, I don't know, happy, I guess that would be 1 token. But things like I can't even spell that, serendipity. Is that how you, serendipity. Okay, this should be, you see, this is like, for whatever reason, 3, oh, please, I probably put a space, whatever. So it's 2 tokens. Okay, so like the more complex, I don't know how tokenization exactly works, but the more complex the word is, the more tokens that's going to be. But as a general rule of thumb, 100 tokens, about 60 to 80 English words. Okay, that's just FYI. All right, next setting, temperature. So temperature is a control mechanism for creativity for the model. Different models accept different parameters. So for example, in this case, they are exactly the same, but Gemini 1.5 and 2.0, the temperature setting can go from 0 to 2, and I think one defaults to 1, the other one defaults to 0.7, although you can change this in your code very, very easily. But what does this mean? What is the temperature 0? What is the temperature 1? What is the temperature 2? Or any number in between. So it can be 0, 0.1, 0.2, 2, 1, 1.2, 1.2, up until 2. So here's an example. This is a conceptual example, just to give you an idea. So you ask the model, what is the capital of Italy? With a low temperature, with a 0 temperature, it's going to say Rome. You ask the question, here's your answer, great. With a higher temperature, so 0.8, and remember, this is the control mechanism for creativity. So we notch it up a little bit, and it's going to say, well, Rome, the eternal city. Okay, cool. 1.2 is going to say Rome is the capital of Italy, known for its ancient history and landmarks like the Colosseum. It's like it's getting like, hoo-hoo, I'll show you what I know about Rome as well. And then at a very high temperature, now, what's really interesting, at very high temperatures, some models, they don't actually output English text. They will literally just output like weird random tokens, right? So you have to be very careful. But it could do something like, again, this is just hypothetical, it could do something like, what is the capital of Italy? Temperature 1.6. Rome, though Florence could claim the title for its art and culture. It's like, I didn't ask that, did I? But it's like, I'm just creative now, right? So what does that mean? In terms of like use cases and stuff, right? So generally speaking, lower temperatures, so the closer the temperature is to 0, the more factual and basically less creative the model is going to be. So it's ideal for things like factual answers and summaries. So imagine you have a 1-page PDF document and you want to get a summary of that from the LLM. You really don't want the LLM to be creative, because if it's creative, it may change some of the intended meaning in that PDF document when it generates a summary, right? So for summaries, something that you really want it to be factual, you have to, or you should, have a low temperature value. Higher temperature value, 1 or thereabouts or even higher, is good when you need to do some creative work. You want to do brainstorming, idea generation, right? When you really want the model to be creative as well. That's when you would use that. Hopefully this puts things into perspective. Okay, now, Top K, even though it's not present on the AI Studio interface, in fact, let's go to Top P, because Top P is present there. So So top P is the one that essentially allows us, or allows the model to pick from a list of words based on their probabilities. Okay, let's do this. Where's my, here. So I'm using top P and top K and top P here together. So let's say that the sentence that the LLM generated so far is the dog is. And now we have these two settings, top K 3, top P equals to 0.7. So top K equals to 3 is going to tell the model what are the top 3 words from the next predicted words that it can use. Okay, so if we say top K is equal to 3, we basically tell the model that you can use happy, running, barking. So remember what we said about the self-attention mechanism? Every time when it's going to print a token or a word, it's going to calculate the probability for the next likely token. Okay, so let's say for the sentence the dog is, the model said I can do happy, running, barking, sleeping, jumping, flying. Like these are the 6 words that it can output. For each of those, it's going to calculate a probability. 35%, 25%, 20, 10, 0.5, 0.2. With top K equals to 3, we're telling the model that you can pick from the top 3 highest probable words. So we restrict the pool to be happy, running, and barking. With top P, we tell the model to calculate what is called the cumulative probability. So cumulative probability is just the probabilities added together. And with 0.7, and using the same example, we say, okay, happy's cumulative probability is 35%. Running, because it was 25%, is 35 plus 25, which gives us 60% cumulative probability. Now, because our cutoff is 0.7, so 70%, we now restrict the next token to only be happy and running. And out of this list, the model is going to probably pick happy. So it's going to be the dog is happy. Now, what's important to understand is that, let's say that the previous sentence, or the sentence from the user, or somewhere in the context, we said something like, the dog was running around all day, then the model generates the dog is, then it's very likely that the words, sleeping, for example, would have a much higher probability because of the previous context that the model output. Does that make sense? Yes? No? Kinda? Yes? Okay. Now, you put all of this together. Top P, temperature. You can ignore top K for a moment, but basically, there's a relation, there's sort of like an indirect, and I'm going to change this word because I was told it's too posh. In synergy, okay? Not synergistically. So temperature works in synergy with top P and top K, whereby first, with the temperature setting, you allow the model, you set the model's creativity. Okay, that's like, the knob to set the creativity. Based on that creativity, then a list of potential next tokens are going to be generated. And then with top P and top K, you're going to then further filter that list of probable tokens to match your settings. Okay, so temperature first, then top P. I think that's what I'm saying here, yeah. So temperature is like the volume control for creativity. You set that. Based on that, you get a list of words. If the model is less creative, then probably the dog is going to be eating, sleeping, barking. If the creativity is higher, you may get things like, oh, the dog is jumping and flying, and it's going to be more creative and more weird. And then based on top P and top K, you're going to say, okay, what are the top words from this entire list that got generated by the temperature setting is the ones that I should use for the next token. And it does this at every single token generation, every single time. I used to have an example, but it's very difficult to get like highly predictable output. You can test this if you want, but I got very mixed results, so I dropped that example because there's no easy way to demonstrate temperature and entropy. When you have like use cases, definitely play around with the temperature lever or the temperature setting in the UI, which is right here. Right, is this one. Or we can try something like write the first sentence of a sci-fi novel. Okay, temperature 0 is going to give us. Oh, I'm using this thing. I shouldn't. Okay, whatever. Where's the? Give me the response. Don't think. Oh. You see, always use the right model for the right thing. Flashlight should be fast enough. Okay, so reset. What was it? Write the first sentence of a sci-fi novel. Oh, and I didn't. Oh, God. There. The Crimson Sun, like this is also very creative, right? Like and then you do this. Okay, remember this, skeletal shadow. I think this is also very creative, right? I mean, in fact, this seems to be like worse. You see, like anyway. Test it in your apps. Hopefully that's going to be different. But that's the general idea, right? So higher temperature, excuse me, more creative, 0, factual, less creative. Right, next one, safety. Safety is very important, blah, 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 right? That's pretty much it. But on a more serious note, you know, if you want to block the model to generate hateful speech, you know, explicit language, dangerous content, or whatever, Gemini models have some safety settings. This is how you set it up. Basically, there are multiple categories. So there's harm, there's explicit speech, there are multiple categories, and you can say how much of that you want to allow. Okay, I was in a situation where I set, you know, everything to be, you know, blocking anything that's even low, you know, harassment, hate speech, whatever. And I just said something to the model like, "Oh no, that's stupid," and I got like a 400 server, like 400 error message from the SDK saying like, "Hate speech detected," and I'm like, I just said it's stupid, right? So, you know, it's good that you can set these. By the way, this code example, this is the old one. Is Gen AI. Okay, so use the new one. And you can also just refer back to here, and you can see the settings here. So harassment, hate, sexually explicit, dangerous content, and then you can set block none, you know, few, some, etc. But basically, you know, when you set these settings, this is how you do it using the SDK. Okay, and then once you set these safety settings up, you then pass that to when you select the model along the settings, you just pass in the safety settings as well. And then the model is now going to adhere to the safety settings that you've specified. Naturally, we do not have an example on this to show, okay? Because maybe one day I'll come up with some abusive text. Okay, cool. Structured output is the next one. So this is very, very interesting. So you can basically tell the model to respond a data structure or a schema that you specify, which is quite amazing. One use case for this is you have unstructured data. You have PDF documents, you have whatever document, whatever text, and now you can tell the model to basically structure that using the schema that you specified. Or another example is maybe you're building an API and you want to have the API to respond using a JSON format. You specify how that JSON schema should look like, and then the LLM is always going to send responses according to the schema that you specified. Okay? So here's one example where this is how the schema looks like. So we have a description, array of original Star Wars films with details. Then we say, I want to have items, and it's an object. So basically specify the data type for everything, and then basically this is going to be an array. So you see the first type, schema type is array, and then I'm going to have, in that array, I'm going to have an object which has title, released character, and plot properties, each of those as strings. So you can specify, string, object, array, I don't know, whatever, there's 3 other data types. You can specify whether a particular property should be nullable, but whether you want it to have null values or not. You also specify which ones are required properties. So in this case, I made every single property required. Now, from the code perspective, you will see the exact same schema here. Okay, so we just collapse that. Then I have a prompt that says display information about the original 3 Star Wars films. We call generate content, and notice that this is what we've done before, and now we just say config. We ask the model to generate a response in JSON format, and then we say that the schema that it should adhere to is the schema variable that we created there. Okay, and then we just print out the response. So if we run this, npm run structured, then the model should respond back with a perfectly valid JSON object, exactly how we asked it to do. Okay? And this could, as I said, this could do anything. This, you could literally ask questions about an LLM, get it to always respond to according to a schema, or you could send it text, you could send it documents, and you could say, maybe you send it, 100 PDF documents, and you say, okay, give me the title, the page count, and the summary in an array of objects, where each object is title of PDF, number of pages, summary of those PDFs. Okay, so you create structure around unstructured data. So that would be another interesting idea. Okay, here's where it gets really, really cool. So, live information. So models, right? So all these companies, right? So Google and the other companies, they train these models, right? So Google spent billions of dollars of GPU costs and electricity and human manpower and everything to train Gemini 2.0, 2.5, et cetera, et cetera. All these models have a cutoff date. A cutoff date is when basically information collection for those models have stopped. And you can ask, here. What was your training cutoff date? You can actually ask them. I think for Gemini, this is, like December, early 2023. So basically what that means is that data collection for Gemini 2.0 Flashlight stopped somewhere in early 2023, which means that anything that happened after 2023, or whenever this training cutoff happened, it just doesn't know. It has no idea, okay? So that's why if I ask it questions like what is the weather in Jakarta today, it should say, I have no clue. Okay, so how should it know? Or you ask it, hey, what was the result of the 2024 World Cup? It has no idea, because it happened after its knowledge base collection time stopped. Okay? Now, so this is, this is one thing to understand. What's really interesting, and we can try this. I did this example here where you say npm run weather in go with Singapore, and it's going to respond like, hey, I'm sorry, I don't know what the weather is like in Singapore. Like, how should it know, especially right now? Or you could ask whatever you want. The good thing is we have this thing called function calling or tool calling for LLMs, which is basically when you give a function to use for the LLM. And this function is really just a JavaScript or a TypeScript function. Now, if you think about this, what can you do in a JavaScript and a TypeScript function? Anything is the right answer. You could talk to a REST API, you could query a database, you could do whatever you want. Because you can do whatever you want, and because you can give this tool to the LLM, it means that now the LLM can suddenly retrieve any information that you want, and it's relevant. And what's great about this is that you write the function, you give it to the LLM, the function is going to be executed, the function is going to get a response. Maybe we're going to do the weather example, which is like the 101 of function calling, really. Every single example that you will see about function calling will do a weather example at some point. But basically, we call a weather API. The weather API is going to return us an object that says, you know, for whatever location, the temperature is 10 Celsius, the conditions are windy. And the LLM is not going to give us that information, but it's going to incorporate that information into its language model features, and it's going to respond with natural language, and it's going to say the temperature in London is 10 Celsius, and the conditions are windy, okay? And that's where it becomes really, really interesting. So let's run this first, and then we're going to take a look at the code. So npm run function, and we have to put in the city. Okay, so let's do npm run function, and let's go with London. Oopsie. Fetch failed. Why did the fetch fail? Fetch failed because, I don't know. Okay, let's look at the code, and we'll try to fix it in 10 seconds. Okay, so separately out of anything Gemini, anything AI related, I have a function that is called getWeather. I'm using the, I think I know why it's stopped. But anyway, so I'm using the weatherapi.com. You know, it allows me to get current weather based on a city. I pass the city as a parameter. And what I do, you know, make a fetch API request, blah, 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 blah. But what this call is going to return is this. The temperature and the condition for the city, or it is going to return this object with the temperature and the condition of the city that I'm asking for, okay? Now, from the LLM side of things, it's slightly, the code is getting more and more complicated as we go along the examples. But basically, I have this object here called the weather lookup function. This is where I describe my function. So I give it a name, it's getWeather, I give it a description, gets the weather for a city and returns the current weather info using the metric system. And I specify that this particular getWeather function is going to have a parameter which is a city where for which I want the weather report, okay? So that's one thing. Then I have the prompt, which is just going to say, what is the weather like in city, you know, whatever the input is from the CLIs right now. I pass, and this is the important bit. So actually, it's these two things together. So we use generate content again. We select the model that we want to specify. We send the prompt. But now we add a config object, which has a tools property, which has a function declarations property, where we pass that weather lookup function. That's like the object that we had to look at before. Meaning, when you put all of these together, is that we are giving a tool, we are giving extra, you know, ammunition to the model. So if it realizes that we're asking a question that is about the weather, and it knows that it can't answer it, and we gave it a function that helps it to answer that question, it's going to invoke that function, it's going to incorporate the response of that function into its response. Okay? And then the rest is where it becomes tricky. So how should we dissect this? Okay. So before, when I print out the response, I just said response.text, right? Because it was easy, the model gave us a text, I just printed that out. In this case, I need to see if in the response object that comes back from the LLM, is there a function calls property? Because if there's a function calls property, it means that the LLM wants to invoke a function, okay? And so if that's the case, so this is the if statement, right? So the else statement is basically there's no function call, just, you know, return whatever the model wants to return. If there's a function call, we actually have to call the getWeather function that we wrote, passing in the argument, the city argument, which comes from, from the argument object here. And these two are very, very important. When it comes to function calling, you have to make sure that in the history that you maintain when you converse with the LLM, you send the user's prompt, and if there's a function call, you need to send the function call response. Actually, that's actually incorrect. This is also model. You have to, I think that's model. You have to send the fact that there was a function call, and you have to send the next message in the history array must be the response to that function call. Like the order here matters. If I wouldn't do this, so if I wouldn't do any of this, or I wouldn't do the second one, I wouldn't do line 62, the model would complain saying like the order of, I don't know what the error message is, but it's something like, oh, the order of items or the next message should be the response of the function call. There's going to be some sort of an error indicating that the order of these items matter. So user's prompt, function call result. So every time there's a function call, the next message in the history must be the result of that function call. Okay? Once we have the function call, then I ask Gemini again, like, hey, okay, can you now give me the final response, incorporating, and notice we pass content, so contents at this point, that's the history of the conversation, will know the user's request, and it will also know the response from that function, right, because we just edit that in here, and I'm just printing out the final text, okay? Now, as to why this is not working, that's a very, very good idea. Where can I think it's because of the API, and I can't do the API right now. But you see it started the logs, right? So it says function to call getWeather. So it realized that it needs to call the getWeather function. The argument is city London, and then it should make the fetch API request at this point. Give me 1 second. Let me just check one thing. It suddenly became very dark, right? Okay, this one. I think I may have changed the API key, and I forgot to obviously update my code, which is very professional. My account, or this example worked last week, so let's see. Okay. Just bear with me. Okay, weather API. Wonderful. Copy. Close. It's exactly the same key, so I'm not sure. Plug back. If it doesn't work, I'll show you another example. Light. There we go. Okay, let me try to run this again, but okay. So it realized it needs to call the getWeather function. City, it realized that the argument is, the city parameter should be set to London. It made that weather API call. The weather API responded with whatever it responded, and now it incorporates it in its answer. The weather in London is currently clear with a temperature of 5.2 degrees Celsius. And let's do here. Is it 32.4? I don't know. Is it cloudy? Someone check. No, but you get, anyway, it does whatever, the APIs are different, but this literally takes current information and incorporates that back to the LLM, which means this could do whatever you want it to do. Okay, if there's time, I'll show you some cool examples, but I just want to make sure that I go through all of this stuff with you. Okay, grounding. This is very specific to Gemini. So grounding is when you want to have solid proof, or you want to ground the information against a Google search for information retrieval. So it's a type of function calling where if the LLM can't answer something, it's now going to fall back to a Google search. Okay, and it's going to check Google's information system for an answer. Okay, so you will see when you take a look at the code that, so the question we're asking is who individually won the most gold medals during the Paris Olympics in 2024? Because its cutoff date was 2023, it has no idea that there was an Olympic thing happening in 2024. The first place, let alone know anything about the gold medals, and it has no idea about Paris Olympics whatsoever. And the only thing here, I mean, I did add some extra code, but what matters here is that now we use Google Search Retrieval as our tool. So we're not specifying a special tool, a custom JavaScript function that we wrote, but as opposed to we're saying just use the Google Search Retrieval, and then we pass that config again back to generate content. Okay? And there's two versions of this code, I think. Yes. So this first one, so basically when you use grounding and when the model responds, you can actually extract some HTML from it, which is under a property called rendered content. And it's going to give you, I think, what Google calls a results pill, or it has a, you'll see, and then you know exactly what I mean when we run this. So npm run grounding. So we send the request, and then what I've done is that I got the response back from the LLM, and I generate this HTML page from it. So this is the actual text response from the model. So this guy, the French guy, won the most amount of individual Olympic gold medals at the Paris Olympics. And then it gives us search pill, whatever it is. Anyone knows what this is called? But this is also part of the model's response. So as part of the model's response, we get this HTML. So I didn't build this. I just took the HTML from it, and I display it here. And so now if you click it, it now goes to and executes an actual Google search. So this is very good, especially if you're writing, you have like a mobile app or something, there's like a chatbot, and you want people to like execute the Google search, you can just like generate this. I think they call it the search pill. That will bring up really weird stuff, I think. What is this called? It has a name. Pill widget. I don't know why I'm obsessed with pills, but it's like a widget of some sort that Google generates. Now the second, where is the second example? So it's on the bottom, it's all commented out. So we do comment this, and then we enable this, and that should give us something else. I think it's just a more simple. Yeah, so this is without the actual content, and it doesn't open up a web page and whatever, and this still gives you the answer to that question. But notice that it knows this, like otherwise it wouldn't know. It only knows this because it's been executing a Google search, and Google search responded with, oh, here's this guy, use this information. Without grounding, if we ask it, so if we open npm run, chat stream, and we ask it the same question, this. Oh, it's still acting as Yoda. I forgot that. I'm like, what? But you see, it doesn't know. Okay, because I didn't give it the Google search grounding as a tool. When you do it, it will, if it's information that it doesn't know, it will try to get it from Google. Okay? Nope. Here. Okay, code execution. This is fun. So you can get the model to generate code for you and execute that code and show you the result of that execution. As of whenever I wrote these slides a few weeks ago, it was only able to run Python code. Okay, so it can only run Python code for us. We'll take a look at this as well. So npm run code execution. So again, we need to specify the tool, and the tool is code execution. Okay, so I'm asking, what is the sum of the first 50 prime numbers? Generate and run code for the calculation, and make sure you get all 50. Okay. On the other hand, what I'm doing, I'm also going to save the result of the code that it generated into a file called output.python, and I'm also going to generate an output.html to then display the actual code that it generated. Okay, so let's see how this works by doing npm run code. Okay, so this is the entire response from the model. I obviously formatted it to look nice. Explanation, okay, I need to calculate the first 50 prime numbers, blah, 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 and it says, okay, this is the generated code, so we get the Python code, and it also executed it for us, so we see the actual, log and execution of that file, and now it gives us also the response based on the code execution. But what's really interesting is that because I asked it to say, or I told it to save that Python file, it's also here. So it generated valid Python code, which you can now run, and it will work exactly in the same way. Okay? Currently, it only does Python, I think. I didn't try it with JavaScript, but I think Python is something that they generate out of the box. Fine-tuning. This is the last example, last couple of set of examples. So fine-tuning is when you take a model and you gave it a sample data set, which is, and you need to give it ample amount of data, and you basically say, this is my input, this is my expected output, this is my input, this is my expected output. So you give it a lot of these examples. So, and with this fine-tuning, you can then basically create a customized model. You're not retraining the entire model, because you would need the same amount of money that Google and other companies use to train these models. So what you do is just, you kind of alter the parameters for that model so that it suits your use case based on the samples that you give. I think Google says you need to specify at least either 100 or 500 samples of sample input and expected output for the model to be able to work properly. And you do this whole fine-tuning. It's very, very easy to do. Why do they have to change the interface every single time? If anyone sees fine-tuning or tuning here, just let me know. Not run settings. System instruction. No, 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 no. More actions. No. Maybe it's here. No, no. Ay, ay. There's a UI for this, or there was a UI for this. AI Studio. If anyone knows where that is, let me know. Starter apps? No. Your apps? Maybe it's an app now? No, it's not an app. No. I don't know where it is now. Or maybe you can only do it with newer models. I don't think so. Dashboard. Uh-huh. No. It's somewhere, find it. But basically how it used to work, I don't know where it is now. How it used to work, you said, hey, this is the model, this is the base model I want to use, and it gave you a table of input, output, and you just put in, or you could upload a CSV file or any input that you have. You press the button, fine-tune your fine-tune model, and then you got an API key for that model, okay, which is very, very important. So I have in here, notice that I'm no longer using the Gemini API key, but I have a separate API key for the fine-tuned model, which is basically going to mean that this code is going to tap into that the model that I fine-tuned, okay? And this is how it's called. So it's Harry Potter sorting hat. So what I've done, anyone familiar with Harry Potter? Sorting hat. For those of you who don't know, there's kids visits in the school. You put a hat on them, and the hat will say, "Oh, you belong to this class or to that class," or that's the generic idea. So obviously, what do you do when you're a systems engineer? You take student qualities, and then you say, "This is Gryffindor, this is Hufflepuff, whatever." So I fed that information to Google for fine tuning. So effectively, I created a model that is now the sorting hat model. So what you do is you give it student qualities, right? So I have a student who is really brave. And based on that, it will put them into a class, okay? So it puts them into Gryffindor. I want you to notice that because I trained the model of, student qualities and the expected output was only a house, it doesn't output anything else except the name of the house, okay? So now we say, I have a malicious student. This should go to Slytherin, right? So you get the idea. Okay, so based on the qualities of the students, it will put them into one of those 4 houses. This is it's like a gimmicky, fun example. But other things that you could do is, given various values about properties or values about something, the expected output is these hashtags. So you could basically have a model that generates hashtags for you based on input, maybe customary for your social media team to handle or whatever it is. But basically, you have to specify inputs and an expected output, and then you have to train you have to fine-tune the model. And I really have no idea where it's gone from this new interface. It was here on the side, like it was just there. Or maybe it's let's see, create an app. Function, no, first function calling. Okay, hopefully it's going to come back. I don't know where that is, but you saw that if you just Google for Gemini fine tuning, this is how you do it, right? So you have input, expected output 2. You see, basically, this is, I think it's increasing the numbers, right? So you're extracting the model that every time I give you a number, doesn't matter if it's in what format, I want you to respond with the next number in the sequence. Okay, so what I've done for my example is, student qualities, expected output, Slytherin. And I fed it lots and lots of examples. And then once you do that, you're going to get, a custom model to use. Okay, but this is the page where you can learn more about that. Okay. Before we get to this, so let me show you, because we only worked at the back end, so I'm going to show you a couple of examples from, admittedly a different event, if you don't mind, just so that you have an idea about how this would look like from the UI. Okay, some of these examples from the UI. Oops, nearly. npm run dev. Okay, localhost 3000. Okay, so ignore the conference, please. But basically, so let's go with function calling. Okay, so maybe this is the chat interface, or this is now using the UI, and you say, "Hi, how are you?" This is then you talk to the model, and hopefully, okay, wait. This is in tool. I think I know why. Because I changed. No, don't ignore anything OpenAI related. What's the? I love this. An error occurred. Great, thank you. But it says there's messages. God, stupid thing. What did I change on this page? What did I change? Where are the changes? God, no idea. Anyway, so you know, you build a nice UI and then everything works. npm run dev. I'm not going to waste a lot of time trying to do this, but let's maybe just try this one. And if this doesn't work, then there's something really wrong. Yeah, there's something definitely really wrong here. Because it does, you don't see this, but not that. There are messages coming back from the model, right? So there's no, I don't know why it's not. Parts, text, hi, but it doesn't. Whatever. So you know, you have to build something nice looking, and then you have to talk to a backend. That's the whole point. Hopefully, let's see if I can show you this example. Because with tool calling, you can do a lot of interesting things. So I'm going to just start this, and then go in here. Expenses advanced. If this doesn't work either, then I'm just going to give up and continue with my slides. Localhost 3000. Again. Okay. How much money I spent on food last month? It's either going to work or it's going to fail epically like the previous ones before. Probably it's going to fail. Of course, I don't know. What am I? None of my examples work. Like literally none of them that worked last week. It's just, someone should say that, oh, it's because you use OpenAI. I'm kind of ready for that right now, but I'm no idea. I have one more. I have one more example. Okay, let's do this. Ooh. Oh. That makes sense. Thank you. Not using you anymore then. Okay, so this one, backend, npm run. npm run, what are the commands? Npm run dev. Okay, that's a good start. Then we go front end, front end, basic, ng-serve. This is for a future conference, so if it doesn't work, that's because, okay, that's the reason. Okay, so, tool calling. Hopefully this is going to work. So we say hi. Okay, so this one, Angular front end, and the same sort of like Node.js example on the back end, except now the Angular front end talks to that back end, and then the back end sends the response streamed back, or it doesn't, I don't think it streams, but it sends the response back from the LLM to the UI, okay? So now we can say, my name is Tamas, and he's going to say, nice to meet you, what's my name? You know, we can kind of test the history. And now we can say, what is the weather like? And this is when it realizes that, hey, you asked for the weather. I can't, like, first of all, where, you know, weather where? Where are you? And it says, do you want me to get your location? And I'm going to say, sure. Okay, and then from the UI, we now have this confirmation. So this thing is called human in the loop. human in the loop, human in the loop, I think this is how it's called, where where the LLM pauses and says, okay, I need you, the human, to confirm whether you want to give access to it's basically waits for something from us as an input. So we're going to say yes, we should technically fire up I already allowed it, but if I wouldn't have, there's this little pop-up says like, hey, can I use your location? You say yes. And now it says we are the special capital region of Jakarta, and there's a mist. Is there a mist? All these weather things are very weird, But anyway, so it knows that it needs to call a function. Okay, so it does the function calling in the backend, and it just feeds the response back to the UI. So hopefully this gives you an idea how to put those examples together. You have to build a backend. The backend would have to send the data back, and then you process the data from your user interface. Okay. Now, a couple of more examples, and then we're going to wrap up. So, this is AI and images. So, we're going to take a different angle on things now. So large language models can generate images, right? So you prompt the LLM to say, give me an image about, a football field or whatever it is, and it's going to generate that image for you. What we're going to look at here is kind of different, whereby you have existing image assets under, and this is going to use Cloudinary. So under your Cloudinary account, and you want to change those media assets using AI. Because you have a website, we're going to run through an example of an e-commerce store, and you have different needs to show that image in different versions or different alterations. You want to make those alterations to happen with AI. So here's the simplest one, right? So this is generative fill. So the original picture was taken in a portrait mode, right? But maybe your requirement now is that, hey, I want to display that image as like a big banner on my website, and I want to use a landscape mode. So what we do is we tell Cloudinary that, hey, I want to display this image in width, 3,000 and height 1,500. And if you don't have generative fill, what you would get is just like a black border or like a green border around the edges of the image, where now with generative fill, you have, the bushes, the trees, and everything else, to a point where you really can't tell which one was the original. Right? I can tell you that the original was the portrait mode. And kind of one telltale is, you see there's like a weird cut here. If you look very, very closely, you can notice that this bush is weirdly placed. But other than that, there's no way you can tell which one was the original, which one was the generated one. So this uses a technique called in-painting, where the AI looks at the existing image, recognizes the patterns, and is just going to use the same patterns to then paint the rest of the picture. Okay, that's in 2 sentences how that works. You can also replace objects. Okay, so here, that's me giving a talk, and who can notice what I replaced? The laptop, yes. Laptop to hamburger conversion done. And what I want you to notice is that well, maybe you can kind of see, but otherwise it's very difficult. It always seems like I was talking to a hamburger, or like I have a hamburger as a request as a speaker. No, I'm kidding. So basically you can, and the way this works is you say either via URL parameters or using our SDK, you say replace object with whatever else you want. Okay, so we could actually open this, and I can show you that this is how the URL looks like, right? So it says replace from laptop to hamburger. Now I could say replace this to pineapple, because, healthy living. Oh, that was fast. There you go. Now I have a pineapple in front of me. Done. That's funny. Slides. Where are my slides now? Slides are right here. Okay, remove, generative remove. So I took this picture in Singapore. It's always the left one that is the original. So Singapore turns 60 this year, FYI, in a few months. And I was like, oh, that's a really nice picture. And then this kid walked into it and ruined it. So I removed him. Now, I usually say at events, like the only thing that you will remember is Cloud Engineering helps remove kids from pictures. No, that's not what I want you to remember. But basically, again, the pattern is the same. Find object or detect object, remove said object, and you can see there's not even a shadow of the kid anymore in the picture, right? It was always like, it was never there. Or he was never there, okay? But you can do this with other things, and we'll take a look at those as well. Recolor, very, very interesting use case, where you take an object and you say, recolor this to another color. And this is very good for like e-commerce, where you now don't have to take, 20 pictures of the same thing in different color. You can now give approximation, and you can do generative recoloring of one single image, and you can show those alterations. Background removal, as it says on the tin, take this picture, remove its background, and it's done. And the reason why I really like this example is because, traditionally speaking, examples with like hair or like furry animals like this one, it's very, very difficult to get it right. And if you look at this example, when you get the slides, you will see that it's very, very precisely doing the background removal. Like there's not, you don't see anything in the background. So it's very, very precise. Okay, so we're going to take a look at this example, which is npm run e-commerce. Here, npm run e-commerce. So now we have to go to this URL. Okay, so I need to zoom back a little bit. So here's our example, right? So you have this product landing page. This is the dress, and now you're going to be, you want to sell this dress, right? So now one thing that you want to do is you want maybe people to click on it, and you want to kind of show a larger picture of this image. And what we do here now is do a backfill. So none of that is real or ever existed that you now see in the background, right? And I can actually prove that to you. It was recently pointed out to me. I want you to focus on sort of this left side of the image. So in this example, notice that there's water and there's some land in the distance, right? Whereas if I now change the color, this is also, by the way, doing the color replace, and it's doing it kind of seamlessly. And now if I zoom in on that, like in some examples, I can't remember which one it was, you see now there's an island. And that's how you can kind of now tell that whatever is on the sides is AI generated. But you can't really tell. Like there's nothing in here that would tell you that this is AI, right? It's like perfect. So basically we are showing two things for now, right? Which is take the color of the dress and replace it with any of these. And when you zoom in, just expand and blow out the picture. It looks much nicer to see this than, you would see like, black edges or gray edges on the two sides of the picture. Now, what bothers me is this bird, right? I mean, it ruined our Photoshop. So remove bird, yes, gone, okay? So now the bird is now removed. It's much nicer without the bird. No, I'm kidding. But that uses the same thing where you do the object removal. And then you can also do, I just added this. You wouldn't probably do this in like a real e-commerce landing page, because why would you? Remove the background, just focuses on the dress itself. So it removes everything in the background, and it doesn't matter which dress color you pick, it always removes the background for you. And then you want to put it back, you put it back, and then you want to add the bird back, remove the bird, zoom in, zoom out, whatever you want. Okay, and all of this is achieved by transformation. So to a point where I can now go in here, copy the image address, just put this in here, and we can let's find something. So let's go into the HTML color picker. Okay, let's find an atrocious color for this dress, something as ugly as this. What do you say? Okay, so we're going to replace that with this, and it will take some time for the first iteration to generate this, but hopefully we're going to get the dress with that purple, violet, I don't know what color I picked, at some point. At some point. So if you wonder how this works in production, Cloud Engineering has this thing called eager transformation. So what you would, this is fine. what you would do is, especially if you have a transformation that is related to AI, you ask Cloudinary to do the transformation when the users upload these images. So it starts processing it in the background, so by the time the image is requested, it will actually return the image and not do this. The error here, by the way, is that, I just refreshed it, but the error code is that it's working. It's still doing the find the object, replace it, generate it, and I also gave it a fair amount of other transformations, like it needs to rescale the image, and that will take some time. The reason why this is fast is because these transformations have been done before, and now it's seamless, right? Because it's exactly the same transformations that we don't actually send this ever back for processing to our servers. This is just, all of these are returned from the CDN. Because it's been done, it's been distributed to the CDN, so it's fine. Okay, I'll give this one more go, and then if it doesn't work, then we're going to let it be. Okay, so I have this link. I'm just going to show this to you as well, because we do a lot of interesting things with video as well. And I was talking to someone about this before. So let's say, you have, let's do it square. So what I want you to notice is, you have this video now, and it doesn't matter how you hold your phone, for example. Actually, this is let's do this one. So what you see on the left is, at some point, this guy is now off focus, whereas on the right, is still in the frame. So what you can do when you use Cloudinary and you do video cropping, you can specify an object that you want to follow as the video is being cropped. Okay, so that's why on the left, we just lose the focus because the video is cropped to the middle of the video, whereas on the left, we lose it. On the right, we always keep the focus on the guy because we specify the cropping to follow the person. So now it doesn't matter how your phone, how you have your phone and how you record a video, you can always get the action to be shown regardless of the positioning of your phone, okay? And on this URL, you will find, additional things that we do with video and AI, so I'll have a link on that so you can try this out. What is it saying? Let me see, why is it not even giving me a network response? You know what? It doesn't matter. Just believe me that it will do a purple image at some point. Okay. So here are some references. AI.google.dev, aistudio.google.com are two very good resources to get started with anything related to Gemini. Also, most of the things that we talked about, right? So AI Studio, if you open that interface and you can specify system instructions. This is where you say you are Yoda, for example. You can set the temperature, you can specify the structured output, the code execution, the function calling, the grounding, everything that we talked about. And what's great is that you press this button, and then you select that you are working in TypeScript, for example, and now here's the entire code that you need to get started, right? Using the package at Google/GenAI, which we talked about. Okay, so you get like this template to get started with, and you can literally put this into Node.js, run it, and you would get everything up and running. What I also highly recommend that you do is to take some time and have a look at all the code samples that I gave you, add your API key, run the code, check the code, and just get familiar with all these things that are in there. So additional resources, again, machine learning and AI resources from Google, and then these two AI-related developer-specific landing pages from Cloudinary if you're interested in more, to learn more about this image and video stuff. Okay, this is me on LinkedIn. Feel free to scan the QR code and send a connection request. I would be happy to talk to you. Do note that when you send a connection request, tell me where we met. GDG Jakarta. If you don't do that, I can show you. I have 150 connection requests. You be the next 20, okay? Because I don't know who you are. I'm sorry, I don't know. And I get like invest in property requests and all sorts of weird requests coming in LinkedIn. Okay, so if I don't know where I met you, I will not add you. So what I want to say, if you have any questions, even after this event, I'll be more than happy to talk to you about that. So I'll leave this on for another 3, 2, 1. And that's me, Terima kasih, if that's how I say it. Thank you for your time, and I think we have 8 minutes for questions. Is there going to be a microphone? You know, it's so bright, I don't see half of you. So anyway, if you have a question, raise up hand. 1, 2, 3. Hopefully there's is there a microphone? I don't see what's there, what's happening there. Hands up now if there's a microphone. I think, yeah, first and then second and third, yeah.
Test. Okay, so thank you for your time, Mr. Thomas, and welcome to Indonesia. My name is Nayaka, and in here I want to ask about the Gen AI from Google. So you have given an example about how we are using a Gen AI and how the study case will being used in either in the development or either in the production way. But in this case, I want to ask about, is Gen AI Google can, we also learning about how we give an instruction to system for giving an output for all the things we question to ask to the model. But how the Gen AI can retrieve the information first from us, which like an history, but when we see there before in an example, history are working with we giving the information first in the code. But how if the history are come from, for an example, as a PDF? Let's say we want to give a chatbot for an FAQ, for an example. Then we have the FAQ or on PDF, let's say, and how we develop the history from the PDF through the Gen AI Google. Is it we just only pass the link of the PDF, or we need to extract first the PDF and then set to the history, or what kind of things we could do for developing it? Thank you.
Okay. So you have 2 options. In large language models with, you remember the context and the token limit. With LLMs that have 1 million token, there are now LLMs out there that have like a 10 million token limit, which is like incredible. You can just load the PDF directly into the context, like into the chat. And so also if you look at the Google specific SDK, they have a thing called the File Manager API, I think it's called. Here, okay, so you say, again, is this larger? Maybe a bit more. You say, okay, you know, use the Google Gen AI package, and you say, okay, I want to upload, in this case, a JPEG file, but you could upload a PDF or whatever you want. And then now, notice how you upload it using the AI.files.upload, and then now you say, sorry, this one, can you tell me about the instruments in this photo? So now you're asking questions about the uploaded document. So that's one way you can do that, right? So this is good if you have maybe an image, 2 images, 1 or 2 PDF files, something that is relatively limited, or small amounts of content. So that's one idea. If you have 100 PDF documents, so you have a lot of PDF documents or a lot of content, then it becomes a little bit trickier. That's when you need to learn about this thing called RAG, Retrieval Augmented Generation, where let me, okay. It's easier if I bring up one particular picture from a slide. I just need to find the slide. Where would I have done this? Sydney? Any bets? Sydney. Okay, this is it, yeah. So, No. Oh, here. Here, this one. Okay, yes. So, first thing is you do, documents in this case are your PDF files. Okay, so you take those PDF files and you have to do what is called vectorization. You have to create numerical representations of the words that are found in that PDF document, and you need to load it into a vector database. This can be a standalone vector database. You can load it into BigQuery because it also supports storing relational data as well as vectorized data. You can just load it into a Postgres database, right? Because that can also store vectorized data. Once it's in the data, once it's in a vectorized format, in a vector database, you can then send a query against that data set. You vectorize the query. The two numbers, the numerical representation of your text and the numerical representation of your query are now going to be compared for what is called relevancy search. So the most relevant documents for your search are going to be retrieved from the database. You pass those to the LLM, and then the LLM, based on that retrieved information, is going to generate a response, which is now grounded to the data set that you have in your database. That's reg in 2 seconds. Otherwise, it's a half-day workshop. But this is how you would do it. I can also really quickly show this to you because I've done a workshop on this. So I think I have some data in here. So what I've done, I think is this one. Password is password. Always works. Embedding, view data, or rows. So what I've done, I took a PDF document, and this is the content. So you load the PDF document into chunks of 100 words, 1,000 words, whatever it is, right? So it's basically, I don't know what I did, maybe 500 words. And for each of those words, I also stored this in a vector format, which hopefully you'll see here. Okay, so this here is the numerical representation of the text. Okay? And so now, in my application, which is, hang on. No. I need to come up with better structure for my files because this is getting out of hand. 2025, London. Oh, reg, there's a reg folder. Clever me, npm. Probably this won't work either because of I run out of, other companies' tokens. Probably it won't work. What is a shield token? No, it won't. It probably, it can't work because I don't have credits anymore. So basically what this would do is I ask it a very specific question, and the answer, it would give the answer from the knowledge base it has, okay? Or maybe we can, I'm going to run out of time. So, think, calm down, breathe in and think. Okay, we go to, not this folder, but Control-C. GDG AI, we go to workshop, and we run npm run reg and see what happens. Okay, so in this example, let me show you the code. This is using the old SDK because I'm no longer using these examples, just ignore that, but everything else is going to be still relevant. So step number 1, list of PDF documents I want to use. Okay, so first one, second one, third one, these are all somewhere in my folder structure here. Then I use this file manager thing somewhere. Okay, so I think this changed in the new API, but here's Google AI File Manager is how it was called, and then I upload these files somewhere in here, filemanager.upload file. So I'll upload all these PDF files, meaning that now the contacts will have access to those PDF files, to those PDF documents, okay? In the system instruction, and this is where it's also very important, I say, so I play this card game, so I uploaded the card game rules as PDFs. And I'm going to say, answer the user's question using the PDF documents and only them. Keep your answers grounded in the facts of the PDF documents. Basically, what I'm telling the LLM is that those 4 PDF documents is your entire knowledge base. You know nothing else other than what's in those 4 PDF documents, okay? And then when answering, always display the exact PDF document where you source the information from. And I just say, if you don't know the answer, just say, I find your question disturbing, okay? Which is, again, Star Wars reference. If you get it, you get it. If you don't, I'm sorry. And now, if we do npm run reg, oh, wait, no, stop. Okay, so now there's a chat session, and basically the documents have now been loaded. I'm also using a cache, so I don't need to re-upload those documents. So now I say, what is a shield token, which is a very specific question about the mechanics of this card game, okay? You don't need to know, but there's a shield token in it. Now, mechanical breathing intensifies. That's Darth Vader's breathing, for those of you who don't get it. And now, you know, it's now, you know, looking at those PDF documents, doing this relevancy search, and at some point in time, hopefully this is going to come back with an answer to say the shield token is blah, 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 and I found information in this document on this page or whatever. It's going to reference that. So long story short, this is how you do it, okay? There are many, many options. So what you want to look into is really just reg, retrieval augmented generation. That's how you do it. A shield token, you see it's there. And now if I ask it like, what is the capital of London? Of the UK? We know it knows, it should know, but because how I gave the system instruction to say, like, if you can't find this information in the document, just say you don't know. But it's not going to say I don't know, it's going to say I find your question disturbing or whatever it's going to say. Okay, we can leave that up, but that's how you would do it. Okay.
Yeah, hello, Thomas. My name is Gentra. So, yeah, I'm wondering with this generative AI and LLMs, in production environment, we as developers usually have monitoring and observability, right? And yeah, I wonder for, let's say, yeah, just like your example, let's say we have a knowledge base that we give to our bot, to our AI. And what's the practice for observability for these AI? So let's say we want to know whether the AI cannot answer users' queries or something. Yeah, what's the best practice?
So yes, that's a very good question. So the framework is, or the technique is called evaluation, right? So there's an actual framework for this. Plus, if you just do eval Gemini, there's an entire page in the Google documentation that talks about this. Define your evaluation metrics, which is literally the first step to evaluate your generative models or applications. Identify your evaluation goal and define your. This is what you need to read. Okay, it's long and highly complicated, but basically, or highly complex. But there's also a framework for this. So eval brainstorm data, I think. Sorry, brain trust. Okay, so they have an eval framework that you can use. But basically how this works is you can code this up, but the easiest way is that you provide a feedback mechanism in the UI. And that's exactly what every single UI does. No matter what you ask it, oh, I did this again. This one. This is them doing the eval on you. Or, the other one, when it provides you with 2 responses simultaneously and it says choose the one that you like, you subconsciously they eval that responses, and then if most people pick that one, they know how they produce that, so they're going to go with that versus the other answer, right? So that's how they do it, and then so every single one of them has it, right? So I'm just going to open this as well. It doesn't matter anymore. Like I'm going to be deported soon. So even this one has here. And then if I say no, and a lot of people say no, then they will figure this out, right? You have to measure it, store this, look at it, etc., etc., etc. Okay? So generally evals, and Google Docs has an entire page on this. Oh, sorry, it's time. I need to, you see, I told you I'm going to be deported in a minute. That's it. Thank you for attending. Enjoy the rest of the show.
We shift into culture and creativity. Sadiq Permana, Google developer expert in Android and CIO of Nusa Beta Studio, will take us on a journey to explore how Gen AI can deepen our connection with Indonesian culture.
Banget di sini. Perkenalkan, nama saya Sidik Rumana, saya GD Android, ya. Terus yang kedua adalah saya founder dan juga CIO dari Nusantara Beta Studio, NBS.dev. Sebelah saya ada siapa? Halo guys, nama saya Iqbal. Ya, ini machine learning engineer di NBS. Kita hari ini mau sharing terkait our experience develop OTT platform tapi empowered AI, bagaimana bisa leverage enhance interactivity engagement di OTT platform gitu ya. Jadi ini proyek pemerintah yang kalian bayarkan dari pajak kalian gitu ya. Kebetulan kita bantu develop. Tapi tenang, kalau NBS yang bikin aplikasi pemerintah harusnya bukan aplikasi yang abal-abal, kalian bisa download aplikasinya. Ya. Jadi tidak seperti aplikasi yang depannya C itu lah. Oh salah. Jangan. Oke, panjang ya. Ini yang kemarin pas submit ke CV ini, cuman akhirnya gue simplify aja lah. Ya, applying Gemini's video understanding to improve OTT streaming. Jadi, ulang dulu, ini perusahaan gue kerja di perusahaan gue sendiri gitu ya. Kita software engineer, reliable software engineer di Indonesia dan product development expert. Kita base-nya di Bintaro. Ada yang dari Bintaro di sini? Oh, nggak ada ya? Oh, ada satu orang. Ya, di situ juga ada dua tim kita, engineer di Android dan hari ini tugas di salah satu bank terbesar di Indonesia. Terus kita ngerjain aplikasi yang favorit teman-teman gitu ya. Mungkin pernah dengar Tix ID, MRT Jakarta gitu ya. Itu beberapa aplikasi yang sempat kita kembangin. Dan ini beberapa customer kita yang saat ini actively kita jalan-jalan sama mereka, bikin aplikasi yang seru-seru gitu ya. Yang dari software engineer banget sampai yang yang biasa-biasa aja lah aplikasinya. Cuman berdampak buat ekonomi Indonesia. Oke, ini proyeknya namanya Indonesia TV. Jadi aplikasi udah live, tapi fitur AI ini nggak di live ya. Karena harusnya supposed to be tahun ini, tapi our government cutting up the budget, right? So the
POC is still POC gitu ya. Jadi hasta karya aja jadinya. Jadi kita mau bagi-bagi di sini gitu kan, knowledge apa sih pengalaman kita. Terus ini aplikasi Indonesia TV. Jadi story-nya sederhana. Gue dipanggil karena kita punya pengalaman ngembangin aplikasi OTT. Mereka datang ke kita, mereka cuma bilang kita mau bikin Netflix buat Indonesia gitu ya. Oke, it's not big deal gitu kan. Bukan sesuatu yang susah gitu ya. Udah kita bikin OTT yang relevan karena mereka punya konten yang hebat tapi punya butuh rumah yang hebat pula gitu. Akhirnya kita bikinin aplikasinya untuk menjadi rumah konten-konten hebatnya mereka gitu ya. Konten-konten video, konten-konten kebudayaan. Yang videonya pun juga coming from your text ya. Jadi itu emang tujuannya buat bagaimana kita belajar Indonesia, budaya Indonesia dari sumber yang terpercaya. Nah visinya gitu, menjadi platform aplikasi nomor 1 untuk kebudayaan Indonesia. Jadi tadinya statementnya bikin Netflixnya buat Indonesia, ya kita convert lah jadi aplikasi nomor 1 yang teman-teman bisa download sekarang di Android, di iOS gitu ya, di Android TV, di Apple TV kalau punya Apple TV. Dan bisa buka website-nya, saya percaya itu tidak seperti aplikasi pemerintah pada umumnya gitu. Jadi kita ada di Android, kita ada di iOS, kita ada di web. Webnya bukan kita yang buat anyway. Kita ngembangin aplikasi di Android TV-nya, kita ngembangin aplikasi di Apple TV-nya gitu ya. Jadi konten videonya punya banyak rumah ya, semuanya kita provide, reliable infrastructure gitu ya. Terus mereka minta, wah bikin streaming, adaptive streaming, pokoknya kayak Netflix lah pokoknya, ada recommendation engine-nya segala macam. Oke, it's not big deal, kita bikinin gitu ya. Terus untuk front end sendiri kita pakai Kotlin multi-platform. Jadi kalau sedikit ke front end kita bikin Kotlin multi-platform, jadi satu core terus kita utilizing buat front end di atas, jadi tinggal bikin front end tapi untuk data layer sama business logic layernya kita jadikan singleton modular gitu ya. Dan ini seperti ini arsitekturnya ya. Ya harusnya tahun ini kita ngerjain buat Tizen sama WebOS TV gitu ya, jadi nggak cuma ada di Android, Android TV dan tvOS gitu ya, tapi kita harusnya tahun ini develop buat Tizen sama WebOS gitu ya. Tizen tuh punya Samsung, WebOS tuh punya LG. Anyway, oke lanjut terus implementasi AI-nya seperti apa di Indonesia TV? Kita udah implementasi sebetulnya. Pertama adalah kita bikin personalized recommendation gitu ya. Jadi ya ngikutin kalau kalian pakai Netflix atau video.com gitu kan pasti kan ada kan untuk kamu gitu ya. Terus ada sectionnya ini disesuaikan dengan konten yang mirip-mirip dengan persona gua gitu ya. Persona orang-orang yang seperti gua langsung kita deliver seperti ini. Lalu yang kedua adalah rekomendasi tayangan sejenisnya. Ini bukan query based gitu ya. Ini semuanya kita lakukan dengan menggunakan recommendation engine. Simple sebetulnya kalau teman-teman pernah belajar kolaboratif sama content filtering, ya kita pakai itu sebetulnya. Terus caranya seperti apa kita bangunnya? Kita pakai TensorFlow, kita pakai scikit-learn, terus kita pakai Pandas, kita pakai PostgreSQL. Dan secara arsitekturnya pun juga tidak ngejelimet gitu ya. Ada core API-nya kita, terus kita buat service sendiri gitu ya. Terus core service kita tempatkan di luar dari core dari si Indonesia TV itu sendiri ya, buat service si machine learning-nya. Jadi udah microservices approach lah. Terus yang kedua adalah ini yang kita bangun, jadi kita pakai content filtering dan juga collaborative filtering. Content filtering berarti yang bakalan similarities dari konten, kalau collaborative filtering yang orang yang nonton yang sesuai dengan referensi saya dan kebanyakan orang yang nonton seperti saya gitu. Akhirnya konten yang ditampilkan itu mirip-mirip gitu ya. Ini prosesnya cukup sederhana sebetulnya, tidak ada yang ngejelimet gitu. Kita punya konten yang banyak, kontennya kalau nggak salah ada 800 video dan mereka juga punya metadatanya, alhamdulillah bagus gitu ya. Akhirnya kita mainin aja dan kita bedakan antara kolaboratif sama content filteringnya cuman di similarity scoringnya aja gitu ya. Terus ini preparationnya, kalau di perjalanan yang sebelumnya adalah kita dapetin datasetnya dari semua informasi yang kita dapetin, dari ya semua metadatanya lah ya, kita minta sama institusi terkait, which is klien kita, Kementerian Kebudayaan, Balai Media Kebudayaan, itu kita minta semua datanya, lalu kita bikin feature selectionnya, habis itu mecah semua jadi kata-katanya kita cleaning, kita removal semua karakter yang tidak perlu. Nah setelah itu baru kita training, kita pakai TensorFlow. Modelnya waktu itu apa ya, kita pakai apa ya modelnya? Oke, TensorFlow Recommendation Net, terus punya lu nih. Ya, terus kita
main ke singularity, calculate singularity using cosine dan kita ekstrak gitu ya dari proses extraction yang ada di matrix dan juga menggunakan TensorFlow dan ujung-ujungnya dari apa yang kita dapetin kita servisnya jalan, tinggal challenge, semua aplikasi front end-nya tinggal ngirimin aja user ini pernah nonton apa, historinya, lalu kebanyakan orang nontonnya seperti apa gitu. Muncullah hasilnya seperti ini gitu. Ini dengan content filtering sama collaborative filtering. Oke, nah pertanyaannya adalah, bukan itu yang mau kita bahas. Yang kita bahas adalah bagaimana kita bikin Gemini AI itu masuk ke dalam aplikasi OTT gitu ya. Nah, ini ada beberapa case tadi yang kita sempat angkat gitu ya buat POC-nya. Kenapa sih motivasinya? Ya karena kita sebagai pembuat aja kalau nonton videonya tuh agak susah untuk mencerna gitu kan. Agak challenging lah. Ini sebetulnya ngomongin apa sih, sebetulnya pesannya apa sih gitu kan. Dan akhirnya kita coba untuk bikin lebih interaktif dengan memanfaatkan si Gemini. Nah ini bold statement-nya adalah pahamin budaya Indonesia dari konten yang kita dari kontennya Indonesia TV itu dengan effortless gitu. Ingredients-nya kita pakai Gemini AI, Firestore, lalu Google Compute Engine dan juga PostgreSQL. Nah salah satu case-nya seperti ini. Jadi kita pengen sebetulnya intinya kayak kalau ini Figma-nya ya, Figma kita bilang kenapa sih Cilo menangis pada episode pertama gitu ya. Jadi lu nonton konten terus lu bisa komunikasi gitu ya. Komunikasi sama si agentnya, dia ngasih tahu dia tuh sebetulnya nangisnya tuh kenapa sih gitu kan. Momen apa sih sebetulnya atau pesan dari video ini tuh seperti apa sih. Akhirnya kita realisasikan karena kita bikinnya itu multi experience gitu ya. Multi experience tuh ada di TV, ada di smartphone. Akhirnya kita connecting dua perangkat tersebut sehingga extension experience itu dapat. Contohnya seperti ini gitu ya. Gitu. Jadi usernya nonton videonya terus habis itu lagi opening streamingnya. Oke. Gak lama ada di pojok ada diskusi di sini gitu ya. Terus kita klik dari remote, habis itu connecting dengan perangkatnya, kita scan gitu ya. Terus di scan sini kita tulis misalkan dia nanya, dia kenalin dirinya, apa pesan misalkan kita ngecek, kita texting apa pesan dari video ini gitu ya. Ketika di ini dia bakalan replay gitu ya, pesan dari video ini adalah bla 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 gitu ya. Terus yang kedua adalah kenapa Cilo menangis gitu ya. Nah ketika ditanyakan kenapa Cilo menangis, dia bisa tahu gitu ya momen tertentu kenapa sih gitu ya, keluar reasonnya seperti apa. Dan kita pengen balik nih momennya, di menit keberapa Cilo itu menangis gitu misalkan. Nah ketika diklik, dia bakalan bilang oke, Cilo menangis di menit kesekian gitu ya. Ketika kita klik tombol biru, itu experience di TV-nya langsung keluar ke momen si Cilonya menangis gitu. Ya, jadi itu extension experience yang kita coba bangun. Next. Nah, oke. Yang kedua itu talk about program gitu ya. Talk about program tuh lebih keseluruhannya ini program ini apa sih, video ini tuh dengan episodenya tuh menceritakan apa sih gitu ya. Nah ini kurang lebih videonya tuh seperti ini. Ini ya contohnya ini ya. Jadi dia nanya, Desa Timun itu program apa sih sebetulnya, tentang apa gitu. Terus ini dijelasin programnya tentang apa sih. Nah ini semua dari tadi ya, kita ngelakuin RAG, mostly RAG. Terus understanding transcription-nya juga. Apakah kamu tahu kejadian apa di episode 1 gitu kan. Nah ini dia dijelasin tentang apa sih sebetulnya, ada menit-menitnya gitu. Next, jadi ini companion yang buat si extension experience yang kita coba ciptakan. This is POC aja sebetulnya sih, berharap nggak jadi POC aja, cuman ya semoga dibuka keran buat budgetingnya pemerintah tahun ini. Oke, caranya seperti apa sih ini arsitekturnya? Secara umum arsitekturnya seperti ini aja kok, cuman kita pakai VM, Docker base, lalu semua dijalankan di Python, dikomunikasi dengan internal service-nya kita. Buat chattingannya kita pakai Cloud Firestore, terus semua datanya dilempar ke CDN. Nah kenapa butuh CDN gitu ya. Jadi kenapa sih tadi caranya gimana video itu, si Gemini itu bisa paham videonya. Nah cara yang paling kita lakukan, cara yang paling goblok untuk bisa bikin POC-nya itu jalan adalah kita nggak menggunakan vektor database saat itu. Jadi pertama adalah kita dapetin videonya lalu kita ekstrak. Ekstrak videonya, keluarin dari audionya dari videonya. Ya, itu easy banget dengan menggunakan FMP kan. Dari situ dapat audionya lalu kita lempar ke Gemini, Gemini ngelakuin speech to text. Keluar tuh kan, speech to text dengan prompting yang bagus, keluar di menit berapa, ini ngomong apa, menit berapa, ngomong berapa. Itu keluar semua, habis itu setelah di generate kita ngelakuin verifikasi. Jadi kita supervise. Bener nggak nih, kita sempat nonton tapi udah tinggal supervise aja, ini bener nggak teksnya nih. Gitu. Terus ya setelah verifikasinya itu oke gitu ya, kalau nggak oke kita balikin lagi ke Gemini. Kalau itu udah oke, transkripnya ini menjadi file. Kita jadikan file. Gitu ya. Jadikan file, nanti filenya ini yang nanti akan kita embed ketika kita bikin prompting. Kebayang di situ ya. Nah ketika ini dia ngelakuin usersnya tadi ngelakuin ngomong ya, melalui aplikasinya, dia bakalan ya jelas kita bakal ngelakuin something from engineering di sana. Cuman konteksnya itu berasal dari dokumen-dokumen itu. Karena dokumen-dokumen itu adalah transkrip audio yang udah kita lakukan, yang kita jadikan konteks dan knowledge yang dimiliki sama si Gemini sehingga ketika dia berbicara dia bisa ngambil dari source-nya gitu untuk mendapatkan jawabannya. Semua chat history-nya kita rekam di Cloud Firestore dan dia bisa nginget dia udah pernah ngomong apa aja dari sebelum-sebelumnya di konten yang sama. Kita desain seperti itu. Nah promptingnya template-nya seperti ini kok ya. Jadi kita coba ngasih se-clear mungkin, karena kalau misalkan kita promptingnya salah juga resultnya salah gitu kan, resultnya nggak presisi. Jadi kita juga trial and error di sisi promptingnya. Dan ini prompting yang kita coba desain sebaik mungkin dan hasilnya pun juga presisi ya. Kita juga ngasih tahu bahwa capability saya misalkan dia di menit keberapa, dia ngelakuin apa, jadi sudah tadi ya, seperti yang disampaikan sama Thomas, ada sisi yang kita bawa untuk bisa mengasih tahu bahwa si Gemini itu harus bisa mengkompos sesuai dengan kebutuhan kita dan hasil dari Gemini itu kita kompos jadi JSON base-nya kita tampilkan dalam visual gitu. Ini code-nya, jadi sesimpel tidak ada hal yang istimewa di sini gitu ya. Yang terpenting adalah kita dapetin dokumennya, kita jadiin itu knowledge-nya, kita punya prompting yang bagus, lalu kita lempar ke Gen AI ya. Karena Gen AI udah pintar gitu kan, dia tinggal bisa mengkompos sesuatu yang kita ekspektasikan gitu. Nah, hal kedua yang kita coba bawa adalah natural search gitu ya. Jadi bukan lagi gini, kenapa natural search? Karena konten kebudayaan tuh artisnya nggak terkenal men. Ya. Paling banter ada Chelsea Islan di sini gitu kan. Itu juga cuma 1-2 konten gitu. Sisanya nggak ada yang kenal. Nggak mungkin lu bisa melihat apa, misalnya lu melihat Dian Sastro di konten kebudayaan gitu ya, kecuali dia tampil di drama gitu. Nggak ada gitu ya. Makanya ketika kita pengen bikin search itu motivasinya adalah bagaimana senatural mungkin searchingnya untuk konten-konten yang ada di dalam aplikasinya. Ya, contohnya kalau secara visual Figma yang kita bangun kayak gini lah, coba rekomendasiin program yang mirip-mirip kayak Aku dan Laut gitu kan. Nah, contohnya seperti inilah. Nah, akhirnya kita realisasikan dengan seperti ini gitu ya. Jadi rekomendasikan saya program yang mirip dengan tepi sejarah gitu ya. Karena padahal di awal tuh kita coba untuk minta ke tim bahwa bagaimana caranya kita bisa tahu ketika dia nyari, tolong carikan saya konten video tentang tarian tradisional yang ada pada budaya Minangkabau. Nah, itu kan lebih kompleks lagi ya. Tapi itu possible sebetulnya. Gitu. Jadi akhirnya kita bikin yang seperti ini sebagai samplingnya yang visinya adalah menuju ke sana gitu. Nah, dia juga ada tambahin reasoning segala macam ya. Dan ketika diklik ya relevan kontennya seperti apa. Gitu. Jadi kalau diulang, rekomendasikan saya yang mirip dengan tepi sejarah gitu ya. Tepi sejarah salah satu program gitu kan. Terus yang kedua, dia bakal ngasih recommendation-nya, terus ini pakai MD Markdown, keluar terus kita tanyakan kenapa kamu merekomendasikan saya konten ini gitu ya, apa gitu kan. Terus ya dia ada alasannya, gitu kan. Nah ini penting banget untuk dapetin, pertama ya kita convert dulu teksnya, terus scriptingnya. Jadi di pipeline kita tuh ketika bikin tuh kayak harusnya setelah videonya tuh diupload ngelakuin transcoding, ini enggak. Jadi kita blok dulu transcodingnya, kita ngelakuin buat pemecahan dari video menjadi audio dulu, audionya kita jalankan secara paralel asinkronus ke Gemini untuk dapetin metadatanya. That's it. Oke. Nah, caranya nggak jauh-jauh, cuman kalau di sini kita pakai embedding modelnya udah pakai vector database di sini ya. Udah pakai vector database, jadi kita udah nggak pakai, apalagi udah nggak pakai si file. Jadi pakai dokumen hanya sebagai pendamping, karena kita ada beberapa metadata dokumen terpisah yang disiapkan oleh kementerian, dan semuanya adalah kita masukkan ke dalam vector database. Jadi inference-nya nantinya adalah buat knowledge context-nya itu larinya dari ke vector database. Oke, sebetulnya secara teori mekanisme flow-nya tuh nggak jauh beda, cuman bedanya di sini kita ada embedding model aja yang kita masukin ke dalam promptingnya sehingga si knowledge-nya itu jadi lebih kaya. Nggak basis cuman teks yang tadi seperti kita lakukan di awal. Terus dokumen-dokumen itu kita export, kita manipulate, lalu kita jadikan knowledge yang kita store di vector database. Kita menggunakan PostgreSQL di sini, dan itu nanti yang akan dibawa yang akan di-inference ketika si Gemini ini menerima prompting dari si pengguna. Dan hasil resultnya dari si Gemini itu akan di-store ke Cloud Firestore, sedangkan si aplikasi akan subscribe ke Cloud Firestore-nya. Oke, ini sistem template-nya buat prompting ya, salah satu yang paling utama kalau kita main di GenAI, salah satu ya promptingnya harus benar dulu sebetulnya. Jadi kita define siapa dia harus ngelakuin apa gitu. Jadi teknik promptingnya juga berpengaruh nantinya. Dan ini again, nggak ada yang something special di dalam code ini gitu ya, nggak ada yang rocket science lah, karena sisanya sudah diselesaikan gitu ya. Tinggal kita ngambil knowledge-nya seperti apa dari vector database, lalu kita inference-kan ke dalam si promptingnya. Oke, untuk selanjutnya saya persilakan Mas Iqbal. Oh ya, Mas Iqbal ini dulunya pernah ikutan Build with AI tahun 2024, 2 kali, akhirnya join NBS, ya play the game lah di dalamnya.
Oke, halo guys. Oke, saya akan lanjutin ya tentang mood based content recommendation. Sebenarnya kalau dari segi arsitektur tetap sama, which is kita tetap pakai hal yang sama ya. Tetap yang sama. Bedanya adalah ketika kita tidak menggunakan chat history di sini. Secara teknikal ya, tadi belum di-mention sama Bang Sidik.
Coba dilihatin dulu videonya biar ngerti konten base seperti
apa.
ya,
beberapa konteks ya.
Biar paham konteksnya seperti apa sih. Ya idenya sebetulnya saya pengen milih, cariin saya video yang berdasarkan dengan feeling saya gitu ya. Sini Pak, saya bantu Pak.
Sorry.
Oke, jadi ada chip beberapa feeling yang hari itu gitu ya, disesuaikan dengan mood. Ya challenge yang bakalan kita capture dari GenAI adalah latency ya. Wah lumayan nih latensinya gitu. Dan ini akhirnya kita misalkan saya pilih moodnya adalah senang gitu ya. Nah senang ini dia punya beberapa tuh.
Ya dia bakalan generate semua hal yang menurut LLM itu senang ya. Tapi ya kadang-kadang pasti hallucination ya yang kita bakalan tabrak gitu. Oke, lanjut aja langsung aja ke arsitektur. Oke, sama seperti yang tadi, tapi belum di-mention ya. Jadi untuk vector database kalau teman-teman belum familiar, kenapa saya pakai PGSQL di sini? Karena dia udah support juga untuk extension PG vector, tapi PG yang versi 13 ke atas ya teman-teman ya. Jadi kalau mau pakai aja. And then buat frameworknya, buat teman-teman yang nggak mau bikin dari nol, mungkin tadi langsung ke code bentar ya. Jadi di sini mungkin teman-teman bingung, saya dapat vector store simultaneous dari mana, chat prompt template dari mana. Mungkin teman-teman bisa baca dokumentasi dari LangChain ya. Di sini saya pakai LangChain biar lebih mudah juga developnya buat teman-teman yang mau belajar. Di Google Cloud yang kemarin, yang Road to AI itu ada penjelasan banget dari situ. Di Medium juga ada, bisa di search juga. Oke, nah di sini ada sistem template. Mungkin belum dijelasin tadi ya. Jadi teman-teman bisa lihat sistem template itu ada beberapa hal yang perlu dipahamin. Ada zero shot, few shot ya, few shot prompting, sampai ke chain of talk. Di sini saya pakai chain of talk dengan few shot. Teman-teman bisa lihat di sini saya menggunakan example, di mana itu few shotnya, dan ada chain of talk untuk kontek-konteksnya. Yang sebelumnya lebih parah lagi, lebih banyak lagi. Dan saya ngelakuin holding dulu sampai datanya selesai. Jadi di sini saya nggak ngelakuin streaming. Mungkin teman-teman bisa lihat di code-nya. Di sini nggak ada stream ya, karena kita butuh kebutuhannya sesuai dengan use case yang kita butuhin.
Ini agak beda sama yang sebelumnya kita pakai
Sebelumnya.
streaming ya. Kalau yang
Streaming.
pas di
Kalau yang
chattingan,
sebelumnya
kalau yang
dia ada
ini kita
streaming.
pakai langsung. Kita
Streaming.
nggak butuh
Nah,
streaming.
di sini ada K sama dengan 3 ya. Buat teman-teman yang tadi udah jelasin sama Pak Tamas ya, Mr. Tamas. K sama 3 sama aja, kita ngambil dari vector store 3 teratas yang mirip dari query kita. Misalkan saya query tadi senang, berarti dia bakal nge-search ke vektor yang ada senangnya. Entah itu senang itu dalam konteks banyak ya. Kan kita di sini pakai embeddingnya dari Google juga, text embedding 001. Kita juga nggak tahu dalamnya kayak gimana, kita langsung pakai aja. Oke. Oke. That's it ya, langsung aja. Jadi sebentar ya. Oke, sedikit aja ya teman-teman. Kalau kemarin ikut juara GJP juga ya, di sini juga udah dicontohin di juara GJP sebenarnya. Lebih enak lagi kalau mau ikut ya next juara GJP mungkin saya ikut. Saya di situ juga sering banyak banget contoh-contoh yang bisa dilakuin. Jadi saya implementasi dari sana. Ini saya pakai frameworknya Flash. Jadi teman-teman kalau Pak Tamas tadi pakai Node.js, which is JavaScript, TypeScript, saya rekomendasikan pakai Python aja ya, yang paling gampang. That's it ya buat hari ini dari saya, mungkin dari balik lagi Bang Sidik ya.
Ya jadi challenge-nya apa sih sebetulnya? Ya ini challenge-nya sebetulnya budgetnya belum ada aja sih. Jadi udah semangat kan bikin VOC kan. Wah tahun ini kita bikin AI gitu kan. Ya semoga lah bisa, ya karena agak challenging karena konten video dan berpengaruh juga pada token ya. Jadi token tuh terkait banget lah ya. Jadi bukan token PLN gitu kan, tapi token LLM itu berpengaruh banget. Semakin besar konteks lainnya, semakin besar token yang dipakai, ya semakin boros pula duit yang keluar gitu kan. Untungnya kemarin pas kita bangun, kita dapat kredit lah, jadi nyobain. Dan ketika ini dibangun juga sebetulnya kita nggak hanya pakai Gemini, kita cobain yang lain, kita cobain Qwen, kita cobain model yang lain. Cuman yang somehow ketika berbicara masalah konteks di video dan audio, Gemini is the best right now gitu ya. Dan ketika kita ngelakuin tadi ya, kenapa sih masih harus ada verifikasi manusia karena halusinasi, kita nggak bisa pungkirin itu. Jadi untuk mastiin bahwa ini sesuai dengan konteksnya, sesuai dengan apa yang dibicarakan, sesuai dengan metadata yang kita dapetin, untuk ensuring itu ya kita pastiin ada verifikasinya. Terus yang terakhir tadi teman-teman bisa lihat ada delay yang mengganggu gitu sebetulnya. Karena kalau misalkan nggak di streaming agak challenging sebetulnya. Cuman harusnya di model-model terbaru seperti 2.5 Gemini eksperimental yang sekarang itu sudah lebih baik dan sudah lebih cepat ketika merespons sesuatunya gitu ya. Dan kita nggak bakalan possible kalau saya, bukan nggak possible ya, butuh sumber daya yang lebih besar. Terutama untuk ngedeploy on-premise gitu kan. Jadi kalau teman-teman punya case customer lagi, mau deploy on-premise untuk enterprise gitu ya, itu sangat-sangat challenging karena butuh sumber daya yang paling besar, sumber daya yang cukup besar lah gitu ya. Harga VGA H100 sama P100 lumayan mahal gitu ya. Jadi kita coba untuk pakai mesin kita aja menggap-menggap gitu ya. Untuk mengorkestrasikan M4 aja tuh udah kalau ikan mas tuh mungkin udah kayak ikan mas ditaruh di darat gitu kan, menggap-menggap ya gitu. Jadi jangan dicoba-coba lah, sayang gitu. Terus fun-nya seperti apa sih? Fun-nya kita nggak seperti yang kebanyakan mainnya cuma teks, video, image gitu ya. Kita main ke video yang harusnya banyak banget yang bisa explore tadi ya. Nggak cuma meng-understand atau extend the experience buat dari existing platform, tapi bisa lebih dari itu harusnya. Cuman harusnya kalau misalkan ini diimplementasikan dan POC kita berhasil, itu bisa ningkatin engagement lah ke users. Jadi users lebih gampang untuk memahami konten video, terutama di kebudayaan. Yang kedua adalah pahami Gen AI foundation modelnya masing-masing punya limitasi gitu ya. Kita nggak bisa bilang ada silver bullet keseluruhan satu single model, all the things Gemini, enggak gitu ya. Kita udah coba beberapa, mereka punya uniqueness masing-masing yang bisa dipakai, bisa digunakan sesuai dengan case-nya teman-teman. Dan yang terakhir tuh kita having fun gitu ya, karena sebetulnya nggak cuman sama Gemini doang, tapi foundation models yang lain juga gitu ya. Ada pro dan cons-nya lah. Ya. Terus takeaways-nya yang pertama jelas ya, itu ya, nomor 1 hidup kita berbatasan dengan token gitu ya, terbatas sekali gitu ya. Jadi kalau teman-teman punya extra resource yang luar biasa tidak terbatas gitu ya, yang mungkin rekeningnya tidak punya limit nolnya gitu ya, nah itu mungkin bisa digunakan gitu ya. bisa dimanfaatkan, bisa dioptimize gitu ya. Nah makanya hal-hal yang sekarang bukan hanya bagaimana prompting yang benar sih sebetulnya, tapi bisa mengoptimasi terkait masalah resource yang digunakan. Berapa sih spendingnya gitu ya, berarti kan sizingnya juga harus benar gitu. Jangan sampai kita hanya bisa bangun tapi kita nggak mikirin sizingnya seperti apa, optimize-nya seperti apa. Nanti yang happy customer-nya, yang nggak happy adalah pemilik produknya ya kan, bayar billingnya kemahalan gitu. Terus yang kedua adalah sebelumnya kita ngelakuin traditional experience kita di machine learning gitu ya, on device machine learning di beberapa perusahaan gitu. Kita implementasi machine learningnya di dalam device, kita menggunakan TensorFlow Lite gitu ya. Terus prosesnya kita memaksakan laptop gaming untuk jadi mesin buat training data dan itu works gitu ya, dibandingkan kita harus bayar mahal di cloud. Jadi kita pakai cara seperti itu, cuman ketika kita dealing dengan experience di LLM itu nggak bisa dilakukan gitu. Jadi ya experience-nya cukup menyenangkan lah, mencari cara bagaimana bisa jalanin lokal LLM di local machine, tapi nggak bisa keep up juga gitu. Terus kecuali yang B-nya sedikit ya, kayak misalkan Gemini 27B gitu, itu masih possible untuk dijalankan. Ya, Gemma. Dan yang terakhir adalah, nah buat teman-teman yang mau implementasikan, karena ini sebetulnya tugas kita hanya memerintahkan dan mengarsiteki ya, karena Gen AI itu sebetulnya sudah pintar in nature, jadi pilihlah case-case yang relevan gitu ya. Karena kebanyakan sekarang saya melihat case-nya agak sedikit mengada-ngada gitu ya di AI gitu. Jadi pick relevan case yang benar-benar itu punya dampak, yang punya alasan, yang itu possible emang go to marketnya bagus. Mungkin Iqbal tambahan? Oke, itu aja dari kami. Semoga demo dan showcase ini bisa menginspirasi teman-teman. Terima kasih. Sip, thank you.
We take a leap into the future of life sciences. Please welcome Kezia Irene, Senior Bioinformatics Supervisor at Calvi Pharma TBK, as she unpacks the power of AI in decoding human life itself.
Halo semuanya, selamat siang. Senang sekali saya jadi hari ini di depan teman-teman semua Dan saya juga tahu kalau saya tuh satu-satunya hari ini ya pembicara wanita. Jadi harapannya bisa memberikan insight ke teman-teman tentang bidang saya, yaitu bioinformatics. Jadi hari ini kita akan belajar tentang decoding human life with Google AI. Apa itu decoding human life? Jadi kita terdiri atas sangat banyak organ ya di dalam tubuh kita. Dan di dalam tubuh kita juga banyak sekali sel-sel di dalam organ-organ tersebut. Nah, sebenarnya semua sel-sel itu kan mengandung DNA yang isinya adalah informasi-informasi tentang diri kita sendiri. Dan hari ini kita rencananya sih pengen coba ngelihat apakah kalau kita bisa mempelajari DNA dari kita, dari tubuh kita sendiri, apakah kita juga bisa mengerti lebih banyak tentang tubuh kita. Bahkan kita juga bisa misalnya memprediksi resiko kita akan sakit apa ke depannya, atau misalnya kita bisa tahu kita keturunan dari mana, dan juga hal-hal lainnya yang bisa diketahui oleh genetik. Seperti itu teman-teman. Oke, jadi perkenalkan, saya Kezia. Saya adalah seorang bioinformatician di Kalbe. Ini cerita hidup saya. Jadi 2016 saya memulai untuk berkuliah di bidang computer science di Universitas Indonesia. Di 2018 saya melakukan pertukaran pelajar ke Peking University. Di tahun 2019 saya memulai kegiatan saya sebagai asisten penelitian di RSCM atau Rumah Sakit Cipto Mangunkusumo. 2020 saya menjadi business intelligence di Shopee. 2021 saya mulai berkuliah lagi S2 di Harvard, jurusan Biomedical Informatics. Dan di 2021 juga saya melakukan, kalau kita di Harvard, kita boleh namanya ambil mata kuliah apapun di MIT. Jadi saya waktu itu juga mengambil beberapa mata kuliah di MIT. Lalu saya sempat magang di Stripe, which is perusahaan financial technology, di mana kalau mirip sama PayPal, kalau teman-teman semua tahu. Lalu 2022 saya berkesempatan untuk bekerja secara full time di Harvard School of Public Health. 2023 saya melakukan kerja part-time di Nala Genetics, dan saat ini 2024 hingga saat ini 2025 saya menjadi bioinformatician di Kalbe. Seperti itu teman-teman. Nah, kita mulai masuk ke dalam tubuh kita. Jadi kita tunggu videonya mulai lagi ya, ini videonya ngeloop. Jadi kita adalah seorang manusia seperti ini, dan di dalam tubuh kita itu banyak sekali terdapat organ-organ. Salah satunya adalah hati atau liver. Ini adalah sel dari hati kita yang memiliki banyak fungsi. Dan di dalam sel itu ternyata terkandung banyak sekali organel sel. Nah, saat ini saya mau minta kita semua coba ngebayangin sel itu sebagai kota yang modern. Contohnya misalnya anggap aja kota ini adalah Jakarta. Jadi kita tahu kota ini terdiri atas banyak sekali fitur-fitur, misalnya ada gedung-gedung mewah, lalu ada trotoar, ada lampu lalu lintas, dan ada misalnya pipa-pipa air dan lain sebagainya, fitur-fitur yang dimiliki oleh sebuah kota. Aku mau kita semua coba nganggep kalau sel di dalam tubuh kita itu adalah sebuah kota, misalnya kota Jakarta. Nah, di tengah-tengah kota itu, aku mau teman-teman ngebayangin kalau ada sebuah perpustakaan yang sangat besar yang isinya mengandung semua cerita dari kota-kota itu. Di mana kota itu didirikan, kenapa kota itu ada, misalnya tujuannya sebagai apa. Misalnya kalau Jakarta saat ini tujuannya adalah sebagai ibu kota. Lalu misalnya, kira-kira kalau ada kota ini yang rusak, misalnya gedung istananya rusak, instruksi ngebenerin kota itu juga ada di sana. Dan di mana itu adanya di ensiklopedia. Jadi di dalam perpustakaan itu terkandung ensiklopedia yang sangat panjang, yang isinya adalah bagaimana cara memperbaiki kota, informasi tentang kota-kota itu aku mau teman-teman ngebayangin tentang ini. Nah, perpustakaan itu kalau di dalam sel kita namanya nukleus, dan ensiklopedia itu kalau di dalam sel kita namanya adalah DNA. Coba kita lanjut ya. Nah, misalnya ya, contoh kalau ada nih pipa air di daerah Pasar Baru yang rusak. Masa aku harus ngebawa semua isi dari perpustakaan itu yang isinya buku-buku yang sangat banyak buat ngebenerin pipa air yang ada di daerah Pasar Baru. Ya nggak make sense dong. Masa aku harus baca satu-satu. Jadi kan aku males. Bagaimana cara yang lebih gampangnya biar nggak usah aku bawa semua buku yang ada? Caranya adalah bikin fotokopian dari misalnya, oh aku tahu nih di ensiklopedia yang ada tentang pipa rusak cuma di halaman 15 sampai 16. Ya udah, aku copy aja halaman 15 sampai 16-nya. Jadi sebuah kopian yang lebih gampang. Nah, fotokopi tersebut disebut sebagai transkripsi dan hasil fotokopiannya disebut sebagai mRNA. Nah, dari mRNA ini kan masih bentuknya seperti blueprint ya, yang dari ensiklopedia itu ditranscribe ke dalam bentuk blueprints. Nah, ini masih belum dingertiin sama tukang-tukangnya. Jadi tukang-tukang bangunan kalau disuruh baca blueprints kan pasti bingung, nggak bisa diminta untuk benerin pipa air gitu. Jadi perlu sesuatu yang nge-translate dan ditranslate menjadi apa? Menjadi sebuah instruksi yang sangat banyak yang akhirnya bisa dimengerti oleh protein, which is protein ini adalah anggapannya kalau di tubuh kita, anggapannya adalah seperti tukang yang bisa ngebantu untuk ngebener-benerin. Misalnya kalau ada pipa air yang rusak, oh ya udah panggil si tukang ini, panggil protein yang ini aja. Begitu. Jadi DNA adalah ensiklopedia yang besar. Transcriptomics adalah instruksi-instruksi yang merupakan kopian dari DNA tersebut. Dan proteomics atau protein, studi yang mempelajari protein adalah tukang-tukang yang sebenarnya betul-betul memperbaiki sel-sel tersebut. Nah, berarti kan kita punya banyak banget data ya, dari tadi ada genomics, ada transcriptomics, ada proteomics juga. Sekarang masalahnya di mana? Masalahnya adalah kita punya lebih dari 3 juta miliar base pair, dan ini tuh baru genomics doang. Di dalam tubuh kita, padahal cuma orang kayak gini aja, kita punya lebih dari 3 miliar gitu. Jadi kita punya lebih dari 3 miliar DNA di dalam tubuh kita. Nah, pusing nggak kalau kita harus nge-store ini ke dalam database kita? Gimana caranya coba? Kalau semua orang punya 3 miliar data, satu orang punya 3 miliar rows, misalnya orang kedua juga punya 3 miliar rows, orang ketiga punya 3 miliar rows. Kan nggak make sense, mau berapa petabyte yang perlu untuk nyimpen data misalnya rumah sakit yang isinya ada ribuan orang gitu. Dan bahkan ini 3 miliar itu belum include misalnya clinical data, misalnya hasil tes darah orang ini tuh bagaimana, hasil uji imunitas orang ini tuh bagaimana, ini tuh semuanya belum include. Jadi ini permasalahan yang kita miliki sekarang terhadap data-data tubuh kita, data-data DNA kita. Solusinya, belum sampai solusi. Oke, dan permasalahan berikutnya, bioinformatic pipelines are painful. Jadi ini adalah contoh dari Profesor Kim dari Korea Selatan. Waktu itu kemarin saya menghadiri conference-nya beliau. Jadi beliau itu menentukan kira-kira kita tuh alergi sama sesuatu obat atau tidak menggunakan data-data anti-cancer drug dan drug resistant cancer cells. Jadi kita mesti menganalisis bahkan dari sisi obatnya. Misalnya obat-obat itu kan ada struktur-struktur molekulernya ya, seperti yang bentuk-bentuk kimia kalau teman-teman yang pernah belajar kimia di SMA. Dan kita juga mesti harus mempelajari bagian dari selnya yang DNA yang ada lebih dari 3 miliar itu. Bagaimana caranya? Ya pusing banget dong, lihat itu datanya manual dan siloed. Jadi misalnya di Indonesia kita harus datang ke rumah sakit buat misalnya minta data-data DNA. Lalu pipeline ini juga sangat-sangat slow, lambat dan juga kaku gitu. Kenapa? Misalnya kalau obatnya diganti, ini bukan obat kanker lagi ya, diganti misalnya jadi obat hipertensi atau obat darah tinggi gitu. Ya, semua pipeline-nya harus berubah, semua analisisnya harus berubah. Dan ini kan satu riset aja bisa makan waktu kira-kira 2 tahun gitu. Mau berapa lama lagi kalau kita misalnya cuma ngubah obatnya doang seperti itu. dan juga sangat error prone. Misalnya kalau ada data yang rusak sedikit, misalnya kalau ternyata data di kromosom nomor 15 dan posisi ke 50 itu keganti sedikit, tiba-tiba mesinnya ada error, pipeline ini tuh udah langsung mampus, udah nggak bisa lagi untuk memproses. Dan ini juga kalau teman-teman yang belajar tentang scalable machine learning, kita tahu dong kalau kita bikin pipeline kayak gini terus-terusan, ini nggak scalable. Apalagi kalau ini mau dikembangin ke misalnya ke orang-orang di luar negeri begitu. Dan ini aku kalau boleh jujur, bahkan bioinformatics pipeline-ku juga sangat-sangat painful, sangat-sangat menyakitkan. Jadi yang bisa kita lihat ini banyak banget proses yang aku mau kerjakan, tapi karena waktu itu aku tuh belum sempat mikir gimana cara baiknya nge-scale. Aku mindsetnya masih riset, penelitian, dapetin hasil. Jadi belum sampai mikir, oh nanti kalau mau dikembangin lagi ke penyakit lain, bagaimana ya caranya? Gitu. Jadi kalau boleh jujur, awalnya bioinformatics pipeline-ku juga sangat-sangat painful, guys. Nah, solusinya bagaimana? I want to introduce you Google AI. Jadi Google saat ini punya banyak sekali fitur-fitur yang available untuk pipeline bioinformatics yang bisa kita pakai. Jadi gunanya bioinformatics pipeline menggunakan Google apa? Yang pertama adalah democratize infrastructure. Jadi daripada kita bikin dari awal misalnya, oh aku mau nge-ingest data-data DNA, oh aku mau nge-analisis struktur dari obat. Mendingan pakai Google aja yang sudah ada. Jadi nggak perlu untuk mikirin cluster, mikirin memori, mikirin misalnya, oh CPU-nya nggak muat nih, padahal udah di-define segini gitu. Lalu yang kedua, Google itu memiliki built-in machine learning tools. Jadi kita misalnya bisa langsung jump in ke model building dan prediction. Yang ketiga adalah scaling, automation, and integration. Nah ini adalah yang belum waktu itu aku pikirkan pada saat aku mendesain bioinformatics pipeline-ku. Jadi sebenarnya kan bioinformatics pipeline itu ada yang bisa sequential, ada yang harus concurrent, ada yang bisa, ada yang bisa concurrent, tapi ada yang harus sequential, ada yang harus menunggu data yang lain selesai dulu baru bisa menjalankan data yang satu lagi. Gitu. Jadi semuanya itu bisa dikontrol melalui Google AI yang banyak platformnya. Ini aku singkat ke dalam Google AI dulu ya. Nah, bioinformatics pipeline itu kan menyangkut kita memiliki raw data, memiliki storage, processing, model, dan visualisasi. Nah dari raw data, bagaimana kita bisa memasukkan ke storage? Kita menggunakan GCS atau Google Cloud Storage. Yang kedua, misalnya dari storage, kita mau jadi processing. Berarti kita perlu konektor dong antara dari storage, bagaimana caranya untuk bisa ke arah processing. Jadi kita menggunakan data flow. Dan dari processing ke modeling, itu juga memerlukan cara lagi. Karena kalau misalnya kita bikin model kan di machine learning, kalau nggak bisa di scale, modelnya tidak reproducible, nggak bisa diulangi lagi, ya itu juga modelnya kurang baik ya, jadi agak percuma dan sangat painful based on my experience. Nah, kalau modelnya udah jadi, fungsi lainnya yang bisa digunakan oleh Google adalah memvisualisasi. Jadi kita bisa melakukan visualisasi menggunakan BigQuery atau menggunakan Looker. Kita akan bahas detailnya sekarang, coba ya. Nah yang pertama data ingestion. Jadi kita bisa menampung data-data raw genomics kita. Kalau teman-teman pernah belajar di SMA, data genomics itu contohnya ACGT ya. Seperti misalnya kodenya ACGT, ACGG, dan semua orang itu punya filenya seperti itu. Nah file-file ini tuh disimpan dalam bentuk FASTQ atau BAM, atau yang sudah diolah lagi menjadi bentuk VCF atau variant call format. Nah kita bisa simpan di Google Cloud Platform yang merupakan GCS ini, seperti ini bentuknya. Jadi sebenarnya mirip banget dengan Google Drive. Jadi that's why it's very easy. Bahkan semua orang yang nggak bisa ngoding pun bisa pakai GCS. Nah dari GCS ada konektor yang bisa menghubungkan ke Google BigQuery. Nah, dari Google BigQuery kalau teman-teman pernah pakai SQL, pernah dong ya semuanya, itu gampang banget untuk mengquery data-data DNA. Misalnya kalau aku mau ngambil data DNA pasien A atau data DNA pasien B, itu tinggal select bintang from table apa, where apa. Dan ini bisa langsung terkonek ke Google Cloud Storage gitu. Jadi ini sangat gampang. Dan Google untungnya juga menyediakan healthcare API. Jadi ada interoperability yang cukup baik antara sistem rumah sakit, misalnya kalau nanti teman-teman ada yang kerja di rumah sakit ya, dengan clinical system yang ada di Google gitu. Kita lanjut ke data processing. Nah, tahap kedua yang setelah dilakukan misalnya data raw-nya udah di-ingest nih, udah masuk ke dalam Google Cloud Storage dan udah kita proses ke Google BigQuery, yang bisa kita lakukan adalah data pre-processing gitu. Jadi bagaimana kita mengolah data-data yang kotor, misalnya data-datanya ada bolong-bolong nih. Misalnya data di kromosom 16. Kromosom 16-nya ternyata ada 5 pasien yang nggak punya data-data seperti pasien-pasien lainnya. Atau misalnya data fenotipnya ya, data-data klinikalnya, misalnya pasien ini memasukkan tinggi badannya 1 cm. Itu kan nggak mungkin, dan ini case yang betul-betul aku alamin. Nah, jadi kita bisa menggunakan data flow untuk apa? Untuk membersihkan, menormalisasi, dan mentransformasi dataset kita. Dan ini yang sangat-sangat aku pakai adalah Vertex AI Pipeline. Jadi Vertex AI ini powerful banget dan interface-nya juga sangat-sangat simple. Sesimpel Jupyter Notebook atau Google Colab kalau teman-teman ada yang pakai. Jadi Vertex AI ini membantu mengorkestrasi pre-processing steps dengan full tracking dan juga reproducibility. Dan reproducibility ini kalau boleh jujur adalah masalah terbesar yang kita hadapin dalam dunia riset. Ini nggak bekerja. Oke. Aku coba cabut dulu, sambungin lagi. Semoga bekerja habis itu ya. Makasih. Iya, terima kasih ya buat kesabarannya. Kita lanjut ke step yang berikutnya. Ini yang paling pusing dan paling malesin adalah omics analysis. Ini adalah bread and butter-nya dari analisis bioinformatics. Jadi ini aku bedain warnanya karena ini beda steps. Jadi ini step-step bioinformatics, teman-teman pasti akan pusing kalau enggak tahu bioinformatics sebelumnya. Tapi ini aku singkat aja sih, karena nanti kita akan ada demonya dari steps lain. Dan jadi ini kalau teman-teman interested di bioinformatics, teman-teman bisa hubungin aku atau nanya aku ke depan. Nanti di sesi Q&A aku bisa bahas lebih dalam, tapi aku nggak mau bahas dalam-dalam sekarang. Tapi bioinformatics analysis itu termasuk ada variant calling, quality control, association study, polygenic risk score atau mempelajari seberapa besar resiko kita terhadap suatu penyakit. Lalu ada juga clinical data integration, yaitu mengintegrasikan data-data klinis ke dalam data-data bioinformatics. Lalu ada functional genomics, SNP enrichment, dan product recommendation terakhir. Gitu kira-kira. Ini nggak jalan, oke. Nah, ini yang interesting, nanti kita akan ada demo sedikit ya tentang ini. Jadi, memprediksi disease risk bisa banget menggunakan BigQuery ML. Nah BigQuery kan itu awalnya kita taunya itu cuma SQL ya. Kita nggak tahu kalau BigQuery itu ternyata bisa juga ternyata untuk jadi tools buat machine learning. Nah ini hal yang interesting juga dan belum beberapa lama ini saya pelajarin. Jadi kita nanti akan coba memprediksi dari raw genetics data, misalnya ada patient ID, ada BMI kategori, ada gen. Di sini aku cuma pakai 2 aja gennya dari 3 miliar yang kita punya. Ya mohon dimaklumi kalau data yang kita masukin 3 miliar selesainya akan bulan depan mungkin. Dan kita akan masukin ke BigQuery ML dan kita akan mencoba membuat obesity prediction di sini. Misalnya dari data-data gen yang sudah disediakan, apakah orang ini akan diprediksi obesitas atau tidak, seperti itu. Nah, step terakhir yang dilakukan oleh seorang bioinformaticians adalah melakukan visualisasi. Karena kalau misalnya kita mau publish paper atau kita mau present ke misalnya direktur, visualisasi ini menjadi sangat penting. Jadi ini contoh visualisasi yang saya ambil dari sebuah paper di pas COVID. Jadi ini adalah peta visualisasi COVID. Jadi misalnya kita bisa ngelihat awalnya, oh ini bisa nyala nggak bisa. Jadi kita bisa ngelihat dari yang hijau itu awalnya kalau pertama yang virus varian apa yang populer kalau nggak salah itu 21K Omicron, lalu menjadi yang 21L Omicron, lalu misalnya menjadi varian-varian lain. Tapi di situ juga ada varian Delta yang ternyata memakan banyak orang juga gitu. Ini divisualisasikan dari Januari 2022 sampai Desember 2022. Oke, maaf. Oke, kita akan ada mini demo. Aku mau minta teman-teman semua kalau mau ngikutin, ini kita bisa coba scan QR code yang ada di sini, atau kalau mau bisa juga memasukkan kode ini s.id/kezia/genomics. Semuanya udah? Ada yang masih punya masalah? Ada yang nggak bisa? Udah? Oke, kita coba lanjut ya. Iya, jadi teman-teman akan melihat seperti ini, tetapi ini kodenya sayangnya tidak bisa dijalankan di Google Colab, jadi ini tuh hanya sebagai untuk membantu aja, dan kodenya ini dijalankan di mana? Kita jalankan di BigQuery. Jadi kalau teman-teman punya akun BigQuery atau nggak punya, teman-teman bisa daftar, dan teman-teman akan dapat gratis $300 kredit dalam pendaftaran pertama, tanpa harus membayar apapun. Seperti itu. Ini aku gedein. Jadi kita bisa mengcopy aja kode yang ada di sini. Kalau teman-teman udah ada yang buka ya. Misalnya di sini, di query pertama ini kita akan meng-create pasien. Kenapa? Karena kalau kita harus memasukkan data dari yang tempat lain itu akan perlu konektornya, akan memakan waktu lama dan tidak bisa didemoin. Dan demo ini hanya 5 menit ya. Gitu. Jadi kalau kita run, ini akan dibuat sebagai table baru, yaitu table namanya phenogenodata. Kenapa phenogeno? Karena data ini mengandung fenotip yang merupakan data-data clinical pasien dan juga genotip, yaitu data DNA pasien. Dan tabelnya ini bisa kita lihat di sini, di phenogenodata di sini ya. Jadi kita bisa preview juga datanya seperti apa. Nah, udah masuk kan ya ke dalam table ini. Jadi ada pasien ID dari 1 sampai 10, BMI-nya berapa, BMI kategori. Jadi di sini aku kategorikan BMI orang dari 0 sampai pokoknya BMI orang yang di bawah 27 tergolong normal, sementara di atas 27 itu tergolong obesitas. Seperti itu. Jadi ini sudah masuk. Kalau sudah, kita bisa jalankan kode yang kedua, yaitu one hot encoding. Di sini kita coba buat one hot encoding, di mana kita melakukan hot encoding terhadap gen yang ada di orang tersebut. Misalnya kalau AA, yaitu gen AA-nya jadi 1, sementara kalau tidak 0, dan seterusnya dan seterusnya. Gunanya apa? Untuk mempermudah melakukan prediksi ke depannya. Kalau kita jalanin kode ini, maka kita akan menyimpan table baru, yaitu namanya ada, lupa namanya, bentar, phenogenodata encoded gitu. Setelah itu kita bisa jalankan logistic regression model kita. Jadi di sini input labelnya adalah BMI kategori. Jadi kita ingin memprediksi dari data DNA seseorang apakah orang itu obesitas atau normal. Gitu. Jadi yang kita masukkan adalah BMI kategori. Dan di sini juga kita memasukkan misalnya fitur-fitur apa yang ada di table kita, misalnya gen 1 dan gen 2. Seperti itu. Lalu kita from table kita yang tadi, phenogenodata encoded. Oke, kalau kita run, ini akan menghabiskan waktu sekitar 1 menit. Jadi mungkin kita bisa skip aja steps yang ini, atau saya bisa coba ngejelasin steps yang berikutnya. Step berikutnya adalah mempredik results. Jadi prediksi results ini kita bisa lihat dari, kalau kita mengambil model dari phenogenodata encoded model. Sorry ya kepanjangan. Ya karena itu dari tadi aku tambahin imbuhan terus. Dan ini kita bisa memasukkan ke dalam sebuah table gitu. Ini contoh modelnya, kemarin aku sudah nge-run, jadi kemarin tuh 9 Mei. Dan kemarin aku sudah nge-run, jadi ada model logistic regression, actual iteration-nya berapa, lalu minimal relative progress-nya berapa, dan fitur-fitur lainnya. Hasilnya seperti apa? Hasilnya bisa kita lihat di sini kesimpan juga sebagai ada prediction-nya. Kalau kita jalankan, ini adalah contoh prediction-nya ya. Jadi pasien 7 misalnya, yang predicted-nya adalah obesitas. Kenapa? Karena probability untuk obesitas orang ini adalah 0,99 dan bisa kita lihat kalau BMI-nya 41,2, berarti orang ini benar-benar obesitas. Dan orang yang nomor 2 itu BMI-nya 27, kita predik kalau orang ini obesitas juga, berarti kita benar memprediksinya ini normal dan ini juga terprediksi secara benar. Jadi ini mesinnya cukup bisa belajar ya. Mungkin salah satunya adalah karena saya memberikan contohnya yang sangat obvious untuk mesin ini bisa mempelajari. Di dalam kesehariannya nggak semulus ini, tapi ini adalah contoh yang bare minimum yang sangat gampang, sehingga mungkin teman-teman kalau nanti mau coba di rumah juga bisa, kan udah ada kodenya ya. Oke, kita lanjut. Ini real use case-nya, ini jadi pipeline-nya jauh lebih panjang dan jauh lebih mengesalkan, to be honest. Jadi pipeline-nya memerlukan imputasi. Tadi kan yang aku bilang kalau datanya misalnya ada yang hilang di kromosom nomor 16 atau hilang di kromosom nomor 15, kita harus ngelakuin yang namanya imputasi di data genetik. Lalu kita membuat sebuah PRS model di mana kita memprediksi resiko obesitas seseorang. Misalnya kalau aku dibandingkan dengan kalian semua, oh ternyata aku itu resiko obesitasnya ada di persentil sekitar 90-an. Berarti resiko obesitasku lebih tinggi daripada 90% dari kalian semua. Lalu kita juga mengetahui kalau diperlukan ancestry adjusted, kenapa? Karena kebanyakan studi-studi DNA dilakukan terhadap orang-orang Eropa saja. Dan kita tahu kalau genetik dari orang Eropa itu berbeda dengan genetik dari orang-orang Indonesia, seperti itu. Jadi kita perlu melakukan ancestry adjustment untuk mengurangi bias-bias yang disebabkan oleh perbedaan populasi tersebut. Dan yang terakhir kita juga perlu membandingkan dengan prevalensi yang ada di Indonesia. Misalnya obesitas di Indonesia itu prevalensinya sekitar 24%. Oleh karena itu misalnya orang yang ada di atas 75 persentil kita kategorikan sebagai resiko obesitasnya sangat tinggi, seperti itu. Ini kayaknya kalau terlalu jauh nggak akan bisa jalan lagi deh, error lagi. Oke, ini adalah real use case, jadi misalnya ini adalah hasil dari prediksi saya. Bisa kita lihat kalau ini adalah AUC erosi curve, di mana kalau AUC-nya itu cukup baik, kalau misalnya tegak lurus ya seperti ini. Tapi ini AUC-nya ada di sekitar 0,7, artinya model ini cukup bisa membedakan orang yang obesitas dan orang yang tidak obesitas. Kita bisa lihat odds ratio-nya itu adalah 3,89, artinya apa? Artinya kalau kita diprediksi memiliki obesitas, kita memiliki potensi obesitas 3,89 lebih banyak daripada orang lain, dan positive predictive value yang 78,13% ini menggambarkan kalau kita memiliki 78,13 orang yang kita prediksi sebagai obesitas akan menderita obesitas, seperti itu. Nah ini mungkin cepat aja bonus, game ini bisa dipakai nggak di sini? Bisa banget. Setiap hari aku pakai game ini. Kenapa? Bisa sebagai asisten penelitian pribadi aku dong. Jadi bisa membantu melakukan literatur review, gene prioritization misalnya, oh sebaiknya kita fokusin di gen yang ada di kromosom, misalnya kromosom 15. Lalu ada hypothesis generation, lalu data interpretation, dan juga yang paling utama kalau bioinformatics adalah dokumentasi. Permasalahan yang ada, nah sekarang kan misalnya kita udah nge-solve nih permasalahan bioinformatics pipeline kita. Apa ini udah nge-solve semua permasalahan? Jawabannya ya enggak. Kenapa? Karena di dalam si kesehatan, apalagi di AI di bidang kesehatan banyak sekali masalah-masalah yang saat ini kita belum bisa mengatasi. Dan aku ingin mengajak teman-teman semua yang ada di sini, yuk kita kalau boleh pikirin bareng-bareng karena ini juga mencakup kesehatan kita sendiri. Permasalahan yang pertama adalah data privacy. Data privacy itu sangat bermasalah, misalnya kalau sampai data genetik kita nyebar ke orang lain, orang itu bisa tahu misalnya kakek nenek kita siapa, lalu misalnya kita punya gejala penyakit-penyakit apa, itu semua orang bisa tahu dan itu sangat-sangat berbahaya. Dan yang kedua adalah bias dan fairness. Kita tahu kalau machine learning bisa memprediksi seseorang itu misalnya menderita penyakit apa. Tapi kan kalau datanya yang dimasukin sampah, misalnya data yang dimasukin adalah data hasil misdiagnosis dari dokter, maka hasil keluaran mesin itu juga sampah. Gitu, itu adalah permasalahan kedua. Permasalahan ketiga adalah lack of validation. Banyak banget model machine learning yang ada untuk kesehatan sekarang, tapi nggak pernah divalidasi ke clinical trial atau ke pasien-pasien sebelumnya. Dan apa jadinya kalau model yang ada itu nggak pernah divalidasi, yang ada adalah membahayakan nyawa pasien, seperti itu. Lalu limited data, jadi orang-orang banyak yang bilang, oh machine learning saya bagus, tapi ternyata datanya itu cuma ada misalnya 1.000 atau 2.000. Dan jadi model itu saat dicoba digeneralisasi ke populasi yang luas, model itu sangat-sangat gagal. Jadi lack of standardization, dan yang terakhir yang paling utama masalah yang kita hadapin adalah limited explainability. Jadi model yang dibuat oleh machine learning itu tidak bisa dingertiin oleh dokter. Jadinya apa? Jadinya nggak ada gunanya. Buat apa kita bikin machine learning capek-capek kalau dokter juga nggak ngerti datanya jadi seperti apa. Oke, terima kasih sudah mendengarkan pembicaraan saya panjang lebar. Sebenarnya ini ada 5 key takeaways yang aku pengen teman-teman mungkin dapatkan dari talk ini. Yang pertama, bioinformatics itu data intensif. Jadi yang kita lihat ada 3 miliar base pairs di dalam tubuh kita. Jadi sangat luar biasa ya teman-teman. Yang kedua, there is a dire need for streamlined workflows di bioinformatics. Sehingga kita perlu menggunakan Google AI. Dan Google AI gunanya adalah merevolusi genomics insights yang bisa kita dapat dari diri kita. Dan yang keempat, game ini gunanya bisa jadi sebagai riset asisten kita ya. Jadi bisa membantu banyak sekali dari hypothesis making sampai ke decision interpretation dan lain-lain. Yang kelima terakhir, AI di dalam healthcare ini already happening guys. Jadi mau nggak mau di masa depan pasti kesehatan itu akan dibantu oleh AI. Dan itu juga udah terjadi sekarang juga. Dan ini mungkin untuk penutup, jadi mau membawa balik ke analogi kota, sel itu adalah kota yang saya mention ya di awal. Jadi cells are smart cities. AI itu adalah seperti urban planner-nya. Oh sebaiknya misalnya kota ini dibangun gedungnya di sini loh, kenapa bukan di sini? Karena misalnya di sini daerah yang lebih bagus gitu. Dan Google AI enables us to accelerate discovery, insights, dan aplikasi. Gitu. Jadi Google AI memudahkan kita untuk mengaplikasikan bioinformatics ke dalam kehidupan nyata. Terima kasih teman-teman sudah mendengarkan. Saya mohon teman-teman memberikan feedback. Ini sangat singkat, ini formnya sangat singkat, misalnya formnya hanya 5 menit saja tentang skill presentasi saya. Dan kalau ada kekurangan atau ada masukan juga boleh dimasukkan ke sini. Terima kasih semuanya sudah mendengarkan. I will welcome you if you have any questions. Thank you.
Now, it's time to open the floor for your questions and reflections in our Q&A session. Joining us are our incredible morning speakers, Thomas Piros, Sadiq Permana, and Kezia Irene. Feel free to raise your hand or drop your questions through the virtual chat. Let's make this an interactive and insightful dialogue.
Selamat siang semuanya. Masih semangat nggak? Nah, dari pagi kita udah banyak hands on ya. Mulai dari kita mengenal dasar AI, LLM, terus diliatin sama Mas Sidik terkait implementasi in real life. Terus kita belajar something new ya. Mungkin mostly di sini teman-teman software engineer backgroundnya ya. Nah tapi di sesi ini kita sangat beruntung bisa kedatangan Kak Kezia. Jadi kita belajar ternyata AI itu ketika dia digabungkan dengan bidang ilmu lain, kita bisa memberikan impact yang jauh lebih besar. Nah, tanpa lama lagi, saya undang speaker-speaker keren kita, Kak Kezia, Mas Sidik, dan Mas Iqbal. Jadi tadi harusnya masih ada Mas Tamas ya, tapi beliau lagi mau kejar flight. Jadinya harus berangkat lebih dulu karena bakal ngisi juga di GDG Bali. Gitu ya. Gimana? Hari ini kita full house nih. Kak Kezia, Mas Iqbal, Mas Sidik. Kita bakal jawab pertanyaan dari teman-teman. Kita mungkin mulai buka untuk teman-teman yang ada yang mau angkat tangan dulu ya. Saya bakal pilih 2 dulu. Yuk, 1, 2, turun dulu. 1, 2, 3. Mas ini yang lengannya baju kuning. Kak.
Baik, selamat siang. Terima kasih untuk kesempatannya. Perkenalkan, nama saya Dorino. Saya ingin tadi sih tertarik sama presentasinya Mas Sidik ya dari NBS. Jadi mungkin ini ngomong kayak mantan. Sebelumnya saya pernah di NBS juga. Saya ML engineer juga, udah pindah sekarang sih. Nah, saya tertarik karena sekarang juga lagi develop RAG juga di tempat saya bekerja. Bedanya ini full on premise karena mungkin uangnya uang BUMN ya, jadi cukuplah mereka. Nah, saya mau tertarik sebenarnya sama yang tadi dijelasin sama ML engineer-nya, yang soal, jadi kan proses, ini agak teknikal mungkin ya, jadi prosesnya kan dari video bakal diekstrak transkripnya bakal disimpan di vector database. Nah itu untuk metode chunkingnya itu kan karena datanya kan bakal konstan sama. Nah itu metode chunkingnya gimana? Apakah per detik, per transkrip per detiknya dipecah chunknya atau ada konteks window-nya. Nah itu yang sebenarnya pengen aku tanya, metode chunking buat ditanya yang ketika kenapa kayak di menit keberapa dia bisa nangis atau bukan, nah itu tuh gimana? Mungkin agak teknisnya mungkin ML engineer-nya atau Mas Sidiknya juga ngerti, boleh silakan.
Ini pasnya sama Iqbal ya kayaknya.
Boleh,
Karena
boleh.
case kemarin yang ngurusin dia tuh.
Boleh, saya sebelumnya
Gue ngonekin di aplikasi mobile ya.
Oke,
Silakan
siap.
Bal.
Oke, thank you buat pertanyaannya. Mas Dorino ya?
Ya, betul.
Oke, Mas Dorino. Salam dari Bang Novan ya. Oke, sebenarnya buat masalah gimana kita nge-manage itu ya, nge-manage konteks ya lebih tepatnya dari RAG-nya. Sebenarnya kalau sampai lihat tadi di sistem prompt kita, itu sebenarnya ada konteks yang tetap kita bawa. Di sistem prompt kita, konteks kita bawa. Jadi setiap dia ngelakuin bikin session, dia bawa konteks tuh. Konteksnya dari query kita yang kita ambil dari vector database. Which is tadi kita ngambil 3 paling utama gitu. Jadi seperti itu sih Mas. Simpelnya itu paling simpelnya. Ada tambahan lagi mungkin, bisa 2 arah mungkin. Oh, nggak bisa ya.
Udah.
Nah, iya sebenarnya kan itu top K ya, top K-nya yang diambil 3. Nah itu aku pengen tahunya tuh metode chunking-nya gimana sebelum dipecah jadi chunk-chunk kan ada metode kalau biasanya mungkin yang lebih general itu per karakter dipecahnya dari transkripnya. Nah itu ada metode spesifik nggak kalau buat yang nge-chunk transkrip video?
Kalau yang kita lakuin sebenarnya ada sebenarnya dikit. Cuman sedikit aja dari Bang Novan itu sebenarnya yang handle masalah chunking. Jadi kita ngelakuin chunkingnya, kita cleaning dulu sebenarnya. Jadi sebelum itu ada cleaning dari data sebelumnya. Jadi data yang kita chunking itu adalah data dari database production, which is the production buat data-data tentang staging lah, presentation itu kita chunking. Kita bawain semuanya tuh, kita cleaning kayak biar tokennya dikit ya lebih tepatnya. Jadi kita kayak titik, koma, bla 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 itu kita hilangin. Terus di wipe out semuanya kayak yang tadi ya, yang di recommendation system, stemming dan sebagainya, kita lakuin itu juga. Karena nggak dibutuhin sih. Dan di best practice yang saya dapetin dari kemarin di build yang AI Roadshow itu, kita harus pre-processing ya sebelum ngelakuin vektorisasi pakai Google Text Embedding. Itu dari Kojowan sih kemarin. Gitu.
Oke, berarti nggak ada metode khusus kayak untuk dapat konteks transkrip misalnya kan kita anggap, saya agak buta sih kalau video ya, mungkin per detik tuh kan ada pembicaraan. Jadi itu Mas Iqbal mecah chunk-nya itu per satu conversation
Satu
conversation
biar dapat tuh.
Oke, udah.
Per subtitle yang keluar itu kita chunking di situ.
Oke, thank you. Itu aja sih yang pengen aku tahu. Terima kasih Mas Iqbal, Mas Sidik. Oke, udah.
Oke, kayaknya pertanyaan itu sama seperti yang di slide ya. Yang paling pertama, any tips for reducing token usage ya. Mungkin kita biar sekalian menjawab yang di slide ya. Kayaknya tadi udah ditanyain soal token usage, how to evaluate nih Mas Iqbal. Katanya ditanyain how to evaluate the fine tune model.
Kalau case kita nggak sampai evaluate kemarin karena again just POC kan. Kalau mau di productionin ya kita berpikir ke sana sih pastinya. Harusnya sih kalau evaluate ya itu udah ada best practice-nya di dokumentasi terkait ya. Di Gemini itu udah ada. Jadi harusnya tinggal mengacu ke sana dan kalau mau lihat lebih observability-nya tuh beberapa tools observability pun juga sudah mengacu ke sana ya, sudah bisa leverage si AI, Gen AI ya. Mau kita pakai foundation model yang mana gitu.
Oke, saya buka pertanyaan lagi mungkin angkat tangannya. Yuk, 1, 2, 3. Mas yang di sebelah kanan, belakang.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang semuanya. Perkenalkan nama saya Saiful Amini, asal tempat tinggalnya dari Wali Kota Jakarta Timur. Nah, pertanyaannya, saya tuh suka tuh bikin aplikasi navigasi GPS. Nah, cuman masalahnya setiap masalah itu ada kan. Cuman problemnya itu kalau maaf. Kalau saya suka bikin aplikasi navigasi GPS, suka ngulik-ngulik itu bikin ya saya ambilnya peta providernya dari mana gitu. terus saya bikin aplikasi itu kan navigasikan dari sumber providernya Mapbox, Sijik sama TomTom. Nah, itu database-nya kan itu kan rute sama lokasinya. Nah, masalahnya lokasinya gak tersemat di jalan atau di rute. Nah, itu kalau gak salah itu bagian database itu kan yang JSON filenya, iya. Itu kalau kayak gitu itu ada pengkodean khusus. Nah tapi dicari implementasinya gak ada, terbatas. Nah itu cara ngelengkapinya itu harus lebih banyak kodenya gitu. Ya gitu. Sekian.
Jadi pertanyaannya apa, Mas? Mohon maaf, aku masih coba untuk catch understanding pertanyaannya apa sebetulnya. Nge-scraping data gitu.
Iya, kayak hubungin data. Maksudnya kayak cara agar lokasinya gak lompat-lompat gitu, gak lepas dari jalan di peta rute sama itu biar
si titiknya itu GPS-nya tetap sesuai.
Iya,
gitu
sesuai
ya.
dengan rute, kecuali kalau dia keluar dari rute berubah. Itunya perbarui lagi.
Iya, ya semoga ini bisa membantu Mas ya jawaban saya. Setahu saya kalau di Google itu sudah ada punya Google Metric Distance, itu udah ada Distance API sama Google Maps API. Di sana tuh udah ada waypoint-nya harusnya. Jadi kalau misalkan waypoint-nya dari titik asal ke titik tujuan, dia akan ngegambar tuh waypoint-nya apa aja, tinggal kita nanti drawing di atas Google Map SDK-nya. Tinggal kita nantinya pointing posisi kita seperti apa, lalu kita mainin di Vis Location API. Kita tentukan dia itu akan retrieval location-nya itu per basis apa? Basis jarak kah, basis waktu kah, atau basis keduanya di-combine. Nanti dari sana harusnya kalau dia experience-nya sama kayak Gojek atau Grab yang menuju ke kita, itu harusnya udah bisa sangat seperti itu gitu. Jadi tinggal dieksplor aja coba ya kalau misalkan punya kesempatan buat exploring distance metrics, terus Google Map SDK sama distance API, location API, ya.
Mohon maaf Kak kalau pertanyaan saya agak terbelit-belit.
Iya. Siap. Terima kasih Mas. Udah itu yang dimaksud atau ada beda lagi?
Itu kalau yang itu kan kalau misalkan to the point aja deh. Kalau misalkan rute, kalau navigasi kan biasanya kan itu kalau kita berada di jalan ya tepat di jalan. Tapi kadang-kadang sering kali kerap sering kali gak tersemat di jalan, gak terakurat gitu. Kadang-kadang. Kadang sinyal GPS-nya atau apa gitu.
Oke, mungkin gini aja ya, sorry gue potong dikit. Kita langsung kaitan aja sama, kita bisa enhance itu pakai LLM maybe ya. Jadi kita bisa ngubungin database kita dengan API itu pakai function tooling sebenarnya Mas. Untuk masalah-masalah itu juga bisa di-handle sama Gemini, absolutely ya. Kalau di sini mungkin kita bisa ngomong Gemini, kita bisa nge-handling itu dengan function tooling. Kalau kita koneksi kita sekarang butuh AI ya. So kita ngomongin function calling ya. Pakai tools yang kita bikin, which is kita bisa ngambil database kita, or kita bisa nge-compare antara API, misalkan pakai Waze, Google Maps, atau yang lain-lain lah ya. Kita kan banyak yang provider buat support Maps ya terutama ya. Gitu. Mungkin maybe itu bisa bantu ya, thank you.
Waduh, kalau saya sih pakai providernya Mapbox sama Map.
Oke, bisa juga sih Mas itu. Kita tinggal,
Mapbox
ya
ya?
bisa juga kalau pakai Mapbox. Kita tinggal use case aja sih Mas, gitu. Oke.
Yaudah, kalau begitu makasih ya atas Q&A-nya.
Oke, kita lanjut ya ke pertanyaan berikutnya. Tadi kayaknya ada pertanyaan terkait soal biomedik nih. Nah tadi pertanyaannya kurang lebih mungkin lebih cocok untuk ke Kak Kesha ya. Katanya yang bertanya kalau misalnya backgroundnya non IT. Tapi tertarik nih untuk belajar biomedik, harus mulai dari mana?
Oke, mungkin ya kalau backgroundnya bukan IT ya, berarti misalnya backgroundnya misalnya dari biologi atau dari ilmu-ilmu lain yang...
Backgroundnya IT justru.
Oh, backgroundnya IT, sorry.
Ah, ah.
Jadi backgroundnya IT, tertarik ke bioinformatics sama kayak saya awalnya mulainya. Ya mulainya adalah belajar tentang biologi karena ketertarikan saya tentang biologi. Waktu itu orang tua saya adalah dokter, saat ini juga masih dokter. Jadi yang membuat saya tertarik adalah personalized medicine atau pengobatan yang diberikan secara terpersonalisasi untuk orang-orang yang tertentu saja. Misalnya kalau kita sakit panas ya, dikasih Panadol. Nah Panadol itu satu mungkin cocok buat aku, tapi buat orang lain belum tentu cocok. Misalnya orang lain cocoknya harusnya minum 1,5 atau bahkan minumnya setengah. Kalau minumnya cuma 1 itu nggak ampuh atau malah bisa berbahaya untuk orang itu. Itu yang pertama kali membuat aku sangat tertarik dengan bioinformatics. Gitu. Jadi karena bioinformatics itu kan mempelajari struktur-struktur data DNA. Kalau mau mulai, mungkin bisa mengambil mata kuliah biologi yang mempelajari DNA seperti itu, atau juga bisa mengikuti kursus-kursus yang online. Waktu itu saya sempat merekomendasikan temanku untuk mengambil kelas di Coursera, ada Introduction to Bioinformatics yang dibuat oleh Peking University, dan menurut saya itu sangat bagus untuk memulai. Dan juga mungkin bisa dengan mengikuti conference bioinformatics. Contohnya RICOM atau BOSC atau American Society of International Society of Computational Biologists atau ISCB. Itu juga bisa mulai dari situ. Jadi banyak sekali cara untuk mulainya gitu sih kira-kira.
Kalau sebaliknya kira-kira kalau misalnya dia ternyata backgroundnya biomedik tapi bioinformatics tapi nggak punya background IT.
Oke, iya. Kalau misalnya backgroundnya bio gitu ya, biomedicine, tapi misalnya nggak ngerti IT, mungkin bisa juga join course-course di Python, course-course yang gampang-gampang aja. Dan itu akan lebih gampang lagi buat kalian karena kalian udah tahu use case-nya. Oh misalnya, saya ingin memprediksi DNA ini bisa jadi seperti apa. Nggak usah mempelajari domain knowledge-nya lagi, kita udah ngerti, DNA itu sebenarnya ada di dalam nukleus. Dan misalnya DNA itu terkandung informasi apa. Kita cuma mau mengerti doang. Itu bisa sih dengan join course-course IT misalnya. Atau misalnya mau kayak saya mengambil S2. Itu juga bisa, jadi banyak sekali cara untuk masuk ke bioinformatics.
Oke, mungkin saya buka one last question ya dari teman-teman selama slide-nya belum up. Oke, mungkin 1, 2, 3, Mas yang paling belakang.
Cek, ya terima kasih. Selamat siang semuanya teman-teman sekalian. Perkenalkan nama saya Edwin, asal dari Kalimantan Tengah. Saya ingin bertanya dengan Mbak Kesia mungkin ya, lebih tepatnya. Karena background sendiri sebagai software engineer, itu juga khawatir dengan kesehatan ginjal ya Mbak ya. Karena kan 8 jam. Ini fakta loh teman-teman, ini fakta ya. Angka kematian karena gagal ginjal itu 42.000 catat di 2024 lalu ya kan, itu angka kematian oleh gagal ginjal, jadi khawatir juga. Nah itu iseng juga saya sebenarnya dengan tool AI yang saya buat sendiri dan developer menggunakan Android juga ya. Kebetulan waktu itu kan saya nanya ke dokter, gimana sih mendeteksi sedini mungkin gagal ginjal, bilang dokternya ya banyak-banyak minum mas, saya kan kerjanya kan duduk terus selama 8 jam. Oke, air minum. Air minum itu bisa dideteksi, mohon maaf agak sedikit jorok, yaitu air seni yang kita bisa deteksi sebagai perantara. Jadi mau nggak mau waktu itu saya ngedevelop Android cuman nyeken air seni ya. Jadi tingkat dehidrasi kita tuh ketahuan dari hasil scan-nya itu. Nah saya cuman ingin bertanya, poinnya tuh ada nggak sih kita bisa mendeteksi gagal ginjal tuh selain dari yang tadi itu ya saya minta mungkin dari DNA atau apa gitu Mbak Kesia bisa jelaskan.
Iya, terima kasih pertanyaannya ya, Mas. Iya, jadi kita tahu kalau orang Indonesia banyak sekali ya sekarang yang kena gagal ginjal, apalagi karena misalnya pola hidupnya kurang baik atau misalnya kurang minum dan banyak sekali faktor-faktor lainnya. Jadi dari yang saya tahu ya, penyakit itu dibagi sebagai dua. Misalnya penyakit yang dikarenakan oleh genetik, misalnya kanker payudara. Kanker payudara itu sangat-sangat dipengaruhi oleh genetik. Jadi misalnya kalau ibu kita atau nenek kita menderita kanker payudara, maka peluang kita untuk menderita penyakit yang sama juga semakin tinggi. Tetapi ada penyakit-penyakit yang sebenarnya dikarenakan oleh faktor lingkungan hidup atau makanan atau pola hidup. Contohnya salah satunya adalah gagal ginjal. Jadi gagal ginjal atau misalnya penyakit lainnya ya seperti ada penyakit misalnya seperti diabetes tipe 2 atau misalnya seperti kanker paru-paru, itu kebanyakan disebabkan oleh faktor pilihan hidup. Jadi saat ini kita juga sudah pernah mempelajari gagal ginjal itu sebenarnya berapa banyak faktor yang ditentukan oleh genetik. Mungkin saya perlu cek lagi, tapi kalau nggak salah yang kami temukan adalah gagal ginjal itu cuma 3% disebabkan oleh genetik. Jadi dalam hal ini kalau kita melihat seseorang dari sisi genetiknya, lalu memprediksi orang itu gagal ginjal atau tidak, itu akan percuma. Karena karena gagal ginjal itu sebagian besar disebabkan oleh pilihan hidup atau pola hidup, seperti itu. Jadi kalau saran saya sih, ya mungkin faktor-faktor klinikal dan faktor-faktor pola hidup adalah dua hal yang perlu di-track untuk penyakit gagal ginjal. Hal itu lain misalnya kalau penyakit seperti kanker payudara atau seperti obesitas atau seperti misalnya hipertensi yang dimana itu disebabkan oleh genetik. Seperti itu, semoga menjawab ya Mas.
Saya izin menambahkan ya Mas, karena lihat pertanyaannya sama saya. Sekarang saya mau tanya di sini, siapa software engineer di sini yang day by day 8 jam per hari ngoding depan komputer? Angkat tangan. Oke, great.
Otomatis gagal.
Siraman koltum ini.
Kalian mau cerita baiknya apa mau cerita bagusnya nih? Ya. Jadi, ini gue bukan curhat tapi ini pengalaman hidup ya. Baru minggu kemarin gue merasakan ada yang gak bener sama ginjal gue. Ya. Gue merasa kayak gak nyaman lah. Ya, tau posisi ginjal di mana kan? Kanan kiri kan? Kalau ada satu ya harganya lumayan lah 500 juta kalau gue lihat tuh harganya tuh. Kalau yang masih bagus ya. Ginjal bagus itu gue lupa namanya LGR-nya atau GGR-nya itu kalian bisa cek lah, itu di atas 93%. Gitu ya. 93 sampai 81 itu dibilang bahwa penurunan fungsi ginjal stadium 1. Dari 81 sampai 62 atau 61 itu stadium 2. 60 ke bawah ada 3, 4, 5 lah gitu lah ya. Nah, gue konsul dong, ya sebagai pengen punya hidup yang panjang gitu ya, ikhtiar kan, kayak hidup kan udah berantakan gitu kan. Kerja 12 jam sehari ya karena gue pemilik perusahaannya gitu. Dan gue ngelakuin cek darah, urin hanya sebagian kecil. Jadi indikatornya urin bisa dicek seperti apa? Kalau ada kebocoran protein, itu adanya di urin. Kebayang ya? Kok gue tahu dari mana ya? Dari dokter gue ngejelasin. Singkat cerita gue cek darah, gue konsul terus gue nanya kan setiap habis konsul kan gue nanya kan obatnya apa gitu kan. Gue nanya, dok obatnya apa? Nggak ada buat Mas kecuali Mas rubah gaya hidup. Wah dalam tuh, hidup sehat Mas. Hidup sehat ya, hidup sehat tuh gimana? Ini gue pegang aqua kan, gue udah gak minum lagi tuh kopi-kopian tuh, warna-warna gak ada. Minimal 2 liter sehari, olahraga 30 menit sehari, gak makan yang manis, gak makan nasi, ganti minyak. Karena ketika ginjal lu berkurang itu faktornya banyak, gak cuman masalah ginjal lu berfungsi, bukan masalah apa namanya tadi dibilang ya, bukan masalah apa yang lu makan sebetulnya, tapi pola hidup lu. Karena bisa jadi, mohon maaf gitu ya, dari empedu lu aja, kalau ada batu empedu, dari kolesterol lu tinggi, ginjal lu kerja keras men. Jadi kalau buat developer yang mungkin sekarang jujur, lu kerja 8 jam per hari depan komputer nggak ada geraknya, nggak ngeluangin waktu 1,5 jam per hari. Yang kedua adalah lu minum kopi sebagai teman duduk lu, tanpa lu atur. Yang minum minuman berwarna, apalagi yang gulanya banyak. Lu makan over, apa yang lu kejar? Oke, gaji lu gede, tinggi. Lu ngejar itu. Lu menukarkan hidup lo yang berharga hanya untuk ngejar kayak gitu. Enggak, itu nggak worth it. Jadi semenjak ketika habis itu, gue cuma sadar bahwa, wah gue punya 2 anak, 1 istri, nggak mungkin kan. Ya kan nggak mungkin kalau gue harus korbanin gitu ya untuk sesuatu yang lebih materialis lah. Gitu. Jadinya itu bukan masalah keturunan, itu gaya hidup. Ya, semoga bisa mencerahkan buat para engineers yang mulai hidup sehat ya.
Udah cukup.
Itu karena relate. Baru banget minggu kemarin tuh.
Dengan ini kita membentuk Google Health Group ya. Terima kasih Mas pertanyaannya.
Thank you.
Oke. Kayaknya udah cukup sesi Q&A-nya. Saya mengundang teman-teman tadi ya, 3 orang yang bertanya untuk ada sedikit kenang-kenangan dari speakers ke kalian dan dari kami ke kalian ya. Boleh maju ke depan? Oke, thank you. Sebelum kita tutup acaranya, foto bersama dengan speakers dulu ya. Anggi. Mas Danang sama Sat, can you join us in the stage for a group photo?
Oh ya udah deh.
Oke, 1, 2, 3. Oke, balik foto bareng teman-teman ya. Jadi mungkin bisa rada merapat ya dari yang agak ke tengah. Yang lain berdiri aja nggak apa-apa, merapat ya ke tengah.
Thank you by the way ya. Kita baru pertama kali ketemu.
Oke, buat semuanya mungkin boleh merapat agak ke tengah. Dari yang ujung-ujung boleh merapat ke tengah. Oke, mungkin yang sebelah kanan saya sini boleh merapat ke tengah. Yang di ujung boleh merapat ke tengah sedikit. Gimana lo? Lo dapetnya sampai mana? Kasih tau gue ya. Dapetnya sampai mana?
Ntar tes dulu ya.
Hah?
Yaudah berarti nggak bisa kekejar. Sorry
belakang
yang
paling.
samping nggak bisa kekejar. Oke, yang di tengah senyum semuanya. 1, 2, 3. Oke. Ya, sekali lagi. 1, 2, 3. Terakhir, paling heboh. 1, 2, 3.
Heboh.
Terima kasih.
Thank you.
Oke, halo teman-teman semua, boleh dibantu perhatikan. Acara untuk morning sessionnya sudah selesai. Terima kasih yang sudah datang. Untuk yang afternoon session juga boleh register ulang yang lagi masuk ke dalam ruangan. Kita ntar keluar lewat pintu di sebelah kiri kalian. Oke.
Tolong
We'd like to extend
perhatikan
our
barang
heartfelt
bawaannya ya,
thanks to
jangan
our
sampai ada
sponsors,
ketinggalan
Cloud
ya,
Mary and
teman-teman.
Amartha. This event is also supported by TAP. Thank you everyone for being part of this meaningful journey.
Sorry ya. Tadi aku jalannya kejauhan kayaknya. Cuma bisa dekat.
We've heard powerful insights from industry leaders, explored how AI is transforming the web, enriching culture, and even helping decode human life. Before you leave, please take a moment to fill out the feedback form. Your thoughts are valuable and will help us improve future events. The link can be found on your event badge or on the event website. Thank you all for being part of this inspiring and knowledge-filled morning at Google Cloud Roadshow, Build with AI 2025, Jakarta. As we close this session, we kindly ask everyone to begin making their way out of the room, as the committee will now prepare the space for the next agenda. Don't forget to take all personal belongings with you. Once again, thank you, and see you in the next part of today's experience.
Cek. Halo semuanya teman-teman. Yang baru masuk boleh ya diikuti nomor kursinya yang ada di kertas. Boleh dibantu ya untuk dicari kursinya yang ada di pojok kanan kertas, ada nomor kursinya. Untuk colokan ada di bawah meja. Kalau misalnya ada yang bingung boleh angkat tangan, bantu cari organizernya.
Good morning and welcome to Google Cloud Roadshow and Build with AI 2025, Jakarta. Before we begin, please take a moment to listen to a few important reminders. Please be seated on your respective number. This helps us ensure everyone is comfortably and efficiently arranged for the sessions ahead. Pay attention and ask questions to the speaker when pleased. Your curiosity and engagement help make each session more valuable for everyone. Mind your belongings and bring them with you. Please keep your personal items with you at all times to avoid anything being misplaced. Toilets are available on the second floor. Feel free to step out when needed and return quietly to avoid disrupting the session in progress. Ask for help from our organizers if you need anything. They're here to assist you and ensure you have a smooth, enjoyable experience throughout the event. Follow instructions from our organizer if something happened. In case of any unexpected situations, please remain calm and follow guidance from our crew for your safety. Thank you for your attention. We wish you an insightful and inspiring day ahead. Once again, welcome to Build with AI 2025 Jakarta. We're excited to have you here as we explore the future of cloud innovation and AI together. To honor our nation, we kindly ask everyone to please stand for the national anthem of Indonesia. We appreciate your respect and presence. Please be seated as we continue with the event. We'd like to extend our heartfelt thanks to our sponsors, Cloudnary and Amartha. This event is also supported by TAP. Thank you everyone for being part of this meaningful journey. Developer Relations ecosystem at Google. Ladies and gentlemen, to open our Build with AI 2025 Jakarta event, please join me in welcoming someone whose leadership has empowered developer communities all across Southeast Asia. Please give a warm welcome to Sagamid, Regional Lead for Southeast Asia, Developer Relations Ecosystem at Google.
Awesome, thank you. So I'll just move over there. Okay, hey everyone, very excited to be here. Thank you for a very, very warm welcome to Jakarta. It's my second visit to Jakarta. And from what I've learned that in the afternoon you say Selamat Siang, so Selamat Siang to all of you. I'm trying to learn, some of the many, many greetings that we have here. And so far I've loved the food. You folks have amazing culture, amazing food. It's again very exciting to be here with all of you. So thank you so much for welcoming me to this beautiful city and to this beautiful country. I'm the developer ecosystem lead at Google, which basically means that I work with Mas Danang and the amazing Google developer groups here to build these programs where developers can learn. Before I share some updates with you, I would like to know how many of you, for how many of you this is your first event by Google developer groups? Okay, a few hands. And for how many of you this is your, you've attended a Google developer group event before? Okay, so a few of you. Again, well, thank you so much. This is our Build with AI series that you're a part of. So you'll get to see a lot of hands-on stuff here. So thank you for joining. Can I use this? Okay. Let me, will I do next? Or I could just, I'll just say next then. Yeah. Thank you so much, Angi, for the help. Yes, so in Indonesia, we have Build with AI and Cloud Roadshows happening in more than 15 cities. This is the biggest that we have had across Southeast Asia. So again, thank you so much for joining these events, for being a part of this. I can see that, developers here really want to learn, they really want to grow. And with AI coming, there's so much happening every day. Every day you wake up, there's a new announcement, there's something new to learn. So there's a lot of opportunity. Can we go to the next slide? Yes. So what we have seen, what companies have seen as well, that there are more than 500 use cases of generative AI. And we're seeing some of the top companies in the world using generative AI in different use cases, all the way from customer support to generating content, to creating agents. I would love to hear from you by a show of hands, how many of you here are working on AI right now in their job? Okay, a few of you. How many of you hope to work in AI in the next few years? Okay, some more, good, that's a good number, that's what we are here for. So it's awesome to have you all kind of show that interest. If we can go to the next slide. Yes, so these are some few announcements that happened recently, and I would like you to kind of look at it, and we'll have a quick, I'll just quickly share with you. And one announcement that's not here yet, but I would love to hear how many of you have heard of it. Has anyone tried this thing called Firebase Studio? By a show of hands, how many of you have already tried Firebase Studio? Okay, good. I can say maybe 20–30%. Hopefully, we can have all of you try Firebase Studio. So similarly, Google has launched these open source agentic applications and APIs that you must try. Some of them that I'm mentioning, one is the A2A protocol, which is the agent-to-agent protocol, which is getting very popular with developers if you want to build multi-agentic systems. So that's something you can try. We also have the agent development kit. So this is again open source, in which you can you build your own kind of agents. And even if you have like multi-agentic system, whether it's with Anthropic, whether it's with OpenAI or with Google, you can like build these kind of multi-agent systems as well. And similarly, one new announcement we just came out like a couple of days back is that Gemini 2.5 Pro Preview now can generate like very customized web applications. So you'll just go in, you'll give a prompt, and you will be able to build web apps. So I think the whole like paradigm is shifting a lot, where you can like just give prompts and you can have applications ready. So as developers, you're at a very good place because there's a very big rapid change happening. So there's a lot to learn, a lot to apply. So keep building amazing things and do try out all of this stuff, including Firebase Studio. Yes, if you can go to the next one. Special thanks to the Google developer groups here in Indonesia who keep doing an amazing job at, can I have a quick round of applause for all the organizers, all the attendees like yourself, all the speakers who put in so much volunteer time. For Indonesia, you can see that the numbers, they just look crazy. Like last year, Indonesia had more than 570 events. I think practically no one slept because there were just events going on throughout the year. There were like so many events. We've had like almost 90,000 developers that we have reached. And we have a footprint of more than 55 Google developer group chapters and 26 Google developer experts, which is highest in the region. Which basically means that Indonesian developers, they love to learn, they love to contribute, and they love to meet up at events like this. So thank you so much for coming. And we have actually a bunch of very exciting more initiatives and campaigns that I would love to mention to you about. So if you can go to the next one. Yes. So this is what the calendar for the whole year looks like. I'm just trying to show you this so you get an idea about what happens throughout the year. And you can take a photo if you want to. But we have, at the start of the year, Juara GCP, which is Google Cloud like AI Study Jam. How many of you participated in Juara GCP? OK, good, few. But we need more of you as part of Juara GCP. It's a great opportunity to learn Google Cloud skills. And we have Build with AI happening in this month, and Cloud Roadshow as well. And for students specifically, we have the Solution Challenge, which is open right now. And next month onwards, we will have Google I/O Extended. We will have Cloud Next Extended. At the end of the year, we will have DevFest. DevFest is the most exciting time of the year because these are like large events where developers come to learn. How many of you have already attended a DevFest event? Oh, good, a few of you. Awesome. So I can see, whenever I ask a question, some of you have already been to some of these events. So it's amazing to see that you're already very much aware of this. So yeah, this was my kind of, I wanted to share this. One last message, if you can go to the next slide. Thanks, Sangi. Is that building your tech career, it does not happen alone. It's I think kind of impossible to just go on YouTube and sit there without meeting other people to build your tech career. It's like a whole journey process. I've been a part of this process for almost 15 years now. I used to be a developer myself. I am very much still a developer. I just recently built an application myself as well. So at very heart, I like building stuff. And to build amazing stuff, you need to first of all learn. Hopefully, mostly Google technologies, but other technologies are fine as well. But learn Google technologies, come to these events. Learning happens when you listen, when you question, when you're curious, when you ask questions, so try to do that. It happens when you connect. So later on, try to reach out to the speakers here, try to reach out to each other, try to make friends, because that's where the dots in your brain kind of connect and you make those connections. And the last part is when you inspire. Sometimes you inspire others, but mostly what works in life is when you inspire yourself. And I think that's what we want you to do. We want you to inspire yourself with new ideas. We want you to build amazing things. And we want you to have an amazing time while being here. So again, thank you so much for giving me the opportunity to be here. I always love to come here. I always will keep coming and hope to keep supporting the Indonesian developers community. Have a great event, and thank you so much for your support and kindness. Thank you. Yeah.
We'll be setting up your workspaces with cloud credits, so make sure your devices are ready. Welcoming Enki Maisa to help you set up.
Yes.
Yes.
Okay.
All good.
Can I? Or can I just bring it? I can just leave it here. Maybe. Hey everyone, how are you guys doing? No energy from this room? How are you guys doing this afternoon? Good? Okay, I thought no one's here. Okay. Let's wait for a moment. Okay, I'll try. See if this works. Let me just. Okay. VPN. Okay, let's just wait for this. Oh, this is the clicker. Shift. And then, okay, let's try. Oh.
We welcome Joshua de Guzman, Google developer expert in Flutter and senior software engineer at Dove, who will guide us through building multimodal chat applications using Firebase GenKit. If you've ever wanted to build smarter chat apps, this is your moment.
Oh, that's wrong. Yeah, I don't think it's working. Sorry. Not this one. Sorry. Okay. Okay. Guys, good? Gotcha. Yeah, it's the afternoon, so most likely most of you are still, just coming from lunch or from your home. So hopefully, this is the moment where, probably most of us love really sleeping and on the weekend. But, bear with me. I think what we're going to talk today is, I think will be beneficial, especially if you guys are into AI or wanted to go into AI. I think Sad asked this earlier, but I'm curious, just a show of hands, who among you here have used Gemini APIs in the past? Wow. So there are a few hands. Yeah, that's good. How about anyone who haven't used Gemini API, any API in the past? How about those people who are not actually raising their hands, even if I ask more questions? Okay. At least some of you have already tried Gemini API, but the goal here is, we're building a chat app, but at the end of the day, the goal here is not to understand how to build a chat app, but rather the fundamentals of how we build an LLM application. I think chat apps are a really good way for you to learn how to build LLM applications because, one, it helps you understand how you structure an input and then structure an output. I think. And another one is interactive, right? You send an input, you get a feedback, and you kind of have a way to experiment with it. So, what we're learning here today is not just chat apps, but rather building LLM applications in general. So I'm Joshua. I'm a software engineer by trade. I work for a company. We're building investing platforms day by day. We're using AI on our platforms. I'm a community developer advocate as well. This is out of my passion way of giving back to the community. I joined the community a few years back. I'm still relatively young, hopefully. So, yeah, and wanted to just share the things that I've learned and how I use it for my career and some of the projects that I'm building on the side. So, just some sort of alignment because there will be probably a couple of technologies and terminologies that we will be discussing. So again, if I'm talking too fast or if you have any questions as well, I think we have a special Q&A session at the end as well or at the end of this talk. But the alignment is we're going to discuss what Gemini is. I think some of you have already learned what Gemini is and of understanding what it does and how it's being used. Another is GenKit. So GenKit is like, oops, sorry. GenKit is like one of the, it's not, okay. GenKit is like one of the tools as well that you can use if you're using TypeScript. Who among you here are writing apps in JavaScript? JavaScript, okay, that's good. Yeah, because GenKit itself is actually built for TypeScript. So directly inside, like your server-side apps or front-end applications, you can integrate GenKit, so you can easily build AI features. Another is interacting with LLMs. So I think later on we'll try a new IDE that's built for the cloud that you can actually interact and directly build AI features with LLMs. Like an example is this is me using Firebase Studio. And anyone familiar with VS Code? I think a lot, right? So this is like VS Code. Think of it as a VS Code running on the cloud. So we don't have to install anything on your local machine. We're just running everything on the cloud. And this is me trying to ask what colors are available from this Tesla model PDF file. And it's giving me a response. So this could be any file, right? But the idea is we understand how we build such feature, and then the fundamental is going to be critical down the line. Yeah, we're going to talk about use cases. So again, we're just talking about chat apps right now because I believe this is a great alignment interactive for everyone. But down the line, there are a couple of use cases that you may want to build, like from videos, image, audio, and there's a lot more. I think it's going to be super exciting once you get your hands dirty on learning actually how powerful Gemini is. So, anyone have heard of you have heard here the term vibe coding? Any one of you doing vibe coding? Oh, no one will be honest. All right, so let's take a step back before you even start. What's happening right now is a lot of developers are leaning into more and more this AI-assisted application way of doing programs and software. So you'll see that as soon as we enter the prompt, it gave a response. Before it was text, image. Now it's also helping us build games, even from a single prompt. And a lot of the things that these tools are offering are really native to a chat experience, right? You're talking to your code, it gives you a response. So everything that we do is just revolving around those flow. And here comes Gemini. Gemini, I think some of you have raised your hand, but for most of you, Gemini is Google's most capable model. It comes with different sizes depending on the context that you need or the use case that you're building. Later on, we'll discuss which is which. And Gemini is something that you see normally. If you're going to gemini.google.com, you see the Gemini chat applications, and on the upper right, you'll see the different models that you can use, Gemini 2.5 Pro, experimental, and so on. It's built native, from an experience of hey, you're using your phone for search, you're using your phone for, if you visit a place, you just scan the picture, and then it gives you information. It feels very embedded to our Android phones, and then the experience is just using it as really your personal assistant. And it's really core on the chat application, but at the end of the day, we're just starting with text. But down the line, you can build specific applications that use voice inputs, video inputs, audio inputs, and everything that you can build down the line is going to be depending on the project that you're building. So this is going to revolve around, from the multimodal capabilities of Gemini. So what makes a chat app, like a Gemini app, really good? It's context rich. So context, when we mean context rich, if you're talking with the AI, it gets better and better as soon as you give more input to it, more context, and it gets the history, save and understand it. The next time you chat with that bot, you'll be able to get the personalized and more fine-tuned response to you. The other is multimodal. So we mean multimodal, it's not yet too technical, but the thing is, if you're chatting with your AI with just text, that's one modality of a multimodal large language model. But again, there's other files supported, PDFs, images, videos, and audio. And you can think of other use cases, just by speaking about these input that you can have with your LLMs. And another is, it feels natural, really, just to build a chat app, right? You're talking with an AI, you're just building an AI assistant, but at the end of the day, you don't have to build complex flows of else, if and else, but then you're just really using the AI and then prompting it, then getting a response. It sounds easy on a high level, but let's discuss code later. Again, it comes with different models depending on what you're going to use. Nano is like embedded on device. Flash is what you're most likely going to use day by day. And it comes with Pro. Right now we have 2.5. It supports 1 million contexts, but down the line it will support 2 million contexts too. Like sometimes, like it's hard to understand what 1 million contexts is, but on an analogy, what it looks like is, like a million token means you can process almost 100,000 lines in Gemini, and the LLM can still remember it. So hey, you send it 100,000 lines, and you can still almost ask it on those 100,000 lines, and it can still remember it. Other one is like maybe pages or videos, and it can almost still remember all the the things that you attach to the LLM, and you can prompt it with the like a specific question that you have. So you can think of it as a way for you to be able to send files. For example, your company details, specific domain knowledge for your projects, which are very not publicly available, but now you want to build something internal tooling or for your customers. But again, I'm just talking about 1.5 Pro. There's recent releases for 2.5 Pro, and it's still in preview. But I think I've read in this article that Google will be supporting 2 million context window, which is, you can imagine, there's already 400 pages in a single chat. Imagine what 2 million contexts can do down the line. So again, JavaScript users, anyone? Or JavaScript developers? All right, so, or I think people hide. You're already switched, but yeah. All right, so again, we're talking about GenKit. So anyone of you have heard of GenKit in the past? Okay, which is good and somehow expected. GenKit was just released on a stable version in like as an npm package. You can use it and import it on your JavaScript apps. So instead of you writing APIs talking to Gemini, you can actually use GenKit for you to be able to build AI-powered capabilities for your application. So the easiest way to do it is really just installing Google AI to your existing projects, and then running the dependencies. And it has different models, but we'll start with Gemini. So Gemini is like the out-of-the-box, one of the out-of-the-box supported LLMs that you can use with GenKit. So you can see here it also supports image generation. Again, depending on the use case that you're trying to build, whether it's text, PDFs, it has a wide range of support for that. What's actually interesting that I found out is it actually supports other open models from from the community. So it also supports like OpenAI. Actually load OpenAI models through it. If you're using Anthropic, you can also load open models like Anthropic and Llama from Facebook. So, but yeah, you can actually switch the models. But again, at the end of the day, it's less about if you're using all models or which models actually is the good alignment are you going to use for the use case, because these models have different capabilities that will best fit your use case. So you have to watch out for that, and you can experiment with that down the line. But for the sake of this workshop, since we only have an hour, we're just going to talk Gemini for today. And yeah, since this is a TypeScript project, you can just run npm run chat and then the PDF file. I'll give you the links later so you guys can follow. So recap, we've talked about Gemini and GenKit. So Gemini, again, it's Google large language model, most capable. It comes with different sizes, ultra, nano, flash. GenKit, if you're using TypeScript, you can import it as an npm package, and you can build AI-featured capabilities. And yeah, you can also use Gemini as your personal assistant, available on gemini.google.com. So I think this is probably like what will keep you awake, scratching your head and not going to sleep. So let's start with the workshop. So I believe most of you here have already created their credits, but we'll just, for this particular section, let's just focus on 3 things. One is how we create Gemini key, how we practice our prompting. Let's just fix a broken CLI or chat CLI app. And then how we build and make sure that we have structured inputs and outputs for our chat applications. So, everyone, I believe everyone has good internet, right? Okay, so everyone head to Firebase.studio. So this is this is the VS Code that port that you can use on the cloud that imports your the project we're going to use in a bit. So make sure you're signed in using the same email where you got the credits, because again, we're going to use or generate an API key as well later. Okay. Okay, just head over in Firebase Studio, then I'll ask in a bit which among you doesn't have internet connection. Hopefully the demo gods are with us today, because this is still experimental back a few weeks ago, but I think they've shipped out a lot of improvements after like the initial feedback from the community. Okay. Okay, Firebase Studio, log in your Google account. And as you can see here, Firebase Studio is actually interesting because you can chat with Gemini directly on your code there. And then it can modify your code, accept, reject, just how other IDEs are doing it. Okay, just for the just to leverage the time a lot, like who among you here have open Firebase.studio already? Okay. How about this one? All right. Anyone having trouble opening it? Internet issues, account, anyone? Okay, we can ask some help from the facilitators so we could help them. Anyone here having trouble? Just so like can have a show of hands so facilitators could help us with. Okay. So just open it, make sure you are logged in with the same account where you got the credits. Okay, it will ask you whether or not you want to add a project via repo or an upload. But what we're going to do is, there's a button there, import repo. So if you go head on to firebase.studio, there's a question of, or there's a button called import repo, and you have to, I'm not sure if this is visible. This is visible from your end, because I'm probably blocking you guys, but this is github.com/my username and then the repo that we're operating in for the workshop today. Okay. Then once you're done, once you copy the link, you have to paste it, and then you have to just name your workspace whatever you'd like, and then click import. This will take some time. So, let's just wait for everyone. So, make sure the URL is correct. Otherwise, it will import the wrong files. So, HTTPS, GitHub, Joshua de Guzman, and Chat with AI PDF repo. Hopefully, everyone's able to. Anyone having problems so far with import? All good? Okay, I see a couple of hands already, people importing it. So let's just wait maybe just a few more seconds, 30 seconds, then we'll go through it. I'll just try to roam around and just, do some, like if there's anything you need. All good from here? Yeah, it feels weird talking and then there's a speaker in front. Okay. So it will take some time. Yeah, import. Yeah, let me know if my API key is licked. Otherwise, I have to pay Google a lot But I remember having it get ignored. Okay. All right. Just copy the link, import. Okay, for those of you probably who doesn't have laptop, you can also share with others. But yeah, I hope you can follow along. I'll also send the slides after this one, just in case you can do it at the comfort of your home. Okay, let's have 10 more seconds, then we'll go through it. Okay, anyone stuck? I will have, maybe just take a picture and then I'll move the slide to the next one. All right? Okay. Again, let me just go over, okay. The next website that I'd like you to open is ai.google.dev. So again, while waiting for your import, maybe some of you are still waiting, ai.google.dev. I think I should have pasted that one, but it's not here. This is live debugging. Okay. This is where we get our API keys later, so I have to make sure we have it here. So if you're familiar already with Gemini, you can see that you can actually interact with it just like a chat app. With this one, this allows you to interact with the models for free, but like you can actually experiment with your prompts, make sure you get better at your prompting, and then like play around with the configurations and models, because I think this is going to be much as important that you're good at prompting as well, because that helps you become more accurate when it comes to building these features that you'd like to open up. So I'm just opening up ai.google.dev. So again, still the website that we have here at the bottom. So again, I'll just show you a quick example how I'd use it, how I would probably play around with it after I go home. So the good thing about AI Studio is, again, it's as if you're just using Gemini, but this is for developers that would like to get their hands on learning how they'll improve the prompt, how they'll structure the prompt, and then what the difference is when it comes to, like you can see the different models here, and you can, select the different types of, from the different versions that you can use. So for example, you're just experimenting, you might want to start with Flash, but for example, if you're building for a research application, where you need more experiment and deep research analysis, you likely want to use Pro. But for the sake of this example, let's just use it as Flash. So again, Google AI Studio is here. There's a couple of sample media. I encourage you to not just follow me, but actually interact with it. But how I would do it, for example, if I'm back at home experimenting with it, is I'll practice how I prompt, using AI Studio first. So for example, we can use this as, as a sample image. Maybe I'm a cat person, so I'll just use this one. So again, Gemini is multimodal, so you can actually send not just an image or not just a text, but both or multiple files. So let's try. Can you describe this image for me? So again, it's probably basic for a lot of you, but this is like the fundamental that we're going to repeat and repeat ourselves as soon as we build more complex AI applications. So again, it's explaining like, hey, this is a kitten, then it does it, blah, blah, blah. So I encourage you, just add a sample media and then describe an image, what it is. I think it's one way for you to be able to really learn by doing, when it comes to your prompting. So yeah, you can just follow along. But what I can do from my end is, what's good about AI Studio is it's as if like a debugging tool or a developer tool that I can use. So for example, it returned a text, right? What I needed for my applications, what do you think is the most standard way of parsing a response from an object or from an API server? Which format? JSON, right? So again, with this one, I can try and experiment how it would output a JSON response for me. So for example, turn in JSON format, or if you have a particular schema, maybe you can use it, so it's more specific. Format, return 3 possible lists, 3 possible descriptions with a score rating, which is the closest. 1 being the closest description. Okay, again, I'm just experimenting. This is just one example, so let's see if this works. So I'm just rerunning it. This time, what should be the output that we're expecting? Which format? JSON format, right? So again, this is one way you can improve how you would structure your output or input. But regardless of the score that we added, it returned the output in JSON format. I think most of you have already tried it in the past, but it gets more complex. For us, we were using it for building a AI-generated portfolio. So I'm an investing company where we build AI portfolios generated by Claude and like Gemini and different, depending on the recommendations. We pre-prompt it with a lot of data. So pre-prompting means you just add a lot of data and then you send a prompt. Otherwise, you send your database and then it gets the output that you have. So everyone has tried AI Studio? Pretty simple? All right, so hopefully we can get started now with the actual workshop. So I'll try not to reveal the key, but, oh, okay. All right, so try to click on the upper right. There's a button called Get an API Key. So it should show you something like this. Okay, the good thing it's really built for demo, so it's hidden. Okay, just create an API key, the right one, this one, the blue, and then, yeah, keep it, copy it on your terminal and make sure that you don't lose it because we will be needing it for our workshop. Okay, again, get API key and then create an API key. Okay, still have 34 minutes. All right, so head over into Firebase Studio. Okay. Even myself is not here. Okay. It should load the workshop that I have already. Okay. And then for those of you who have already Firebase Studio ready, like for the sake of time, let's try to set up the API key first. So get an API key in, on the terminal. So depending on the, Windows or Mac, you can open the terminal. I think there's a help window there, and then create an env file. Anyone familiar with an env file? Yeah, this is probably the easiest way where you store a secret, but there's better strategies here like Google Secrets Manager or alternatives. But for now, let's just do it because this is ignored. So don't worry, your API keys will not be sent to me. If it does, there's like $250 times $10, so there's a lot of AI calls. Yeah, just create an env file. So touch that env, or just you can create it manually. So you have to create it on the root file. So it has to sit with the rest of the files here on the root directory. And then with the env file, you have to add Gemini API key, and then the key here. So don't have to tell your friends what your API key is, take it as a password, right? So this is why we wanted to build a server-side applications rather than a mobile-side or client-side applications, because exposing your API keys on the client can put you or your company at risk, because anything on the mobile side is like, or client side, let's assume is insecure. So this is on the server side. Just add your API key. There's this parameter that you can add, and I've hidden the API key here. Okay. Okay, probably let's 10 more seconds, and then yeah, we should be good. Anyone who wasn't able to create their API key? Okay. At least, most of you have their API keys ready. So make sure it's not being saved. I think this is already added on git ignore. I think one important concept before we even jump into it is the concept of RAG. Anyone here have worked with worked with RAG in the past or ever understand what RAG is? Okay, so in a nutshell, right now, what we did earlier was an image of a cat and then a text prompt, right? So this is just us really making sure that, hey, we are very explicit with the data and the input that we sent to the LLM. So one bad example of a prompt is like, tell me about this PDF, but if you're not attaching the PDF, it won't know what PDF it's talking about. Another one is, there's a possibility if you have a bad prompt that's beyond, for example, you're asking about a PDF that's not on the repo. So you can see here on the directory in the workshop, there's a couple of PDFs there. If you're asking something outside of those PDFs, like for example, asking what the author thinks like outside the context of what we have, LLM could hallucinate, right? So this is probably one of the biggest challenge of some companies and how they want to keep the LLMs or the AI grounded to their companies so that it won't hurt any customer or like falsely give like an information that's wrong. So how we would like to do it is a good practice is like provide as much context. I think this is going to be much more relevant. So as long as you're building AI applications, you'll have to be specific with what you want, with the data that you have, and you have to give it as much data that where you want it to get the facts from. So a simple kind of like diagram what we have here, we have a prompt, a database here could be a PDF, an image, an audio file that you attach, or your database on your servers. And then once we prompt the LLM, we just send everything to the LLM, and then we structure an output that we want to get from that particular input. So for example, if we ask it, hey, based on the 500 employees that I have in my company, who are most likely to get promoted based on their performance, things like that. So a lot of those data are actually internal to you. So again, I think one of the important factors as well is how good your data is. So you can't just ask it like, and expect it to be good if your data is not good. So I think there's still some inner work that you have to do when it comes to data cleanup, data sanitation, and more. Okay, so the concept that we're talking about here is RAG. So I think it's a bit technical for those of you who haven't heard of it in the past, but think of RAG as a way for you to, hey, send a text prompt, attach a document, and make sure we structure the output and get the facts from these documents. So it's retrieval augmented generation. And I hope most of you here have already set up. So let's try it. So can you guys confirm if you are on which can you guys confirm which branch are you using? Main or not? Start. Start, that's good. Which is actually the broken code. So, okay. Okay, if you go over to the code, you'll see this particular line. So it will be very familiar with you. There's some, I think it's already added, right? So you just have to add Gemini 20 Flash. So this is the first step that you want to do, model selection. Again, we have Gemini Flash and other open source models, but we'll start with something like this to begin with. I think it's already on the code, but I'll try to check it as well. So the good thing about Firebase Studio is that you can, oh, that's my API key, that's my API key. Okay, it's already added, yeah, I think. Okay, so you don't have to select, but again, this is the first step. You can change it to an Imagine 3 model if you're working with image generation models and so on and so forth, depending on the capabilities that you need. Okay, now you see an empty prompt, right? Like this one. This one, line 25. Okay. Now, I'm just giving you an example what we want to do as a pre-prompt or like an input to the prompt, but it could be anything. So I encourage you maybe for the next minute or two, just add something similar, exactly the same for your prompt. So, and then we'll discuss like how the flow goes after this one. So again, it's almost similar to what we did with AI.google.dev. We are adding pre-prompts and strategies for us to be able to guide the LLM, hey, you are this, you have to be able to do something from this data so that it will be meaningful for my users. So that's the alignment there. Right now, we're not yet touching GenKit. This is just a variable that we have to change. So you can change this, for example, for mine, I'll just copy it. So I can copy it, you're my assistant, blah, blah, blah. And then, okay, I'll just close this Gemini tab here. Okay, everyone's, again. So this could be any prompt. So for example, you could also add something weird. Like probably you're not a helpful assistant, but yeah, depending on what you want. Okay, I'll give you maybe 30 more seconds. So you can, really set the context of, like what the AI will do for you. Okay, 20 more seconds. Again, we're using TypeScript here and then running it on the CLI. I think this is probably like the easiest way to touch and interact with LLM. If you are, anyone here who are front-end or mobile developers? Mobile developers? How about back-end developers? Okay, there's a good mix, so almost half and half to those who raise their hands. So for back-end developers, this is pretty straightforward. Usually you'd interact with it with a postman, but for front-end developers, you would want to, you don't want to ship your Mac to your users, right? You'll have to build something, but I think the concept is what's going to be important here. Okay. I think now we're good. So the next one is add a method at the end. So right now, there's no way for us to be able to run the app at the end. And so you can add it with the to-do at the end, and then we'll go through how GenKit works. So this is us just trying to build the app that's broken for us to be able to understand what the flow is. So we select a model, we set the prompt, and then we run the program. And how it works, let's do it after this one. So just call the method, chat with PDF, then the file name. So it should be relatively quick. Make sure that this is case sensitive. I mean, other programming languages does this as well, so you have to be careful, otherwise it won't work. Okay, 10 more seconds. I think that will be, again. I believe like anyone here having issues or not following along? Okay, what's the issue? The prompt, okay. So for the prompt, yeah, you can do this. I'll just add this both, so both anyone who can follow. Okay. So for those of you who are already on step 3, just add this one, PDF. For those of you in a prompt, let's add this one. Okay. So again, this could be anything with a prompt. Usually, like from how we use it, like we send a lot of data because one of the things that we're building is heavily regulated, so we are not allowed to store things like that on a data store. We only store it temporarily, but this is almost similar, like just adding prompts, making it structured in terms of like the output and so on. Okay, all good? Right, that's good. Now, the moment of, again, still have one more, like the biggest lift of all, npm install. Okay, now, I think this is like a race. So anyone who types npm install first will probably get prioritized with the packets of data. So on the terminal, just type in npm install, and then we'll start the chat together. So again, this is like a TypeScript project running on IDE called Firebase Studio, which is actually good because most workshops that we've had in the past, it's pretty hard sometimes because we have this computer classes, sometimes they don't have Node install. But this one is actually on the cloud, so you can, hey, send your friend your code and then he can run it on the cloud. So npm install, make sure I do it as well. Okay, I already installed it, so that should be good. Okay, I believe npm install is pretty straightforward. So you can see here from the PDFs, I think you cannot actually read it. But let me, okay. Okay, I'm trying to be careful. My messenger's open. Okay, not sure what's in there. Okay. Closed. Okay, so I think it will be hard if you did not download the PDFs, but assuming you have downloaded it, let's just see what the Tesla PDF looks like, right? So the Tesla PDF, it could be any file, but this is a Tesla PDF right now. Do you have Teslas here in Indonesia already? Oh, wow. Okay, yeah, yeah, in the Philippines it's just starting as well, but yeah, fanboy. But yeah, Tesla aside, this contains all the info that you need to learn, like as if you're buying a Tesla Model S. So it has, the colors available, the touch screens, the controls, the camera, the features that you need, the different things that you need to understand, like how it goes insane mode, sports mode, or like just how it works with the different colors and settings if you're trying to buy it. So what we're trying to do is, instead of sending all of these as text, we attach it as file. That's why we're doing the chat with PDF. So the most straightforward thing that we can do is, you can follow along as well with this one because this has to be exact. So I'm not sure if this is visible at the back. Is this visible at the back? Okay, just have to copy you just have to run it. Once we run it, I want you to explore like how you would interact with a PDF file as well. So npm run chat, then hit enter. It should open up an instance of you running the server and then being able to interact with this PDF file. Demo gods are with us today. I believe. Okay, nice. All right, so you'll see here, chat with PDF is initialized. So this is just one way, like we added the logs. Hey, you can actually start now chatting with your PDF. So anyone here is already on this stage? Nice. Right. So now let's try to prompt it. So earlier I tried asking what the colors is. Let's probably try asking it something. I think you can also download the PDF files, so just to verify, hey, like this actually has this info. But for the purpose of demonstration, I can just open it so that we can actually verify in live. So maybe let's ask something about, what do you want to ask? Anyone? What do you want to know with this PDF file or anything? I think we have a couple of PDFs there as well. But let's try, I think the most probably common that we'd like to ask is, I don't know. There's a lot of info here. So let's just say, I think we only want to verify it, that, hey, like actually post data from this PDF. Okay, I think let's just ask for the battery and drive. Sounds good? Okay, Okay, can you explain to me what the battery in wheel drive is for the Tesla Model S? So again, this is like a clunky application. You want to build a much more better user interface, but the goal here is to understand how this links. So we'll do that in a bit, but yeah, so this is, this is the response. We have the battery and drive options. We have this data that we have, and where did it extract? From the PDF file. So a lot of the other information here also came from sources that it already knew before. But what's interesting here, it only limits the data that we provided, like from 70 to 85, and then it added extra information based on the structured prompt that we sent earlier. So you can see here, only has 70, 85, and then the 85 all-wheel drive. So, this is just one example of how you would build a... Anyone of you are able to chat with the PDF already? Okay, feel free to play around at your best time as well. Right now, I'll just exit this one and then show you more demos. So you can also follow me along with the demos. I have here another Git project. So recipe, Git checkout recipe number 1. Okay. And before we actually, okay, oh, it's not, you guys cannot find it, right? Git branch. Ooh, probably it's not pushed. Git check, git fetch all. Let me try fetch. Okay, yeah, you have to git fetch all. You have to follow this code, I think, so that you can open the other example that we have. I think I'm going to show you the structured prompts. Recipe 1. So, I think you have to reset. I'll just reset mine. Control Z, this is the easiest way. Or you can also commit. Anyone familiar with Git? Okay, just Control Z or commit it so you can switch branches. So again, the branch that we're going today is git fetch. So everyone can follow with the missing branches, and then git checkout recipe 1. Okay. Make sure you're under a new branch. So this contains the first step, for us to be able to see what's actually going on. Why the PDF, why the prompt. Okay, should be straightforward for most, but let me know if you're blocked. Okay, so with this branch, this actually contains the entire code already that we have with the index that we have for the chatting of PDF. So I think this is the best way to segue if anyone's still trying to check out the branch. So what we did first is selecting the model. So the first one is like, hey, you can use Gemini 20 Flash or Pro, depending on the use case that you're trying to build. And the next one, there's a method called chat with PDF. So we added some logs and comments there, but the better understanding here is this is one way you can import a file in TypeScript. So if you're not familiar with TypeScript, this is just one way, the syntax of importing a file. Reading it from the bytes, from the directory that we have, and then this is extracting the text, from the buffer that it has from the PDF. This is the thing that we did, 926, the prompt, and then at the end, this is part of the GenKit package. So we have AI that chat. There's also other methods that you can use. We will be talking about here on the recipe structure, but AI is like the package that we're using from GenKit. Instead of you passing HTTP requests or parsing like the method calls on your own, we're just really sending a text from the prompt and then getting a response from GenKit. Okay. So now, if you're on the recipe generator, we don't have to add Gemini API key because it's already added locally if you did not close your app. But what we have here is almost similar, except this one is where we actually wanted a specific output from the, a format for the LLM. So for example, hey, we provide some sort of like example ingredients, list down the particular things that we want, and then there's a method called generate. So to run this, there's also a README, so if you guys are at home, you can actually follow along as well. So the command is npm, let me just clear this one so that it's very straightforward. So the command is npxdx, and then run the source. So this will generate the recipe for that particular ingredient that we have sent. So this is hard-coded at the moment. But again, you can provide your own inputs so that it can tailor a more specific output for the use case that you need. What was the output? Is it JSON or not? It's not JSON. So again, this will not be easily, you cannot easily serialize this for your application. So again, what will you add on the prompt? You have to structure it. You have to give it some context. Hey, you have to return it for this particular prompt or output. Now, that's just one example. Another is, I'm checking out recipe 2. And then let's see what's the difference. So in terms of code, it's almost similar, but this one, it has more structure. So if you're building production apps, you most likely want to give some structure. Because again, what happens if the API changes schema? It will be a breaking change on the client side, right? Sometimes, it will fail to parse, it will fail to serialize, so it will break the app experiences of your customers. So what you're most likely going to do is define interfaces. So this is not the best practice, right? I'm adding all domain models on the single file, but just for the workshop. So we have here a sample recipe interface, which most likely on the different file. And then the schema, I'm just adding it. This is just code generated as well. Just convert it with the schema. I think there's a new version that's coming out where you can just pass this one, right? So I think, wait for that. So I think later on it will be just easier. You don't have to do this anymore. But for the purposes of demo, I created this specific type safe schema object that represents the output that I want. And now, you can actually just add it at the end of the prompt. Now, this is recipe 2 branch. So if you want to check out, you can also see the code. So the difference is, earlier we just returning the text. But for this one, we're specifying that, hey, you have to return it for this particular schema in this particular format. So now let's see what the output is. Okay, let me run it. You can also just play around with it locally. You have $10 to exhaust. I think the API calls that we're doing is just probably less than 10 right now. You can probably exhaust that, otherwise it'll expire. All right, so now it returned the schema that I want for the particular properties. But again, it's still not JSON. But at least it's now being, it's now closer to what I want to show in my app, right? So it has the title, description, the list of ingredients, could be a list of string, could be a list of objects that you want, and then the instructions. So again, this is still not something that we can port on our app via API. So I think I haven't pushed it yet, but let me try pushing the recipe 3. So you can fetch it again, fetch dash all. Still have 8 minutes. I think that's enough for the demo. Boom, boom, boom. Check out recipe 3. Okay. Now let's see what the difference is. Okay. So the difference with this one is, earlier I wanted to return it for a particular schema in a text format, right? But now I want it to be returned only in JSON format. So let's see if it's actually working. Okay. Oh, too many requests. Okay, so this is, I have 7 minutes to debug. Boom, 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 boom. Okay, This is live debugging, so let's see if we can do it. Making sure that we're starting clean state. Oh. Okay. Ooh. This is live debugging. Okay. Let me try. We have to have suspense music here, but okay. Boom, 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 boom. Too many requests. Resources have been exhausted. Anyone here using my API key? I feel like I leak it somewhere. Too many resources. Someone here is using my API key. Guys, come on. I don't have the credits like you guys. Oh no, it's here. There. Oop. Someone's taking a picture. Okay, I'll paste it here. Okay. Too many requests. Someone's using my API key, but let's try. Still have 6 more minutes to end this workshop. Oh. I think somewhere here is like messing up with the Okay, let's have a minute. If we can't fix it in a minute, like this is day-to-day happening, right? So this is not like a just vibe coding every single day. Ooh, my cheat code. Okay. So it's sometimes my even I have to rely on the auto generation. Okay. Ooh, maybe I haven't installed it yet. Boom, 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 boom. Okay, wrong command. From runs or C. Why is it? Okay. You know what? I'll just go back to the recipe 2. Okay. Recipe 2, and then we'll have to update it. Again, something is wrong somewhere. We have to find that out. Okay. It's not every day we trust AI. Okay, I think I'm using the wrong file. TS. Okay, this is recipe. Even I have to. Okay, I'm using NPM. I'm mixing them up. Okay. We can fix this. 4 more minutes. Okay, so this is going to return some text. Okay, but we want it just to return JSON format. Boom, 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 boom. And then there should be a background music for this one, but let's see. Boom, 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 boom. Turn JSON format. So my application can parse it. So let's try. Okay, sometimes, like you have to fix it on the fly. Ooh. I feel like something's wrong with the schema. Okay. We can still do it. I feel like something is off with our Am I blocked? This feels like Kota. Check Kota. Boom, 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 boom. Maybe my account is blocked. Okay, boom, 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 boom. I feel like no one here using my API key. But again, I think we don't have to exhaust the time. But I think the goal is to just return in JSON format. That's why you have to store your API key properly. Otherwise, someone will exhaust it. But I think anyone got the point, right? Just have to structure it so that you can actually parse it in your client. So last but not least is, at the end of the day, what we want to have is, we don't want to have a plain input or output, but rather we want something that's more structured, like a schema, like a JSON. I told you, this actually worked earlier. And we want it so that our applications, whether web, mobile, can actually parse it. So we talked about Firebase Studio. Firebase Studio is an IDE, kind of like a fork of VS Code that you can run on the cloud. And you can import your projects directly from GitHub, whether private or public. RAG helps your LLMs keep grounded. You provide the data. You must provide good data. And then add your prompt so you can actually stay factual when it comes to prompting or asking the LLM. And again, I think I cannot emphasize this more, but structured input and output is going to be helpful when it comes to efficiency and accuracy of your AI. And beyond chat apps, there's a lot of use cases. We just talked about text, but I think that's the core flow, input, LLM, output. I think that will be revolving around your day-to-day process as a developer specifically, because there's a lot more advanced use case like Vertex AI, where you actually build your own agents and end-to-end infrastructure for AI. But for applications, I think this is the workflow that you're going to do. So again, another example is like just imagine if you're building something that generates text. So this is me just prompting, hey, like a cat playing with dogs. So hopefully it's not like killing the cat. But you can also build it with other kind of like models as well. Another interesting that came out with GenKit is actually the flow. I think this is actually what makes me exciting as well outside. So instead of you just building a simple chat app, you can build a continuous flow of chat apps that can be really good at a particular niche. So for example, I wanted to open my application using Firebase Auth, and then it has a Firestore in it. And then you can have a GenKit flow in between that can actually read from your database and does most of the things that we did today. So for example, we have an input, hey, try to parse this user's blog post and try to help them summarize it and then send it to Gemini. So I think flows is really interesting. So you can actually debug what's happening inside. So I'll wrap up in 2. But like you can see here, the entire flow that you can debug. So for example, if you deployed your applications on Firebase, you can actually see, hey, this is the output that the other flow provided. This is the output that I provided to the other flow. And basically, you can orchestrate a set of flows you can actually build. Maybe you want to build a customer support ops flow or an image or a text summarizer that you can automate a lot of things at the end of the day. Okay, we're not going to do this, but again, Gemini is Google's most capable model. AI Studio is something that if you're just practicing your prompt, I think this is a good start because it's free to try out the models. GenKit, again, GenKit, if you're using TypeScript already, it feels natural for you to just use it directly in your projects. Firebase Studio, an online IDE. RAG helps your LLM stay grounded. Again, the best way of learning is actually just by doing so. That's pretty much it from me. I think outside this, there's a QR code. I think these are all the collabs. Filter it with machine and AI that will give you access to what we discussed. And then I'll just share this slide as well with the organizers so they can share it with you guys at the end of the session or event. But that's pretty much it. Feel free to connect with my LinkedIn. And yeah, if you have any questions, go for it. Okay, I'll just close this one. Okay.
back again.
Let's explore how AI can help bring meaningful impact to underserved communities. Please welcome Zuhrianda, AVP of Data Science at Amartha, as he shares the potential of AI across end-to-end financial services, especially for Indonesia's grassroots segments.
Ya, halo semuanya. Senang sekali ya bisa berada di sini bersama teman-teman Google Developer Conference. Ya. Mungkin dari pagi kita udah ngobrolin low level, technical ya. Kita untuk talk ini mungkin step back sedikit ya. Kita ngomongin high level aja. Jadi judul talk kali ini kita mau bahas penggunaan generative AI, specifically di finance karena Amartha kan kita bergerak di industri finance ya. Tapi sebenarnya apa yang kita lakukan di finance itu untuk diadaptasi ke industri lain nggak begitu sulit sih karena mirip-mirip ya yang kita kerjakan. Ya, mungkin mulai dari industri introduction dulu ya. Kenapa sih kita mesti pakai Gen AI dan kenapa sekarang gitu kan? Jadi Generative AI ini mungkin lumayan baru ya, baru beberapa tahun terakhir. ChatGPT kayaknya baru 2-3 tahun lalu baru booming. Dan dari industri pun sebenarnya kita masih exploring kayak apa sih potential use case-nya, beneran gak sih? Masih banyak yang skeptis juga terkait kegunaan generative AI. Tapi kalau ngomongin bisnis, in general, bisnis itu kan kita cuma membahas ya profit and loss kan, profit dari revenue, kita mau naikin revenue, kita mau ngurangin cost. Sekarang pertanyaannya gimana generative AI bisa ngebantu kita di situ. Kalau untuk revenue mungkin kita bisa bilang dengan adanya generative AI, kita bisa menghasilkan customer experience yang lebih baik dan mungkin bisa juga menghasilkan new product offering gitu. Jadi itu akan menghasilkan customer lifetime value yang meningkat atau mungkin spending dari customer di produk kita jadi lebih banyak, jadi increasing revenue untuk bisnis. Dan kalau dilihat dari sisi cost saving, banyak sebenarnya hal-hal yang tadinya manual gitu, butuh manual works dari orang, sekarang kita bisa eliminate gitu, bisa di-automate. Nah, ini saya bicara terkait financial industry ya, kayak apa sih sebenarnya yang dilakukan di financial industry. Dan sebenarnya loop ini applies juga ke hampir segala jenis industri. Jadi dalam bisnis industri itu kan sebenarnya kita serving customer kan. Jadi kita kita dapat customer sebaik mungkin, kita bisa menyelesaikan masalah customer sehingga ya mereka bisa membayar kita kan. Kalau makin kita bisa memberikan solusi yang terbaik buat customer, ya customer akan membayar kita pakai uangnya untuk mensustain bisnis dan meng-acquire customer baru. Jadi loop dari business sustainability kalau saya gambarkan, kalau dari point of view customer ya seperti ini ya, kita mau acquire customer, dan gimana cara acquire-nya, berarti kita mesti tahu gimana marketing yang efisien. Jadi kita mesti tahu mana nih customer yang kira-kira cocok buat produk kita, itu namanya target marketing. Spesifik di finance, kita juga perlu tahu nih customer itu credit capability-nya seperti apa. Jadi kita ada namanya credit underwriting. Sebenarnya ini cuma nama yang sophisticated, tapi sebenarnya cuman kita pengen tahu punya uang berapa gitu customernya. Kalau banyak uangnya kita kasih service yang lebih bagus dibandingkan orang yang mungkin uangnya nggak begitu banyak. Dan tapi pertanyaannya adalah bukan uangnya sekarang, tapi uangnya mungkin 5 tahun ke depan gitu. Nah, kita butuh tahu kreditnya. Credit underwriting, once kita udah decide, oke, customer ini kira-kira penghasilannya mungkin 5 tahun ke depan seperti ini, kemampuan bayar seperti ini, kita bikin credit decision. Jadi kita decide, oke, untuk customer ini kita kasih apa. Nah, once customer udah onboarded, kita mau keep customer itu selama mungkin. Jadi banyak proses-proses di sini kayak manajemen untuk mungkin collection, kalau untuk loans ya. Customer management, kayak mungkin sehari-harinya customer pasti ada pertanyaan kan. Nah, gimana kita ngejawab pertanyaan customer tersebut, menyelesaikan solusi customer tersebut, itu kan manajemennya. Terus terakhir mungkin upselling, jadi kalau kita ada produk baru atau apa, kita mau customer itu nyoba juga kan, supaya kita bisa menambahkan value kita ke customer tersebut. Nah, syukur-syukur kalau customernya puas, dia akan nge-refer ke customer lain dan loop ini akan mulai lagi untuk customer itu. Nah, loop ini berjalan terus sampai akhirnya customer selesai ya. Jadi ini kita sebut customer lifetime. Problemnya apa? Ini spesifik untuk financial industry ya, dari pengalaman saya juga sebenarnya yang jadi pain point di loop ini sebenarnya kalau di bagian atas adalah bagian data. Jadi kalau kita mau understand customer itu seperti apa, ya kita perlu banyak data dan datanya pun mesti benar. Tapi kalau kita terlalu banyak minta data ke customer, itu akan jadi bad user experience kan, karena kita nggak mau pakai tools tapi mereka minta segala macam data kan. Gitu. Terus kalau untuk retention mungkin lebih ke manajemen sama manpower cost ya. Jadi banyak proses-proses yang di bawah ini itu manual gitu, dan itu aja. Dan kebetulan prosesnya kalau sekarang ya belum bisa digantikan sama mesin, kayak customer service itu belum bisa digantikan sama mesin. Terus, nah ini saya mau highlight analytics skill gap ya, karena saya dari data ya. Jadi ini juga tricky sih. Banyak yang mikir kalau kita punya data kita bisa make decision, tapi nggak segampang itu ternyata. Kita kasih data belum tentu orang yang baca datanya bisa make decision dari data tersebut. Jadi ada gap besar sebenarnya di sini. Dan ini penting sekali sebenarnya analytic skill ini untuk make the right decision. Oke. Nah, sekarang kita ngomongin opportunity dulu. Jadi dengan adanya generative AI, terus apa gitu? Apa yang kita bisa lakukan? Apakah ada opportunity baru yang kita bisa tap in gitu? Nah, saya mau ngasih lihat, ini cuma cuplikan aja ya. Sebenarnya di luar ini jauh lebih banyak. Kita mulai dari customer facing dulu ya. Jadi customer bisa dapat seperti apa dengan generative AI. Ya. Nah, ini ya, again karena saya dari data science ya. Pertama, bridging the data problem. Jadi kalau di industri saya, terutama di Amarta ya, kita banyak bersinggungan sama orang-orang di akar rumput yang belum terlalu familiar sama teknologi. Jadi banyak bahkan mereka nggak punya data kredit history, nggak data pinjaman, bahkan rekening akun bank pun nggak punya gitu. Jadi satu-satunya cara kita dapetin data dari mereka ya kita ambil foto atau minta mereka isi application form. Problemnya adalah application form itu banyak yang dipalsuin di lapangan. Jadi sebenarnya data-data seperti ini, data-data kita sebutnya unstructured ya, image, itu banyak yang bisa kita ambil untuk mendecide customer ini seberapa bagus. Nah, kalau zaman dulu mungkin kayak misalkan kita ada data foto KTP atau ini data dari mitra Amarta langsung ya, yang dia omsetnya 100 juta per bulan dari usaha ternak cacing gitu. Nah, kita sebagai produk kita pengen tahu dari gambar ini bisa gak sih kita ambil informasi yang penting ya, kayak misalkan kalau KTP mungkin ya nama, address, golongan darah dan lain-lain. Nah, kalau dari sini kita mau tahu oh dia usahanya apa, kira-kira seberapa besar usahanya cuma dari image ini aja gitu. Nah, kalau dulu kita pernah coba-coba sebelum zaman generative AI ya, ini modelnya banyak banget gitu. Contoh yang OCR ya. Untuk OCR tuh kita butuh satu model cuma buat nandain ini nama, ini alamat, satu model lagi buat ngebaca teksnya. Ya, itu zaman dulu. Dengan adanya generative AI, multi-modal LLM, ini kita udah coba. Ini cukup satu model aja, kita masukin gambar ini, nge-prompt, coba keluarin nama, alamat, dan segala macam, langsung keluar. Gitu. Jadi untuk development ini jauh lebih simple sih harusnya ya potensinya, karena kita nggak perlu lagi nge-manage model banyak-banyak, cukup ini aja, dan mungkin di belakangnya kita tambahin semacam rule engine atau mungkin model simple gitu. Sisanya untuk tuning modelnya bisa pakai prompt. Itu. Nah, terus kalau ngomongin KYC sama juga, tadi kan saya sempat mention ya, kalau zaman dulu ya misalkan kita mau onboard orang, ya orang itu harus isi data dulu, upload data. Nah, banyak data yang diisi atau diupload ini sebenarnya salah gitu. Jadi tetap aja walaupun datanya kita udah kumpulin, nanti ada lagi tim operation di dalam perusahaan yang cross validasi dari data itu mana yang benar, mana yang salah, mana yang bisa kita pakai, mana yang enggak. Dan ini prosesnya panjang banget gitu. Dan ini nggak cuma bad ya buat user experience, karena ternyata banyak yang data yang kita input sebenarnya di produk itu nggak kepake di belakang gitu. Dan untuk cross validasinya karena masih pakai orang itu juga lumayan wasted ya, karena perlu manual. Nah, dengan generative AI terutama agentic AI, flow ini bisa jadi, oh ya sorry, kalau di atas itu flow-nya one way ya. Jadi once datanya udah masuk dan udah sampai ke operation, itu susah banget kita balik lagi minta data ke customer. Bisa jadi customer-nya udah nggak ada. Tapi kalau dengan generative AI, dengan AI agent ini bisa berdiskusi ya. Jadi bisa ngobrol sama orangnya, jadi conversation. Jadi kita bisa nge-prompt agent itu untuk cari tahu kira-kira orangnya seperti apa. Dan ketika agentnya sudah mengerti, oh orang ini mungkin pengusaha warung atau orang ini petani. Data untuk pengusaha warung dan petani itu yang dibutuhin beda. Nah, agent ini harus bisa tahu, berarti untuk pengusaha warung kita minta data, misalkan penjualannya sebulan berapa. Tapi kalau untuk petani kita tanya, ya berarti nanam apa gitu, apakah nanam padi atau nanam sayur-sayur gitu kan. Dan jadi agent ini bisa dynamic minta data langsung ke customer, dan dia pun bisa langsung ke cross validate data tersebut. Dan gak cuma ini, dia bisa ngegantiin tim operation karena sekarang agent itu bisa connect juga ke internet kan. Jadi dia juga bisa crawling data public. Nah, itu semua dilakukan di satu service. Nah, ini juga bisa kita pakai untuk customer service. Jadi mirip sama tadi ya, kalau customer service tradisional mungkin customernya kita expose ke semacam FAQ page, atau kalau masih kurang dia telepon ke customer service. Nah, di dalam customer service itu sebenarnya ada layer-layernya ya. Itu harus L3, sorry. Jadi L1, pertama dia masuk ke layer 1, mungkin kalian pernah nyoba ya, nelpon, nanti kan diarahin ke customer service yang lain, terus diarahin lagi ke customer service yang lain, tergantung seberapa urgent pertanyaan kita kan. Jadi sebenarnya ada beberapa layer, dan tiap layer ini mungkin bisa diisi puluhan sampai ratusan orang customer service. Nah, ini juga sebenarnya sesuatu yang bisa digantikan sama dengan agent AI. Jadi dengan AI agent ini kita bisa nge-feeding SOP dan mungkin kita bisa ngedesain flow conversation antara agent dan usernya. Nah, untuk apakah customer service nggak perlu? Ya mungkin masih butuh customer service, tapi dengan ada AI dia bisa jadi semacam filter gitu. Jadi untuk hanya yang penting-penting inquiry yang penting-penting aja yang masuk ke customer service real gitu. Dan ini agentnya sekarang udah berkembang jauh banget ya. Jadi nggak cuma chatbot. Kita bisa ada agent yang bisa call, jadi conversationnya langsung dari pakai voice dan ada juga yang pakai video ya. Kalau untuk banking spesifik, telecollection sekarang udah ada beberapa bank gede yang nelpon pakai AI. Jadi kalau ditelepon sama bank-bank besar itu belum tentu sebenarnya yang ngomong orang di belakangnya. Oke, nah itu untuk eksternal. Internally sama gitu. Jadi kita juga di dalam perusahaan kan sering yang ngobrol sama atau minta tolong sama HR gitu. Nanti diarahin, oh ini SOP-nya, selalu ngisi form ini. Nah ini kan semua manual tapi prosesnya udah baku ya, standar. Itu juga bisa digantiin sama agent AI. Dan ini lebih straightforward sih. Nah mungkin dari point of view saya, data scientist pun data science sudah mulai digantiin gitu. Ini salah satu contoh tools yang mungkin lagi ngetrend ya, Generative BI. Jadi sebenarnya mirip sama ChatGPT gitu, tapi pertanyaannya itu spesifik data. Ini contohnya dari OpenAI, bisa dicek sendiri, open source tool. Nah, jadi tools ini bisa connect ke database kita. Jadi nanti kalau pertanyaan terkait data, itu nggak lagi lewat data analis. Kan biasanya kita kalau tim bisnis tuh minta ke data analis, tolong tarikin data ini dong gitu. Jadi tinggal tanya ke sini, ambilin data ini, nanti dia yang tarikin. Terus ya kita bisa desain juga buat melakukan analisa-analisa sederhana kayak coba conclude kayak kesimpulan dari A/B testing ABC dengan data ini, itu pun generative AI udah bisa. Gitu. Jadi banyak pekerjaan yang bisa di-cut sih dengan generative AI ini. Oke, dari tadi saya ngomongin opportunity-nya, sekarang terus gimana resikonya ya? Oke. Nah, jadi generative AI ini nggak semuanya bagus ya, jadi ada juga resikonya yang kita juga harus paham. Kalau nggak kita bakal ya bahaya sih di next 2-3 years ya. Mungkin pertama false information. Jadi seperti yang mungkin kita udah tahu ya, generative AI itu kan bukan logic ya, dia apa istilahnya fuzzy logic. Jadi kadang-kadang benar, kadang-kadang salah. Jadi nggak 100% correct, kadang-kadang dia cuma 99% correct. Nah pertanyaannya ketika yang 1% informasi yang salah itu keluar, gimana kita handle atau manage problemnya gitu. Ini contohnya dia nanya, ini dari paper ya, usernya nanya rekomendasi resep buat makan malam, dikasihnya resep buat lunch gitu. Nah itu istilahnya kalau di LLM hallucination. Nah kan belum tentu semua usernya paham kan terkait hallucination. Jadi user juga harus ketika nanya ke generative AI, ya kita juga sedikit banyak harus tahu konsepnya. Jadi jangan mau sampai dibohongin. Nah gimana caranya supaya kita ngejagain supaya LLM ini nggak hallucinate, itu juga masih challenging topik ya. Dan ada juga case di mana user itu bisa istilahnya reverse engineering. Jadi dia nanya pertanyaan dengan logic khusus untuk nge-extract informasi yang sebenarnya nggak boleh di-share sama LLM. Itu pun bisa gitu. Nah, risiko kedua mungkin fraud. Jadi kita sekarang bisa nge-generate image atau nge-generate data apapun, teks, image, voice, video, itu semua bisa di-generate. Pertanyaannya adalah siapa yang jagain supaya data-data ini nggak di-exploit, terutama untuk fraud ya. Jadi kalau zaman dulu mungkin kalau pernah dengar ada SMS, apa, mama minta pulsa. Bentar lagi mungkin bukan SMS lagi, tapi video call, mama minta pulsa gitu. Itu possible, sangat possible. Pertanyaannya gimana kita nge-guard ourselves untuk attack-attack semacam ini. Problemnya mungkin saat ini research untuk generate fake data itu progresnya jauh lebih cepat daripada research untuk ngedetect fake data. Jadi mungkin dari kita pribadi juga harus jaga-jaga sih itu. Nah, terus saya juga mau angkat terkait ethical issue. Nah, AI ini kan dia make decision juga ya. Nah, seberapa jauh kita bisa percaya sama decision dari AI tersebut, terutama untuk decision yang kritikal gitu. Misalkan performance review, ini kan sesuatu yang nggak bisa dikasih ke mesin ya. Gitu. Jadi banyak kalau antara manusia dan manusia itu kan banyak aspek personalnya juga. Itu apakah kita bisa percaya sama AI? Terus benefit management, siapa yang akan dikasih benefit? Ini nggak cuma di level workspace ya, tapi juga mungkin di level governance, kayak subsidi, siapa yang perlu dapat subsidi, siapa yang enggak, itu apakah kita bisa percaya sama AI sepenuhnya gitu. Dan ini juga topik besar sih, karena kayak di yang sudah-sudah gitu, ketika benefit itu kita systemize, yang terjadi adalah gap antara yang kaya dan miskin malah tambah tinggi gitu, karena sistem itu kan biasanya pakai algoritma min-max ya. Jadi dia minimize yang miskin dan maximize yang kaya. Nah itu apakah kita mau percaya seperti begitu aja dengan AI? Dan yang terakhir mungkin hiring and firing. Nah ini udah mulai ada juga kayak hiring yang di-automate. Jadi kita interview, tapi ternyata di belakangnya interviewnya sama AI. Nah, apakah itu etis? Dan yang kedua terkait firing juga sih, masih related sama ini. Kalau kita mecat orang karena alasan AI, etiknya seperti apa? Ya, ini masih on discussion juga. Ya, mungkin itu aja. Closingnya mungkin, ya mungkin saya kasih statement ini ya. Jadi AI ini pasti sebentar lagi akan nge-disrupt gimana hidup kita ya. Jadi tadi saya cerita tentang finance industry, tapi sebenarnya semua industri itu polanya mirip-mirip. Jadi kalau ini bisa nge-disrupt finance, AI akan bisa nge-disrupt semua industri dan semua hidup kita. Jadi kalau kita diam aja nggak mau coba adaptasi, kita bakal ketinggalan. Tapi hati-hati juga sama risikonya, karena risikonya juga lumayan dan kita nggak mau kecemplung di situ. Oke, thank you.
Oke, halo teman-teman semuanya. Aku mau minta tolong yang lagi connect ke hotspot boleh dimatiin. Karena sebenarnya wifi kita bisa banget, masih bisa banget dipakai, tapi keganggu karena hotspot kalian nyala semua gitu. Kayak lebih banyak pemakai hotspot daripada internet. Jadi kayak internetnya nggak ada yang pakai wifi-nya. Tapi karena banyak yang pakai hotspot, jadinya ketabrak, nggak bisa kepake wifi-nya. Boleh dimatiin terus di reset lagi ya. Untuk wifi-nya dan join ke wifi kita. Masih ingat nggak passwordnya? Enggak, aku ejain ya. Passwordnya untuk GDG Jakarta ada di B kecil, W kecil, A kecil, I kecil, J kecil, K kecil, T kecil, 25. Oke? Sip, thank you.
Bisa lakuin aja.
William Notoadagdo, SVP of Engineering at Amartha, will lead a workshop on building your own personal expense assistant using the Agent Development Kit and Gemini 2.5. This is your chance to see AI in action and build something truly personal.
Halo, selamat sore. Aduh, udah ngantuk nih kayaknya nih. Sesi terakhir lagi ya. Mudah-mudahan masih ada sedikit energi ya. Quick introduction, nama saya William, engineer di Amartha. Ada anak Amartha nggak di sini? Wih, 2.000 orang. Oke, welcome. Ya, Amartha adalah perusahaan, barusan Mas Rian sudah menjelaskan, Amartha ada perusahaan finansial, kami membangun infrastruktur finansial khususnya untuk grassroots ekonomi. Dan salah satu effort yang kami lakukan adalah meningkatkan financial literasi daripada masyarakat Indonesia yang ada di pedesaan. Nah, salah satu praktek financial literasi adalah sederhananya tracking pengeluaran, ya, tracking pengeluaran. Jadi kalau teman-teman di sini melakukan itu ya sudah melakukan praktek financial literasi. Dan sore ini saya akan mengajak kita semua untuk mencoba bagaimana membuat sebuah aplikasi web yang akan menjadi personal expense assistant kita, ya, menggunakan Agent Development Kit framework dan Gemini 2.5. Ya, aplikasi web ini sederhananya akan membantu kita menyimpan resit yang kalau kita belanja ya ada resitnya di foto, diupload dan disimpan. Oke, kita mulai. Teman-teman udah mendapatkan Google Credit ya, jadi saya harap bisa mengikuti step-stepnya di sini. Ada beberapa hal yang menjadi goal dari workshop kita sore ini. Pertama, kita akan membuat fully functional web-based personal expense assistant. Ya. Kita akan menggunakan Google Agent Development Kit. Ya. Ada yang udah pernah menggunakan Google Agent Development Kit? Angkat tangan dong. Wih, sudah ada. Itu baru sekali ya. Berapa minggu kemarin waktu saya mulai pakai ini itu versi 0,2, sekarang 0,5. Kalau udah ada yang pakai, keren. Jadi kalau ada yang nanya, saya lempar ke yang udah pernah pakai. Kemudian kita akan pakai Firestore sebagai database kita, cloud storage untuk menyimpan receipt image-nya. Kurang lebih arsitekturnya akan seperti ini, teman-teman. Jadi kita akan menggunakan browser web tentunya, kemudian kita akan membuat satu aplikasi yang terdiri dari front-end dan back-end. Ya, front-end dan back-end, kemudian back-end-nya nanti akan menggunakan EDK tadi ya, EDK tadi. Front-end dan back-end ini kita akan deploy di Cloud Run. Ya, kita akan deploy Cloud Run. Kemudian kita akan menggunakan Gemini API tentunya. Kemudian kita akan menyimpan data yang diekstrak dari image di Firestore. Image-nya sendiri kita akan simpan di Cloud Storage. Ups, sorry, salah pencet. Ya, jadi di workshop ini kita akan sama-sama membuat prototype web menggunakan Gradio. Kalau yang banyak melakukan pekerjaan machine learning udah tahu ya, ini adalah front end framework ya. Kemudian ada si back-end-nya tadi kita akan pakai Fast API, kita juga akan pakai Pedantic untuk configuration. Google Development Kit, kemudian kita juga akan membuat prompt yang akan menuntun agent kita dalam melakukan capability-nya ya. Kemudian kita juga akan melihat bagaimana kita dapat menggunakan Retrieval Augmented Generation menggunakan Firestore. Terakhir ya, kita akan membuat aplikasinya menjadi container dan kita akan deploy di Cloud Run. Prerequisite untuk workshop ini adalah familiar sama Python ya. Dan web arsitektur secara umum, udah punya Google account, sangat dianjurkan pakai Chrome, dan Google Project dengan billing enable. Nah ini penting, billingnya harus enable. Jadi kalau billingnya belum enable, tolong di-enablekan dulu. Udah dapat kredit kan ya, jadi harusnya tidak akan tidak usah ada biaya gitu. Billingnya harus di-enable, kalau nggak bisa melanjutkan. Oke, saya akan switch ke Google Console, kita akan masuk ke Google Console seperti ini. Ini adalah tampilan depannya. Saya udah membuat satu project ya di sini, jadi kalau teman-teman mau buat project silakan, project terpisah gitu ya. Kemudian dipastikan billingnya sudah enable. Caranya kita masuk ke sini, ke billing. Kebetulan punya saya link account, masuk ke sini ya. Nah kalau udah ada seperti ini berarti udah enable. Ya saya mungkin berhenti dulu sebentar untuk memastikan billingnya udah enable. Baik, bisa juga menggunakan apa? Ini namanya Cloud Shell ya, untuk memeriksa apakah billing kita sudah enable atau belum. Nama projectnya biasanya ada di prompt-nya, dimasukin. Nah kalau tampilannya udah ada billing enable true, berarti billingnya sudah enable. Oke. Kemudian kita pastikan projectnya sudah aktif ya. G-Cloud utility-nya sudah mengenali project yang akan kita gunakan untuk workshop ini, seperti ini. Ini saya menggunakan Cloud Shell, kalau teman-teman baru menggunakan Cloud Shell, dia ada di sebelah sini ya. Nah ini diklik, nanti dia keluar Cloud Shell. Di Cloud ini sebenarnya bisa digunakan lewat terminal di lokal komputer masing-masing, tapi harus ada autentikasi dan lain sebagainya. Kalau di Cloud Shell ini udah masuk semua. Oke, kemudian kita lanjut. Supaya saya nggak bolak-balik, saya lihat slide-nya di sini aja ya. Setup udah, billing udah, terus kita perlu enable API yang akan kita gunakan nanti untuk aplikasi kita. Sintaknya akan seperti ini. Ya, teman-teman bisa melihat di sini G-Cloud Services, Enable, AI Platform, Google API, Firestore API, dan sebagainya. Ini akan butuh waktu, jadi saya akan enter dan kita tunggu. Kelihatan harusnya ya, teksnya. Silakan, saya akan berhenti dulu sebentar untuk mempersilakan teman-teman untuk mengenable API yang diperlukan. Ya, setelah API-nya selesai, kita akan mulai dengan membuat Firestore database-nya yang nanti akan digunakan untuk menyimpan metadata yang diekstrak dari image ya. Kita masuk ke search bar, kemudian Firestore. Masih kosong, jadi kita create new database. Kita pakai namanya default aja nggak apa-apa, kemudian Firestore native, karena ini hanya untuk demo, kemudian security rules-nya open. Tapi saya ingin berhenti sebentar di sini. Ini karena untuk demo ya, makanya security rules-nya open. Tapi kalau untuk production, jangan. Ya, jangan pernah open. Ini multi-region, saya nggak akan pilih region lain, klik creating. Nah, kita sedang buat database-nya. Firestore ini adalah database NoSQL ya, NoSQL dokumen database. Kalau teman-teman pernah pakai MongoDB misalnya, ya serupa lah. Cuma ini cloud native gitu. Salah satu alasan kenapa kita pakai Firestore di demo ini karena Firestore juga menyediakan vektor database yang akan kita butuhkan pada saat kita mendevelop kemampuan RAG dari agent kita. Database-nya udah tercreate, ini ada ya, default. Dan setelah itu, setelah database-nya terbuat, kita bikin indeksnya teman-teman. Kita bikin indeks. Jadi konsepnya sama ya seperti di database RDBMS. Indeks itu membuat query akan lebih efektif. Kita akan membuat 2 indeks. Indeks yang pertama, ini indeks yang pertama, kita pakai Google Shell lagi. Indeks collection group-nya ini, jadi nanti ketika kita mulai menambahkan data atau dokumen itu akan disimpan di sebuah collection ya. Collection-nya saya sebut personal expense assistant receipts, kemudian field-field apa yang akan nanti ada di metadatanya juga saya daftarkan sebagai indeks di sini. Ada yang mengikuti atau nonton aja? Nggak apa-apa sih. Pengen tahu aja, sorry. Ada yang ngikutin nggak? Ngatakan dong. 3.000 orang, oke lanjut. Yang lain nonton nggak apa-apa. Seneng kok saya di... Agak lama ya, kemudian kita habis ini akan bikin vektornya. Saya siapin dulu scriptnya. Saya nggak hafal by the way, jadi harus saya copy paste ya. Oke. Internetnya masih hidup kan nih? Jangan-jangan mati internetnya. 6,2. Oke, aman. Kalau sudah selesai dia akan muncul di halaman indeks ini ya. Ini udah ada tapi komennya belum selesai. Not sure why. Masih ternyata. Kalau kita nggak bikin indeksnya, query-nya akan slow dan yang untuk RAG-nya kita ini ya, bakal kesulitan menggunakannya. Oke, ini yang kita akan sekarang bikin untuk RAG-nya, indeks yang akan digunakan untuk capability retrieval augmented. Ya, ini sama. G-Cloud, nama service-nya apa, Firestore, bikin indeks, composite terdiri dari apa, collection yang akan termasuk ke sini apa, kemudian karena ini untuk vektor kita akan menentukan juga dimension-nya, strukturnya flat. Ya, setelah ini kita akan buat Google Cloud Storage bucketnya ya. Kita siapin, saya akan bikin di region yang sama seperti Firestore-nya. Oke, kita lihat ini sedang dibuat. Ya, udah. Sekarang kita buat paket KCS-nya. Kita masuk ke KCS paket. Dan kita create dari sini ya. Namanya, ini nama bucket kalau kalian follow, nama bucket itu globally unique. Jadi gunakan nama yang kira-kira orang belum gunakan. Saya menggunakan nama project plus nama, saya ambil number dari project ID saya. Oh, already exists. Already exists. Saya tambahkan minus A tadi ya. Oke, ini ada ya bucketnya. Jadi, ini kenapa potong? Oke, ini namanya udah. Oke, bucketnya sudah. Kemudian Firestore-nya udah. Sekarang kita clone starter template-nya ada di sini. Ini ya. Oops, sorry. Ini nanti saya akan kembali lagi ke layar ini buat teman-teman yang mengikuti. Mudah-mudahan bisa kelihatan. Ini saya clone di home directory dari VM Cloud Shell saya. Oke, saya balik lagi ke sini kalau teman-teman mau mengikuti. github.com, William N, Personal Expert Assistant, ADK, Kotlab, Starter, Git. Oke, should be done. Ini sudah. Sekarang kita akan menggunakan, kita sekarang buka editor, Cloud Shell Editor. Tampilannya sangat mirip dengan Visual Code ya. Mungkin ini base-nya juga dari Visual Code. Supaya kita fokus ke yang barusan kita clone, saya akan open folder ke project yang tadi saya clone. Oke. Ya. Nah, kita akan membuat aplikasi webnya ini menggunakan Python ya, teman-teman. Nah, sebelum kita mulai, kita install dulu UV. UV itu adalah Virtual Environment Manager untuk Python. Bisa dilihat di internet lah gimana install UV ya. Saya paste di sini. Oke, UV-nya sudah ke-install. Kemudian sekarang saya akan create virtual environment buat project ini. UV sync frozen. Basically dia akan ambil file ini, mana-mana, di project OML, dan ini ada definisi dependensinya. Dependensinya ini akan di freeze ya. Dia bikin UV lock ini diperbarui dengan dependensi yang kita tentukan di sini. Kemudian dia juga akan buat ini yang virtual environment ini. UV-nya sudah. Nah, karena kita sudah menggunakan UV, jadi semua komen Python kita akan menggunakan UV ya. Jadi kalau kita mau ngejalanin Python script, kalau tidak pakai UV kan ya Python 3 terus apa gitu nama filenya. Kalau pakai UV jadinya UV run main.py. Nah seperti ini. Ini sama ya hasilnya seperti yang diharapkan. Oke. Ada project configuration ini bukan yang ini. Ini saya save as dulu. Project configuration-nya. Ini Google Project-nya, kita gunakan ID kita. ID project yang aktif. Tadi bucketnya namanya jadi apa ya tadi bucketnya? Ini. Storage bucket name, namanya itu. Sip. Terus next-nya ini menggunakan Pedantic, jadi ada layernya pertama dari setting .py, kemudian setting YAML, kalau nggak ada dia fallback ke variabel yang akan kita gunakan di kode gitu ya. Nah kita akan mulai sekarang dengan generate agent-nya ya, menggunakan apa tadi ADK. Kita akan generate agent-nya menggunakan ADK. UV run ADK create expense manager agent namanya. Modelnya apa? Project ID-nya yang kita gunakan. Sorry. Ya, dan ada direktori baru di sini. Jadi generate agent menggunakan ADK ini akan membuat 3 file ini ya. Ada init, ada agent py dan environment. Agent py kurang lebih seperti ini defaultnya. Jadi di sini kita mendefinisikan agent yang akan kita gunakan. Saya akan replace ini dengan yang udah disiapkan. Filenya ada di sini ya. Kalau mau ambil github.com williamn/devrel demo sources. Ada di sini. In summary, ini mendefinisikan setelah kita mendefinisikan agent-nya, di file ini kita mendefinisikan capability dari agent ya di dalam tools ini. Jadi nanti setelah ini saya akan membuat satu file lagi, tools namanya, yang isinya adalah kode-kode yang enable capability yang ditulis di sini. Ya, jadi nanti seperti kita lihat di arsitekturnya, setiap query yang masuk dari web masuk ke front end masuk ke back end akan berbicara sama agent ini. Kemudian agent ini yang nanti akan memutuskan menggunakan tools yang mana. Gampangnya seperti itu. Saya akan buat file tools. Oh iya, dia akan memutuskan menggunakan tools yang mana seperti didefinisikan di kode ini ya. Thinking config-nya, kalau kita mau lihat tot-nya seperti apa, kita bikin true. Kalau enggak juga false. Saya mau disclaimer sebentar ya. Jadi pagi hari ini waktu saya mencoba running ulang demo ini, hasilnya berbeda dengan yang saya dapatkan beberapa minggu lalu ketika saya mencoba ini gitu. Ketika saya menghubungi engineer Google, katanya modelnya diupdate. Jadi responnya meskipun sama, requestnya meskipun sama, responnya berbeda. Jadi kalau nanti di akhir demo ini responnya agak berbeda ya, saya udah disclaimer ya. Tapi setidaknya kita belajar pendekatan cara membangun multimodal agent ya menggunakan EDK. Nah ini adalah kode yang akan mengenable agent ini untuk melakukan decision making. Tools mana yang harus saya gunakan? Nah, toolsnya kita definisikan di sini. Kita sekarang bikin toolsnya. Uh, 30 menit lagi. Ya, ini toolsnya. Saya nggak akan satu-satu kali ya. Kita kalau ngejelasin kode sore-sore gini ngantuk. Kita ke presentasinya aja. Jadi ada beberapa tools yang akan digunakan. Pertama adalah tools untuk menyimpan receipt yang diupload oleh user. Jadi ketika user mengupload receipt dengan komen mungkin store this, backend akan menerima itu, menguploadnya, kemudian ADK akan mengambil image tersebut. Nah, sebelum mengambil image tersebut, dia akan membuat decision making di situ ya. Jadi kalau dia dapat image plus comment store this, apa yang dia lakukan. Hopefully kode kita akan membuat EDK mengambil keputusan bahwa oke, berarti user mau saya menyimpan receipt data ini, dia akan menggunakan tools yang kita sebut store receipt data. Tool tersebut akan melakukan apa? Dia akan convert datanya, di embed nanti terus dimasukin di Firestore. Yang kedua adalah kita akan membuat tools yang membuat agent punya kemampuan untuk mencari receipt yang berdasarkan metadata tadi yang diekstrak ya. Jadi misalnya komennya analyze expand during 2024 gitu. Dia akan kalkulasi tuh fieldnya, berarti kan tanggal receipt-nya, kemudian untuk melakukan kalkulasinya dia akan mengambil jumlah-jumlah pembeliannya dan melakukan query ke Firestore. Nah inilah sebabnya kita bikin indeks tadi depan karena kita akan melakukan query. Yang ketiga, kita juga punya tools untuk mencari relevan receipt berdasarkan natural language gitu ya. Jadi misalnya find expand related to COVID transaction. Nah, dia akan menggunakan tools ini untuk mencari receipt yang kira-kira terdapat coffee di item transaksinya. Nah, karena secara natural ini kan nearest neighbor ya search-nya. Jadi mungkin kita akan mendapatkan data-data yang tidak exactly seperti yang kita harapkan gitu. But nevertheless, approach-nya bisa kita gunakan dan kita tweak ke depannya gitu ya. Oke, itu tools-nya. Saya ambil contoh tadi yang mana ya, tools yang store. Nah ini yang store ya, yang store. Ini kita mendefinisikan image ID. Jadi ketika dia ketika dia ekstrak metadatanya, dia akan menentukan image ID-nya. Kemudian dia juga akan menentukan nama tokonya apa, transaction time-nya kapan, total amount, receipt-nya, kemudian ada purchase item-nya dalam list gitu ya. Kemudian juga ada currency-nya. Default-nya ke USD, artinya kalau si AI-nya tidak bisa menentukan ini IDR atau apa, dia akan fallback-nya ke USD. Ini contohnya. Ini semua disimpan di satu file, tentunya dalam proyek yang beneran ya bagusnya dipisah ya, lebih rapi. Nah sekarang kita akan membuat prompt. Jadi kalau lihat di file agent AI ini ada prompt ya, kita import prompt di sini. Jadi prompt ini akan guiding the agent on how it can use the tools. Nah, jadi prompt ini critical ya. Kalau promptnya kurang bagus gitu, agentnya akan membuat decision yang kurang bagus juga dalam menggunakan tools yang mana untuk mengakomodasi request-nya user. Kita akan bikin di sini namanya task from MD. Ya, ini saya akan copy dari sini yang udah ada. Nah, kita mulai dari kita menentukan personanya dulu ya. Untuk si prompt-nya kita menentukan personanya dulu, kemudian kita menentukan apa yang dia harus lakukan kalau dia mendapat image, kemudian juga kita menentukan beberapa instruksi detail bagaimana dia mengekstrak data image tersebut gitu ya. Nah, di prompt ini juga kita bisa melihat bagaimana kita menggunakan multimodal ya. Multimodal apa yang kita gunakan di sini? Kita handling image data yang di-upload oleh user. Kita juga akan mereferensi image data yang sudah di-upload sebelumnya, bukan di event yang sedang dia handling. Kemudian juga ada instruksi untuk melakukan analisis image, kemudian juga tools yang digunakan berdasarkan modality yang dikenali oleh agent. Kemudian juga me-represent image-nya, refer image-nya di output. Nah, lengkapnya ada di sini ya. Contohnya yang handling image itu ada di sini ya, ini handling image, kemudian di line 9 itu contoh user input structure. 21 kita mendefinisikan datanya harus seperti apa, dianalisanya dan lain sebagainya. Nah ini task prompt-nya. Kemudian juga kita ada, karena kita berusaha pakai Firebase sebagai vektor database ya, itu ada di, saya lupa, nah di sini ya, ini ya. Jadi kalau kita di sini membuat sebuah instruksi, kalau kamu butuh informasi lebih, gunakan tools yang ini, retrieval ya. Ini adalah retrieval external information berdasarkan data yang sudah di-upload di interaksi sebelumnya. Ya sampai sini sebenarnya kita udah bisa mulai menggunakan ya. Kita sudah bisa mulai mencoba. Nah, untuk mencobanya kita EDK ini menyediakan beberapa tools dari yang paling sederhana lewat command prompt. Seperti ini, UV run, EDK run, kemudian agentnya apa? Model not found. Oh, saya lupa. Ada yang belum saya buat, yaitu callback. Jadi salah satu fitur yang dibuat, yang disediakan oleh EDK adalah kita bisa mengintervensi data sebelum dikembalikan ke LLM. Nah, kita akan istilahnya callbacks, dan di callbacks ini kita akan memodify image ya. Saya akan copy dulu callbacks-nya. Nah ini, kita memodify image data in history. Jadi supaya efisien, agent hanya akan menggunakan 3 data image sebelumnya. Ya, jadi kalau usernya dalam sebuah session mengupload 10 image gitu misalnya, yang selalu dia gunakan hanya 3. Itu hanya untuk efisiensi ya, dan mendemokan capability callback ini. Saya akan coba jalankan lagi. Oke, nah, ini udah keluar ya. Running agent, nama agentnya apa? Kalau mau exit, exit. Saya ketik hello. Nah, agentnya akan menampilkan respon ini. Nah, ini teman-teman yang responnya ini kita definisikan tadi di prompt-nya tadi ya, kemudian di tools-nya juga ada. Makanya responnya seperti ini. Ini supaya clear apa yang dia lakukan, apa yang dia pikirkan ketika dia akan merespon query kita dan sebagainya. Kita coba sekali lagi, misalnya tell me your capabilities. Ya, menjawab di sini ya. Nah, yang saya suka dari prompt ini adalah kita juga bisa melihat thinking prosesnya ya. Jadi ketika dia mendapatkan komen dari kita, apa yang dia pikirkan sebelum dia mengeluarkan final responnya. Nah, selain CLI, EDK juga ada tools apa itu? Webnya ya. Caranya UAV run EDK web min port 8080. Nah, dia akan keluar kayak gini. Kita bisa buka di sini preview port 8080. Nah, ini sama sebenarnya, cuman ini CLI, ada UI yang bisa kita gunakan untuk mengupload file. Saya mulai dengan hello dulu. Sama ya. Nah, kemudian kita coba upload file untuk melihat bagaimana thinking proses agent. Saya yang ini deh, yakiniku ya. Oke. Store this, saya udah siapkan receipt-nya. Ini thinking prosesnya kalau kita mau lihat. Kita tunggu dulu ya, nanti kita akan buka sama-sama thinking proses seperti apa. Nah, it works. Tadi enggak loh, ini sekarang it works. Padahal nggak ada perubahan kode apa-apa. Ya, ini agent menerima image dan komen ini ya. store this, dia pakai tools yang ini dulu, kemudian dia decide setelah menggunakan tools ini, dia menggunakan yang store receipt data. Kita juga bisa melihat visualisasinya di sini ya. Jadi ini adalah proses ketika expert manager agent menerima query dan image, kemudian selanjutnya dia menentukan, menerjemahkan, gampangnya gitu, menerjemahkan komen ke bahasa yang lebih clear gitu ya, di transform, kemudian setelah itu dia menentukan bahwa oke, ini usernya mau nyimpen file ini, dia memutuskan menggunakan tools yang store receipt data. Nah, yang barusan kita upload tadi itu disimpan di metadatanya, disimpan di Firestore. Kita belum pakai DCS-nya teman-teman ya. Jadi di kode tadi kita belum mendefinisikan upload ke DCS-nya. Jadi kita akan lihat di Firestore. Nah ini udah ada collection-nya, kemudian ada dokumennya. Di dokumen ini saya kecilin dulu yang ini. Di dokumen ini ada ya, ada currency-nya berapa, metadata dari image tadi. Kemudian purchase items, itemsnya apa aja, receipt ID, store name, total amount. Oke. Saya upload satu lagi. Ini tahun 2024, oke. Coba saya cari yang 2023 ya. Nah, 2023. Mudah-mudahan berhasil nih. Store this. Oke, store ya mirip ya. Ini dia menggunakan tool search relevant receipt dulu. Kenapa dia pakai itu ya? Anyway, terus dia langsung masuk ke store receipt data, kemudian dia menampilkan di sini hasilnya. Ya. Nah, sekarang kita coba natural language ya, misalnya kalau breakdown expenses by month from between 2023 to 2024. Ini kalau teman-teman berpikir kok lambat ya, itu karena memang prompt-nya dan kodenya masih tidak efisien ya, karena ini untuk kepentingan demo aja. Jadi contohnya ketika upload, prompt-nya itu mengatakan bahwa image-nya harus unik. Nah itu kan sebenarnya ada approach lain yang lebih efisien, yang akan membuat lebih cepat prosesnya gitu ya. Oke, dia udah reply. Kita bisa lihat dari thinking prosesnya ini, dia menentukan ada 2 receipt, kemudian dia breakdown ada di Desember dan di Januari 2024, dan final responnya seperti ini. Ya. Oke, ini saya close sekarang. Kita lanjut. Nah, kita akan membuat front end-nya ya sekarang ya. Kita akan membuat front end-nya seperti yang tadi direncanakan. Saya gedein dulu front end-nya, kita akan buat. Gampang aja. Kita akan buat nama filenya frontend.py. Kemudian di file frontend.py ini kita akan mendefinisikan komponen-komponen pre-built komponen dari framework Gradio itu ya. Saya akan menjelaskan singkat nanti seperti apa. Nah, seperti ini. Jadi ada file untuk encode, decode, karena nanti frontend ini akan menghandle file input pertama kali dari user sebelum diteruskan ke backend ya. Nah, kemudian ini ada method get response from element backend. Jadi function ini, method ini yang akan call ke backend. Backendnya belum ada, jadi abis ini kita akan bikin ya backendnya. Kemudian kita si backendnya nanti yang akan berinteraksi dengan agent dengan Gemini dan lain-lain. Nah, di sini kita mendefinisikan interface dari frontend kita. Ini pre-built komponen, jadi kita bisa langsung menggunakan komponennya ya. Contohnya di sini saya menggunakan komponen chat interface. Ya, kita jalanin ya. UV run front end. Gampang aja, langsung dijalanin aja front end PY. Jalan front end-nya, kita lihat UI-nya. Ya, kayak gini ya. Jadi dengan sedikit kode kita udah punya chat interface. Kita coba sapa agent-nya, hello. Error. Kenapa error? Karena backend-nya belum ada. Ya. Ini error ya, error connected to backend service. Nah, sekarang kita bikin backend-nya. Caranya sama, jadi kita tinggal buat file, satu file, saya sebut sini backend.py. Saya copy dari yang udah saya buat. Oke, basically backend.py ini kita menggunakan Fast API, jadi adalah framework Python yang akan membantu mengembangkan prototype API cepat sekali ya. Komponennya memang fokus untuk HTTP API, toolingnya juga cukup lengkap, Swagger dan lain-lain sudah ada di situ. Jadi di Fast API itu ada metode lifespan. Lifespan ini akan dipanggil sebelum Fast API-nya dijalankan, sebelum instant Fast API-nya dijalankan. Kemudian di sini kita menggunakan di lifespan ini kita mendefinisikan kita menggunakan dua artifact ya, in memory session dan GCS. Ini adalah bagian dari ADK. Jadi di ADK itu ada konsep namanya artifact yang akan meringankan kita developer sehingga untuk hal-hal yang memang general seperti in memory session atau interaksi dengan GCS itu tinggal menggunakan yang sudah disediakan. Kita di sini tinggal menentukan storage bucket name-nya. Tadi kita sudah menentukan ya di sini ya, udah benar ya, ada A-nya di belakang. Oke. Ini masuk ke app context. Kita melihat di sini bahwa di app context ini si backend ini akan berinteraksi dengan expand manager agent runner. Ya. Runner ini nanti akan diarahkan ke expand manager agent yang tadi kita coba ya. Dia akan expose satu endpoint chat. Chat ini yang nanti akan dipanggil oleh frontend. Oke, saya akan bikin satu terminal lagi dan akan menjalankan backend-nya. UV run backend. Oke, komplit. Kita coba sini. Kita cek, harusnya ini udah nggak error. Saya ketik hello. Ini yang saya temukan tadi siang. Jadi instead of merespon, dia hanya berpikir. Responding to simple greeting. Saya matiin dulu ya. Ada yang saya harus klik. Tadi siang juga saya alami hal yang serupa. Apa yang saya lakukan? Yang saya akan lakukan adalah saya akan meng-disable thought. Jadi kita don't care apa yang dia pikirkan lah ya. Yang penting dia mengembalikan apa yang kita inginkan gitu. Oke, for ini saya jalanin lagi. Kemudian ini udah ya, coba jalan. Sip, kemudian backend-nya. Oke, mudah-mudahan jalan ya sekarang. Oke, udah jalan. Halo. Nah, sekarang sudah respon sesuai yang kita inginkan. Kita coba query yang sama ya, misalnya breakdown expense by month between 2023-2024. Ya, ini thinking prosesnya kita bisa lihat, kemudian dia menampilkan final responnya. Sekarang kita coba upload ya, teman-teman. Kita tadi belum upload, coba ini apa sih? Jurnal, oke kita coba yang jurnal. Store this. Komennya nggak harus store this ya, bisa mencoba query lain juga. Kita melihat bagaimana agent menerjemahkan komen yang kita input. Ya, successfully bla bla bla. Oke, nah sekarang juga saya akan satu lagi ya buat keperluan nanti kita simulasi, saya akan masukin yang Indomaret. Oke, Indomaret. Sore ini performance AI-nya cukup oke ya. Tadi pagi saya coba ada sebagian receipt yang dia decide currency-nya USD. Tapi kalau saat ini saya demo semuanya IDR sepertinya. Oke. Ini IDR juga 2003. Oke. Nah, kita bisa coba query yang lebih berbeda dari yang kita masukkan tadi ya. Misalnya apa ya? Show me receipt of Indomie transaction. Show me receipts of Indomie transaction. Ada yang punya ide nggak? Masukin apa? Komennya. Ada ide nggak? Apa? Oh, minuman ya? Oke, boleh, boleh. Jadi kayak misalnya transaksi minuman ya? Menarik. Coba ya. Oke, ini udah Indomie keluar, bener ya, dia keluarin ini. Minuman, coba saya masukin lagi, saya punya receipt untuk matcha. Nanti kita bisa lihat ya, apakah dia kenalin kopi sama matchanya itu ya. Matcha mana ya, ini jurnal. Ini fore kopi nih. Nah ini kopi nih, boleh deh fore aja. Store this. Nah kalau natural language-nya tidak seperti yang kita expect, berarti tools yang kita perlu revisi adalah yang itu tadi ya, yang search by natural language tadi query-nya ya. show me receipt of any drain transaction. Menarik. Kita lihat, dia bisa nggak? Oke, keluar nih. Coba kita lihat. Salted caramel. Wah, bener semua. Tepuk tangan dong. Jago, jago. Indomie nggak ada kan? Indomie? Berarti Indomie nggak ada. Oke, bagus. Oke, itu saya akan kembali ke sini. Nah, last step-nya kita bisa deploy ini sekarang ya. Kita sudah tes. Oh, saya belum kasih lihat Firestore-nya. Tadi saya udah kasih lihat. Jadi, Firestore-nya tadi ini kalau saya refresh, kita akan lihat beberapa dokumen. Barusan kan kita udah upload beberapa ya. Nah, seperti ini adalah data-data yang kita input tadi, metadatanya. Kemudian kita juga bisa lihat bucket. Kita lihat ada file-file. Nah ini ya, ini dia bikin file-filenya dia upload di sini. Saya ambil contoh satu. Nah ini benar ya, Indomaret. Oke. Nah last step kita akan deploy aplikasi kita ini ke Cloud Run. Ya, kita akan deploy ke Cloud Run. Kita kebetulan template-nya ini udah containerized ya, jadi kita bisa lihat di sini saya udah mendefinisikan Docker di sini, nothing extraordinary sih ya. Ini komen buat run virtual environment-nya akan diekspos di 8080, kemudian kita akan pakai supervisor D untuk proses kontrolnya. Supervisor D-nya seperti ini, akan ada dua program, back-end dan front-end. Back-end-nya pakai yang barusan kita sudah sama-sama lihat, UV Run Back-end PI dan lain sebagainya. Kita tinggal, ini udah mati, ini udah mati, kita akan tinggal deploy ke Cloud Run. Command-nya yang ini. Cloud Run, di Cloud Run deploy-nya apa? Personal, run-nya itu maksudnya Cloud Run, source-nya existing directory, allow authenticated. Lagi-lagi saya ingatkan ini untuk demo ya, kalau production kalian harus mikirin authentication-nya seperti apa. Setting YML tadi ini ya, yang barusan memorinya, agak lama sih ini. Kita tunggu. Ya, sambil nunggu deployment ya, mungkin saya sambil closing aja. Nanti kita bakal kembali lagi ke situ untuk demo lagi. Jadi setelah deployment nanti kita akan dapat URL, kita akan buka URL-nya. Starter template-nya ada di sini. Ini juga berdasarkan original code labs yang dibikin oleh Mas Alvin. Saya tidak tahu apakah slide-nya akan di-share ke peserta atau enggak ya. Jadi kalau di-share nanti bisa lihat di sini. Ya, jadi closing-nya adalah kita sekarang developer dapat dengan mudah ya, saya pikir dengan relatif mudah mengembangkan agentic capabilities di service system atau solusi yang kita bangun, terutama menggunakan Google ADK tadi. Very helpful, memangkas banyak sekali pekerjaan yang harus dilakukan kalau kita tidak menggunakan Google ADK. Oke. Ya, masih uploading. Yang barusan belum saya tampilkan, sebenarnya ini juga punya capability untuk upload multiple file, juga untuk download. Jadi nanti setelah Cloud Run-nya terupload, saya akan mendemokan downloadnya ya. Oke, 4 menit lagi. Kita lihat Cloud Run-nya sudah sampai mana. Cloud Run. Oh, ini udah ada. Ini belum running. Lagi building new version ternyata menggunakan revisi sebelumnya. Oh iya, pakai revisi sebelumnya. Oke, ya kita lihat aja dulu. 5 jam lalu. Oke, tinggal creating revision, then we can try. Dua menit lagi nih sebelum saya diusir dari tempat ini. Come on. Oh iya, udah juga akhirnya. Cloud, maybe they should change the name, Cloud Walk. Oke, kita coba, ini udah selesai. Saya klik open. Service. Oh my, mana sih? Udah 100% ini. Loading. Oke, ini udah di Cloud Run ya. Kita coba ya, hello dulu. Hello, backend-nya belum jalan. Bentar. Ini front-end-nya udah jalan, backend-nya belum jalan. Nah, ini backend-nya udah jalan sekarang. Oke, saya coba upload, nggak usah upload deh. Kelamaan, saya langsung ini aja deh. Get receipt file from journal. Oke. Kalau ini sukses, dia akan menerjemahkan ini bahwa saya ingin mengambil receipt file image. Nah, ini dia keluar ya. Oke, that's it guys. Thank you so much for your attention. I hope you learn something this afternoon. Thank you. Panitianya mana nih? What next? Oke. Kalau kalian, one more thing, kalau kalian mengikuti step-step ini, setelah selesai jangan lupa di clean up karena semuanya ini open ke production. You don't want a bot masuk ke sini terus dia upload macam-macam ya. Jadi please ingat itu untuk clean up. Thank you.
We'll wrap our sessions with a live Q&A, moderated by Andi Wijaya, Business Architecture Specialist at Accenture. Joining him on the panel are Joshua de Guzman, Zuhri Anda, and William Nodowidagdo. Bring your questions. This is where insights deepen.
Tepuk tangan dong untuk Mas William. Gimana, masih semangat nggak? Semangat pagi? Kalau gue bilang semangat pagi, semangat gitu ya. Semangat pagi? Masih loyo.
Kasih kredit lagi dong.
Semangat pagi? Semangat? Oke, jadi kita udah sesi kedua ya, sesi afternoon. Kita udah dengar 3 pemateri. Please welcome Mas William, Mas Rian, and Joshua of coming here. I just had conversation with Joshua. He has to take like 4 hours by car and then 2 hours from Manila to here, right? So it's pretty long journey for him to come here to share cool stuff with you guys. Give him applause. Okay, we'll do a Q&A session. So I will start with 2 questions first from all of you guys here. Okay, saya akan hitung ya, 1, 2, 3, nanti angkat tangan, lihat yang mana paling pertama. 1, 2, 3. Yang belakang. Yang
Okay.
Sorry, Ko Andi, yang mana?
Yang itu tuh.
Siap.
Tes. Oke. Thank you. Maligayang Pakdating sa Jakarta, Joshua.
Oh, wow.
So yeah, my name is Lutfi. I want to ask to you about, is it possible to create AI with RAG based on some documents in a folder without need to mention specific the document? Thank you.
Sorry, maybe, thank you for the greetings. Like, sorry, like, so you're asking if, can you repeat the question? Like, just one more time, yeah, maybe.
Is it possible to create the AI with the RAG, but based on the document in the folder? So we don't have to mention specific document like you mentioned before that we have to, we have to put the specific document like Tesla Model S, but let's say for the example, like you have some document in one folder and you want to like ask about the random anything, but based on the sum of document in the folder.
Yeah, good question. So the question is like if we can add more files other than just specific, right?
Yes.
Yeah, we can actually do it. So 2 ways. One is you can have the directory loaded in the environment, and then you can use that as part of RAG, what we're talking about, retrieval augmented generation. Another one is you can use cloud storage, Firebase storage, where you can store the data and you can actually pull it using flows. So for example, we talk about GenKit flows. You can load the Firebase storage or Google Cloud Storage bucket as well, and then it will initialize that with those PDF files or other form of file types so that you don't have to specify a file type or document in the future. And you can train, you can fine-tune the AI based on that storage.
Okay, thank you.
Oke, next one. 1, 2, 3. Masnya yang depan.
Oke, thank you. Perkenalin, aku Mutakin. Aku mau tanya tentang bagaimana sih cara kerja RAG itu mengingat data yang diupload sama usernya gitu, sebagai informasinya gitu. Jadi RAG kan dia ngambil informasi tuh setiap prompt yang dikasih, terus ngambil informasi di belakangnya. Apakah itu setiap kali user request, apakah dia mengambil lagi informasinya gitu dari yang belakang gitu, dari backendnya gitu. Thank you.
Halo. Ya. Jadi kalau defaultnya generative AI kan kita ketika nge-prompt kita kasih konteks dulu kan di awal kan. Kalau kita konteksnya kepanjangan itu bisa juga cuman costly kan. Nah RAG itu sebenarnya konsep untuk nge-compress konteks di awal gitu. Nah compressionnya kita pakai encoding itu tergantung modelnya sih, kayak ChatGPT punya encoding sendiri, Gemini punya encoding sendiri, Llama punya encoding sendiri. Jadi konteks yang besar itu di encode dan di store di kita sebutnya vector database. Jadi ketika kita nge-prompt ke modelnya itu sebenarnya bukan prompt yang raw-nya yang dikirim, tapi yang udah hasil encoded, yang udah compress. Dan itu pun udah ada algoritmanya untuk select konteks mana yang perlu. Jadi konteksnya udah dipilihin dan udah dikecilin. Jadi ketika ditanya ke OpenAI-nya atau ke ChatGPT atau apa, mereka udah paham. Walaupun sebenarnya konteksnya udah bukan bentuk bahasa manusia lagi, udah bentuk encoded konteks gitu. Itu RAG sih.
Contohnya ada Mas, di kode yang barusan ada. Coba nanti dibuka aja. Jadi di prompt-nya saya dituliskan di situ bahwa kalau begini kamu lakukan something yang retrieval gitu kan. Jadi spesifik gitu. Soalnya kalau nggak spesifik kayak Mas Rian bilang tadi nggak efisien, nggak efektif. Nah di contoh kodenya ada, bisa dilihat di agents.py. Thank you.
Jauh.
Oke. Kita ada pertanyaan dari Slido? Nggak ada ya. Kita lanjut ke teman-teman dulu kali ya. Oke, 1, 2, 3. Ulang deh. Gak kelihatan kayaknya situ ada juga. 1, 2, 3. Mbaknya yang di belakang.
Oke, sebenarnya aku mau tanya ke Mas Zuhrianda lagi. Jadi mungkin perkenalkan selamat sore teman-teman, nama aku Diva. Kebetulan aku jadi data analis di salah satu financial service juga. Nah jadi aku mau bertanya nih, yang pertama tadi kan ada contoh-contoh penggunaan generative AI yang udah dipaparkan sama Mas Zuhrianda ya. Nah apakah contoh-contoh itu tuh emang dipakai di Amarta, itu yang pertama. Terus yang kedua, gimana sih cara regulate atau memantau AI terutama yang customer facing gitu. Kayak customer service agent yang selain chatbot ya, itu gimana cara kita memantau apakah dia emang memberikan respon yang tepat ke customer kayak gitu. Dan yang ketiga, nah agak banyak pertanyaannya.
Gak apa-apa, nanya aja.
Yang ketiga, kalau financial service ini kan biasanya kita ada regulator ya. Kayak misal kalau di bank itu ada kayak OJK gitu. Nah gimana, dan kayak tadi ada contohnya untuk generative AI pengganti data analis itu ada brand AI. Nah gimana kita bisa meyakinkan gitu regulator, atau gimana sih tanggapannya regulator terhadap penggunaan tools kayak brand AI, apalagi kalau tadi aku sempat cek brand AI itu open source dan ya dia sifatnya kan bisa mengakses database perusahaan kita gitu. Apakah itu safe dan gimana untuk meyakinkan regulator kalau itu memang safe kayak gitu sih, Mas. Terima kasih.
Susah.
Enggak, pertanyaannya lupa saya. Yang pertama tadi apa? Yang pertama apa tadi?
Yang pertama, apakah contoh-contoh generative AI tadi
digunakan.
digunakan? Iya.
Kalau untuk yang self-service sebenarnya masih in development, tapi tahun lalu kita sempat POC ya. Dan emang capable. Jadi sebenarnya mirip sama yang tadi dicontohin Mas William ya. Cuman kalau tadi yang di-expose itu image, kita expose database. Kayak satu table lah, satu table. Nah jadi, tapi kita perlu jelasin juga ke AI-nya, table-nya ini tentang ini, kolomnya artinya gini, 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 gini. Dan so far emang bisa gitu. Dan lumayan akurat lah hasilnya. Tapi apakah kita pakai itu sehari-hari? Belum. Masih in development. Dan ini juga kita hati-hati ya. Terus tadi pertanyaan kedua, apa lagi?
Verifikasi, sebenarnya verifikasi.
Oh, gimana cara kita nge-verify
tidak
benar atau
halusinasi
enggak
gitu
ya
kan.
AI-nya kan. Nah ini balik lagi ke kontrol ya. Jadi AI itu nggak bisa dilepas gitu aja, tetap harus ada kontrol manusianya gitu. Jadi tetap harus ada tim operasional yang tugasnya ngelihatin output dari AI tersebut. Tapi mungkin nggak semuanya bisa dilihat karena AI kan cepat banget ya. Jadi at least kita ada sampling base gitu. Misalkan kita bikin kita sampel tiap bulan 1000 inquiry sama outputnya, nanti dari tim manusia itu yang menilai seberapa akurat hasil dari AI tadi. Nah, itu udah common practice ya, kayak bahkan di Meta, di Google mungkin semua inquiry itu sebenarnya ada orang yang ngecek di belakang untuk sampling base. Terus terkait regulasi, ya ini ya hot topic juga sih sebenarnya, tapi dari OJK belum ada regulasi terkait generative AI kan. Jadi yang penting dari kita harus ada kontrol ya kalau di banking checker maker ya. Jadi tetap harus ada checkernya. Ya, AI ini jadi makernya tapi tetap harus ada tim yang ngecek seberapa valid, dan mungkin bisa pakai itu sih ya kita untuk menjelaskan ke regulator. Ya, mudah-mudahan jawab.
Oke, cukup jawab ya Mbak ya, atau ada lagi? Oke. Next one ya. 1, 2, 3. Masnya yang depan.
Mohon maaf, ini perlu bangun nggak ya? Diri gak apa-apa, nggak duduk apa berdiri ini?
Berdiri mungkin.
Berdiri aja ya. Oke. Kenalan, I'm Iqbal and I want to ask about something that I've actually do it before. Is I've some projects about LLM, but I haven't using this Firebase Firestar before, but instead of using that, I'm using something called Dialogflow CX. Is it actually the same thing or not? Because about the storage thing, while I using the, what is that? Object storage, yeah. I was using object storage for the feeding the data, but instead of I'm sending it through chat, I'm feeding it directly to object storage. The point is it actually the same like the Firestar thingy like now, or is it any different between the RAG that you explain and the Dialogflow CX thingy that I do it before? Thank you.
Thank you. At least what I can say is the Dialogflow and the object storage, the concepts are the same. It's much more rigid, I think. So for example, on Dialogflow, you specify a conversation, this is the reply, right? I think the challenge is really like what the expertise of you or the team is. Because for example, if your team is much more comfortable building it directly with GenKit, Firebase, or LLM directly, I think it makes, a lot of companies are already using LLMs right now with, instead of Firebase, I think it depends really on the tech, but for Firebase, you can use Firebase storage, and you can use that as a data store. Because I think there's also a code lab called Chat Your Firestore, where you can actually ask a prompt, and instead of it searching for files or PDF, it can search databases. So you can also do that. But beyond that, you can also add, I think the challenge with Dialogflow is, I think it's been a while, like since, it's been a while since it's been updated. But I think if it works for you, I think that's fine. Again, LLMs, AI, regardless of the hype, you should use something that you are comfortable with, you are already using maybe for production use, but if you need to shift, which is I think most companies are doing, start thinking about how you can use AI or LLM in general for that particular, for example, customer chat, right? Again, I think, so as long as you're feeding the right data, your company data, like the specific business knowledge that you have, you should be able to build the AI more grounded. You can also specify the prompts, right? So for example, here are the spiels. So for example, if my customer wanted a shoes, maybe you can give him a structure like, hey, this is how you will reply. We have a products selling like shoes in colors, maybe shoes in sizes. So things like that, you can experiment. You can also A/B test prompts right now. So you can see, hey, there are more users buying when we ask for the colors versus the size. So there's a lot of ways you can play around with it. But to answer your question in terms of difference, there's a huge difference. Dialogflow is rigid. There's more control on the LLMs right now. And there's more freedom on how you can build the experience as well. Because Dialogflow, I think it's limited to literally just Google technologies as well that you can use and then host. But like with LLMs, could be any models that you'd like. Yeah.
Okay. Next question. How does the RAG work with the data? Is it uploaded to the cloud to remember the information? I think this one can be answered by Mas William.
Yeah, I think it's the same question.
It's your question. Okay. The second one, specifically for Mas Rian. Dari poin materi, bagaimana cara kita bidang IT untuk bertahan dari ancaman AI, mengganti pekerjaan IT dan memanfaatkan peluang dengan adanya AI?
Oke, ini mungkin buat both engineering sama data science. Nggak tahu. Jujurnya sih sebenarnya apapun teknologi baru itu sesuatu yang disruptif ya, tapi AI itu, kedatangan AI ini bukan sesuatu yang baru. Kayak zaman dulu pun ketika ada revolusi industri, reaksi dari masyarakat juga sama, gitu. Takut buruh tergantikan sama mesin. Nah yang terjadi juga sebenarnya sekarang sama, kita takut apakah pekerjaan yang kita punya sekarang bakal tergantikan sama AI. Tapi ya seperti kalau melihat dari sejarah, waktu itu ketika ada revolusi industri di Inggris, cuma Inggris di seluruh Eropa cuma Inggris yang berani revolusi industri, yang lainnya nggak ada yang berani. Yang terjadi apa? Inggris 100 tahun kemudian jadi penguasa Eropa. Nah, hal yang sama juga pasti akan terjadi sekarang gitu. Kalau kita menolak, orang lain pasti akan nyoba. Gitu. Jadi kalau kita mau bertahan ya kita mau nggak mau harus adaptasi, mencoba pelajari dan ya beradaptasi gimana caranya kita bisa survive. Karena kalau kita ngotot nggak mau, kita pasti akan ketinggalan. Ya, itu sih.
Can I add to that? So we are living in a very interesting time. So yes, AI, perhaps we can see it as just another technology, but I think us human beings have not seen this kind of things in real life until today, right? So my opinion is whether we're going to be replaced by AI, engineers going to be replaced by AI, data science, data engineer, and so on, replaced by AI the question is yes and no. But I think the important thing that we have to understand is one, AI is going to stay, and the only way to deal with it is coexist with AI. So I would suggest not to see AI just another technology as a tools, right? But as a coexistence, whether it's a co-engineer, co-data scientist, co-learner, your peer, your pair programming partner and so on, but the main thing is try to coexist with AI. Yeah, that's it. Thank you.
Okay. So next question. How to provide security for the data we input into AI and make sure that the data is not used by other people with the same AI engine? You want to go first, Joshua?
Yeah, so we skipped this lesson today, but like if you're using Firebase, there's what they call app check. So if you're building a mobile or web application, so one thing to make sure that the access to your services or APIs are only limited to the apps that you build is by enforcing app check. So for example, you can see like the official Play Store is like Google Play Store, right? But there are APK hubs out there that are not authorized by you. So the one way to deal with protecting your data and APIs as well is like really enforcing app check. It's called Firebase app check. That's one. Another is putting some guardrails, like who has access to the API keys, who has access to production data. For my end, like I work on like an investing app, and one thing that we have established is that the only people who can access the data are those with certificates, Series 7 certificates in the US. So we can actually view live data if you don't have certificates. So I think you have to put some guardrails. Who can access the data? You can't just give someone a junior engineer, and then he drops the table. Like select all, drop table on SQL, then boom, like your data's gone. So another one is, so that's a lot. The second one has a lot to do with the policies, right? Like, hey, are your developers allowed to write in cursor? Developers allowed to use Copilot? I think you as a company have to evaluate less about the tool, but rather the policies that you have. So for example, hey, like Cursor, VS Code, Gemini have SOC 2, something like that, certification, right? Like they have strict policies about data retention and privacy, so you have to check for those certificates. And last but not the least is to really train your employees, because at the end of the day, like these users or developers are going to be the one protecting your data, and like data privacy officers and the like. So yeah, I think look for certifications, train your employees, and then just be careful not sharing your data with anyone. Yeah.
Okay, Mas Rian, Mas William, do you want to add some?
Maybe to add on that, never send, you can use the zero trust policy, never send sensitive data to anything, like even an LLM, especially the public available LLM. If you can serve LLM in your premise, that's the best. For example, in the generative AI for self-service analytics, for example, don't share the data, but share the schema. We actually only share the schema and then let LLM build a query, and then the query is run inside the service. So we don't send the whole data to the LLM because we don't know if we send it to, let's say, OpenAI, whether it's going to be consumed by them. Like, we don't know. So yeah, just put a zero trust policy, just like you put zero trust policy on people.
Mas William?
No, I think that's all.
That's all. Okay. So 5 questions, wrap up our Q&A session. So I thank you, all the speakers. I invite people who ask to join us in the stage, and there's some swags for you.
All right.
Yuk, boleh maju ke depan yang sudah bertanya.
I should have asked. Ayo Mas, let's go.
Mbaknya tadi di belakang. Yuk. So you can go first. Take a photo first. Photo. Just you first. Okay.
Mas Rian dulu, silakan Mas Rian. Alright, thank you Mas, I'm glad. Mbaknya sini, langsung. Langsung 2 kita. Oke.
1, 2, 3 lagi ganti gaya. 1, 2, 3.
Oke,
Thank you ya.
foto bersama dulu ya kali ya.
Thank you.
Let's take photo with the participants.
Lihat sana, lihat sini. Lihat sana. Ini Mbak. Gak apa-apa. Biar simetris aja, tuh kan.
Oke, kamera sini ya. 1, 2, 3. Lagi 1, 2, 3.
Oke, thank you udah bertanya. Oke, next one. I invite Mas Danang and Sat to take picture with the speakers. Oh, nggak apa-apa. Anggi. Fari. Sekali lagi menghadap sana. Oke, teman-teman bisa berdiri, merapat ke tengah, kita foto bareng ya. Just stand.
Boleh mungkin yang di sisi kanan dan kiri agak merapat lagi ke belakang. Belakangnya diisi boleh, ini belakang sini karena pasti kelihatan kok kita agak tinggi kameranya. Ya diisi ke belakang aja, yang sebelah sini isi ke belakang aja boleh. Yang sebelah sini juga boleh isi ke belakang aja, isi ke belakang karena ini nggak akan kedapatan di sini. Jadi isi belakang aja boleh, karena belakang masih kosong belakang. Mas maaf ini boleh diisi ke belakang karena di sini nggak akan kelihatan, nggak nyampe sini kameranya. Boleh diisi sampai belakang karena pasti kelihatan. Boleh. Mas boleh isi ke belakang karena di sini nggak kedapatan kamera, di sini isi ke belakang aja boleh di sini. Oke, siap, standby. 1, 2, 3. Oke, lagi 1, 2, 3. Oke, sekarang kita
Heboh ya, semua yang heboh.
gaya bebas, oke. 1, 2, 3. Sekarang kita bikin video ya.
Jangan bubar dulu ya. Jadi nanti gue bakal sebut build with AI, kalian berteriak Jakarta gitu ya. Oke, revisi. Jadi dari gua bakal berteriak Google Cloud Roadshow, kalian berteriak Jakarta gitu ya. Google Cloud Roadshow. Kurang tepuk tangannya. Ulang ya. Jadi setelah Jakarta langsung tepuk tangan ya. Oh gitu. Udah siap? Oke. 1, 2, 3. Google Cloud Roadshow. Thank you.
Teman-teman, boleh ntar diperhatikan lagi ke layar, bakal ada feedback form. Boleh dibantu diisi. Nanti keluarnya kita bisa lewat sebelah kiri, tapi feedback formnya diisi dulu ya. Ntar bakal ada, kalau misalnya udah isi, bakal bisa tunjukin ke meja registrasi buat ambil freebies kecil-kecilan. Thank you. Terima kasih semuanya sudah datang.
We'd like to extend our heartfelt thanks to our sponsors, Cloudnary and Amartha. This event is also supported by TAP. Thank you everyone for being part of this meaningful journey. Please take a moment to fill out the feedback form. Your thoughts are valuable and will help us improve future events. The link can be found on your event badge or on the event website. Thank you all for being part of this inspiring and knowledge-filled morning at Google Cloud Roadshow, Build with AI 2025, Jakarta. As we close this session, we kindly ask everyone to begin making their way out of the room, as the committee will now prepare the space for the next agenda. Don't forget to take all personal belongings with you. Once again, thank you, and see you in the next part of today's experience.